Grade 12 Maths, November 2018, Paper 2. So, this is the fourth paper on the channel. So, why did I just do that? Well, the best thing is, obviously, over time, I think the guys in 2022, those guys are going to have a party because by then there's going to be like a ton of papers on the channel. But anyways, here we are. Stats. Let's see what this stats question says. It says a cumulative frequency graph, which is called an ogive or ogive. Yeah, until today, guys, I don't know what this thing is called. Is it an ogive, an ogive, an ogive? I don't know what you call it, but this cumulative frequency graph, right? The cumulative frequency graph that follows. Oh, the frequency cumulative graph that follows, as in this one. No, that follows. What in the world? The cumulative frequency graph that follows, supposed to be a comma, shows the total number of food items ordered from a menu over a period of an hour. So within an hour, they were taking note of the total number of food items that were ordered. So what we can see here is obviously they have here cumulative frequency of items ordered from a menu. So, and then here they have the number of minutes. So basically what this is saying is in 10 minutes, there were roughly a total of about, looks like 14 orders. And then let's say 40 minutes, there were roughly a total of about, 115 orders. And then after an hour, this is telling us that the total number of orders were about 140 orders or 140 food items ordered. So that's not too bad, but best believe McDonald's will do like 10, 20,000 times better than this because, hey, McD, guys, goes down. So, unless you're not a McDonald's fan, then, hare bosso. Hare girl, hare, but, hey, McD is just one of those things, man. When you're craving, it slaps. But anyways, 1.1.1, using this data or using this graph, it says, look at the first question. Write down the total number of food items ordered from the menu during this hour. So you see here, this is a cumulative frequency graph, you see. So it means that your data is piling, you see. So what it means is the total of everything is just 140 in 60 minutes, you see. So for 1.1.1, let's go ahead and get our first mark, 1.1.1. Let's put it to the side so that everybody can see. I mean, like, come on now. 1.1.1 is like 140. That's it. It's just one mark, 140 days. Yeah, it's an easy mark, this one. Let's just move on. Write down the modal class of the data. So the modal class, you have to look at these. You see, this is a class, that's another 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 class. You see, 0 to 10, that's one class, 10 to 20, 20 to 30, going on and on and on. Now, the idea is the modal class will be the class where you will see the biggest jump. So you see here, I mean, from 0 to 10, this is the jump. You see, it's just like a few there. From 10 to 20, you see, between 10 and 20, you see, there's not that much of an increase here. But then if you check from 20 to 30, you see, from 20 until 30 there, you see this jump here. Yeah, this is quite a lot. So this may just be our model class, but let's check the others. From 30 to 40, right? From 30 to 40, let's see the jump. You see, it's just like 3 of these lines here. So you see, they're still less than this. And then here, definitely less. And then from there to there, definitely less. You see, from 50 to 60, you see, from 50 to 60, the jump is just a tiny bit there. Because you see, the food items were just being added to each other. So basically with your graph, it's just looking at the portion where it's the steepest. You see, this is the portion that's the steepest. The steepest portion. So the modal class here is from 20 to 30 minutes. So that's what you write down there for 1.1.2. The modal class is 20 to 30 minutes. I still don't know how to spell minutes actually. I always have to say min and then, it's min, so nuts. Because I always say M-U-N-I, Mooney, what? Yep, it is what it is. How long did it take to order? How long did it take to order the first 30 food items? So what that means is you want to now look at your cumulative frequency. You see, you want to check when were 30 items reached. So you see here 30 items that was reached in 20 minutes. So you see, the answer there is just going to be 20 minutes. 20 minutes, I think. Yeah, Afrikaans. I told you. Got a 51. So I was like, wow, oh my gosh, got a 51? I'm so amazing. Like, I can swear. Yeah, that's when I'm like, I can swear what? I can swear, I guess. Yeah, that's all my 51 could get me. Like, I can swear, because by now I'm just like, how much of that Africans do you remember, bro? Not so much. Just have a small casual conversation with the Tony there, we'll be able to talk and stuff, but other than that, nothing. How many food items were ordered in the last 15 minutes? Okay, so in the last 15 minutes. So you see, what we need to do is, here, because they've given us time, 15 minutes. The last 15 minutes is technically 10 and then 5. So here somewhere is where we should start off. You see, from here until 60. We need to use our table or our cumulative frequency graph and then make an estimate. So you see, we want the number of food items that are being accounted for from, you see, this is like the third line, yeah, the third line from 20. So here, the third line there. And if you check, you see, from 120 to 130, that's technically 5 pieces. So they are moving in twos, you see. 22, 24, 26, 28, 30. So basically, in the last 15 minutes, let's see here. Let me just trace. I don't have to trace anything. Well, basically, you see, this is the last 15 minutes, right? So we know that in the last 15 minutes, when the 15 minutes started, there were about 120. This is not the answer, but let's see. There's 126, right, when the 15 minutes started. And then when the 15 minutes ended, you see there's 140. So technically, this is where they started with. And then by the time the 15 minutes were over, this is where they ended. You see, so the difference here, I mean, technically it's just 140 minus 126. Calculator, where you at? Where you at? 140 minus 126. 26. 14. You see, it is 14 items. 14 items. You see, and all we did was we have to check the last 15 minutes and then trace that to our cumulative frequency table and see. When the 15 minutes started, this is what we had. So that's how much we gained, because the question said how many food items were ordered in the last 15 minutes. So this is a straightforward question. Nothing difficult there, nothing major. We should actually just be, strolling along with this nice paper until things go mad. But for now, how many marks? 5 marks so far. You see? 5 marks. Okay, the next one. Determine. Yo, guys, I should drink something. I can't keep going. Like, So, determine the 75th percentile for the data. So I think this is the one question that everybody was like, yeah, let's get to the percentiles and the quartiles and the what, that stuff. So with your 75th percentile, this obviously refers to quartile 3. However, if let's say you don't know how this whole, shandies works, this is what you need to do. So if they want us to work out the I keep doing it, the 75th percentile, this is what you do. You have to go to your data and then you need to ask yourself, what does everything add up to? So if you want to work out your 75th percentile, the first thing is you need to know how much of everything you have. You see, you have a total of 140 items. So what you do is, let's put here 1.1.5. We want the 75th percentile. So you're going to put 75 over 100, and then you're going to have there 1 plus n. So what this is going to do is, it's going to give you the position of the 75th percentile. If they had said the 30th percentile, then this number is just a 30. If they had said the 25th percentile, then this number there is just a 25, you see. So this gives us the position in our data where the 75th percentile is. Now the n represents everything we have. So let's see here. 75 over 100, 140 plus 1. The position we are getting. Yeah, you see, I already did it in my calculator because I'm like, I'm quick like that. Well, I kind of paused for a second if you noticed, because like, let's work this out quickly. So 105.75, you see. That's the position. 105.75. This is just, what is that? This is just, you see, a rough idea of the position. So you could round this off to the position at 106. So what that means is you need to go to your data. See your cumulative frequency table. You need to go to your data, your data, hey, whatever you want to call it, guys. So here we need to look for position 106. So position 106 is like over there. You see it? So then what you do with the 106 is you want to trace it to your line. Trace it, don't lose it, trace it. Got it, over there. Hey, don't lose it. Oh snap, I lost it. No, I didn't. Found it again. There we go. That's so scary. Like, oh, I lost it. I lost my position. Well, let's see. There. Yeah, and then you want to trace it down. Trace it. Hold it. Boom. There's your 75th percentile. You see what we did there? We got the position using this formula, which is a fixed formula. You see, the n plus 1 there with the 100 down here. This value will always be the percentile they're talking about. So you drop the percentile here, you get the position. So in your cumulative frequency table or data, you just want to go to that position and then trace it down using your archive. So let's see here. Well, these ones are nicely 10, you see. So let's see here. 1, 2, 3, 4, 5, 6, 7. 37 minutes, you see. The 75th percentile, if you check the question said determine the 75th percentile for the data. So the 75th percentile, you see here I put position. So the 75th percentile is 37. Me, see I was about to put a U. Me, newts, because it's min and then oots. Minutes. Minutes. But hey, I don't know how you remember how to spell your words, but hey, now I have to finesse some of these things because spelling is so fun. Not. So it says here, calculate the interquartile range of the data. Okay, interquartile range, 2 marks. It's a straightforward question. Never lose marks for questions like these because, I mean, it's the same thing over and over and over. Interquartile range is just Q3 minus Q... Whoa. Be nice. Q1. So, with your interquartile range now, this is the big idea. Firstly, well, the rule of thumb is... Okay, let me not confuse anyone. Let's just work these out individually. So, for Q3, you have a formula to work out the position of Q3. You see, 3 over 4 and then n plus 1. This is going to give you the position of Q3. The same way we work out a percentile is fun enough how you work out a quartile, like legit. So Q3, we're going to use this formula to get its position. It's supposed to be Q. Q1, we also use this formula with 1 over 4 n plus 1 to get its position. You see, position, people. You see, I'm really trying to drill this in because this does not give you the actual value. It gives you the position. And in the main channel, Bright Young Brains, yeah, I mean, tutorials on this are all there in the stats playlist. So if you haven't gone through them, you probably have. So holla. Here we are, Q3, Q1. With the positions, we just use this formula. You see, 3 quarters, 1 quarter. So the position here, well, for Q3, it's going to be 3 over 4, and then 140 plus 1. And guess what? We're going to get 106 as well, because you see the 75th percentile is Q3, because, I mean, 75 over 100, that's 3 quarters, you see. But let's not get anybody confused. It's just the same thing. You see in your calculator. If you don't believe me, I don't know who else who isn't believing me, but if you don't, let's just prove it to you quickly. Plus 1, kablamo. You see, I told you so. But anyways, the next one, let's put a 1 up there. So this is, I mean, 35. I mean, that's definitely position number 35. You know, I mean, But yeah, so Q1 we know that it is let's see, yeah, roughly 35.25, 35.25, somewhere there. So let's put here 35. Yeah, let's just round it up to 35. Position number 35. See, so in our data, our this thing. So we want two positions, right? Position number 35. Let's go to position number 35. Where are you, 35? Oh, you see, you're in the middle there. Not in the middle. Not iso. There. Yeah, you get it. So here, I need to trace it to the ogive, or the ogive, or the ogive. Yeah, ogive is definitely wrong, guys. Like, I know sometimes ogive is definitely wrong. It's not an ogive, this thing. It's an ogive. So let's see. There. And it's so blurry. Why are you blurry, man? Huh? Come on, focus. So let's see here. You see in the middle there, you can see where it is. You see 21.5. You see, so it's not guessing here. You can see it. I mean, look, we started at 35. Where's 35? There. And then we went there, and then you see it's in the middle there. I mean, it's clear, guys. You drop it, 21.5. So I mean, the actual value for Q1 is 21.5. The actual value for Q3, I mean, that one we worked it out. I mean, look, position 106, that was 37. So there. So you see, you have your Q1, you have your Q3. Now you can work out your interquartile range. You see, your interquartile range is going to be 37 minus 21.5. And then use your calculator. The easier the numbers, those are the ones that chow. You be thinking, it's easy numbers. Then you use your head. You get it wrong. Chai. That's when you know. It's chai, boss. It's over. Just, yeah, it's over. But we don't work like that. We just use the calculator for absolutely everything. You see the interquartile, and this is minutes, so this is going to be in minutes. Minutes. Fantastic. 1.2, you see, we're trying to keep things moving. You have to keep things moving in an exam. There's no time to what? Well, there's always time to celebrate. After every question, 2 marks, but gotta keep moving. Reggae. Who's reggae? Reggae works. Reggae works. I don't know how to pronounce it, but this looks like reggae works. Reggie. Oops, Reggie. Reggie works part-time as a waiter. Was up as a waiter at a local restaurant. Very strong people. Anyone that works as a waiter, very strong backbone. Respect. Always treat your waiters nicely, guys. If you don't treat waiters nicely, just close this video now and just go and pass grade off on your own. But I think you do treat waiters nicely, so hello. The amount, it says here, Reggie works part-time as a waiter at a local restaurant. The amount of money in rands he made in tips over a 15-day period is given. Wow, these guys are not so bad. But guys, come on, tip better. This is a whole day. Tip more. If you're going to eat out, tip. Yassi, don't be so stingy with your tips. Yes, like, I'm calm now. But anyway, so let's just pretend this is like 1991, you see, and this is a lot of money. So yeah, let's be positive. With these tips, right, over 15 days, you see 3, 6, 9, 12, 15. They say you calculate the mean of the data. Oh, okay. So you see these kind of questions, before you like dive into them and stuff like that, I mean, look, they're gonna ask us things like standard deviation. Yeah, so the one thing is put this data in your calculator. Put this data in your calculator. Forget what I said. In your calculator, you're gonna press mode and then stat. And then you see this one here, that's the one you go for, 1. This one is for least squares regression line and stuff. We're gonna probably use that later, but for now we need to use this one, 1. You see, you press 1 on your calculator. Let's just pretend there was a 1 there. Well, there was, but it's not there anymore. But you press 1, and then gotta put all this data in your calculator. All this data, you see all of it. You just want to chuck it into your calculator one by one. Don't rush. you have time. So you see, hey, what am I doing here? 35. You see, I couldn't see me type 35, so I typed it twice. 35, and then you can type it whichever way you want. I'm gonna go this way. You see, it looks like I'm going to make less of a mistake. But the reason why I'm also choosing to go this way, it kind of looks sorted already. So oh no, it's not. Yeah, it is. You see, there. So yeah, let's do that. You don't have to put it in that order, but you know, yeah, OCD stuff. You know, we gotta. Hey, I'm lying. The way I write. Don't even lie. Yeah, but anyways, 80 and then 80 and then 90, 100, 100, 105. Hey. Don't play those games, Baba. Don't play those games. It's 105, not 150. 110, 110, 115. You see, you must watch this calculator nicely, because these calculators sometimes they get possessed, you know, and they're like, what happened here? How did I type that number? But anyways, put in all our data, you see, then you press on, and then your calculator is ready to give you info. You see, mean. The calculator is going to give us the mean for how many marks? Let's see how many marks they're going to give us for calculator work. 2. Wow. Very nice. Die gemiddelde. Yo, what? Gemiddeld van die data. Okay. The standard. Yo, the standard of vehicle. Oh, yo. What's going on? Yo, guys, Africans. That was hard. So glad I don't have to do it anymore. But shift. So to get your mean, now you press shift. You see we pressed shift already. So let's just do it again. Shift. And then you press stat. You see stat? You press it here. Stat. And then now we want to what we want to do. Let's go to var. Go to var. 4. Where's 4? 1, 2, 3, 4. Press 4. And then kablamo. You see here, we got mean. And then here, standard deviation. Don't worry about this one in grade 12. You see, you don't need to worry about this one. Leave this one alone. You only need 1, 2. This one gives you how much data you have. You see, you have 15 numbers. So that's what n is. This is our mean. This is our standard deviation. So we want mean. So let's press 2 equal. There's your mean. 90 what? Well, it runs up to 2 decimal places. This is going to be 94.67. So where's that? Where's the paper? What number is this? 1.2.1a. The mean is 94.67. And this is rands. So yeah, there we go. Okay, guys, tip more, okay? Tip more. We want more tips. So let's see here. B says get the standard deviation. So you see these guys are giving you marks for free because, I mean, look, shift and then stat again and then var again and then 3 this time. Standard deviation 22.69, but then, you know, 2 decimal places, yeah, it's just going to be 69. 22.69. Yeah. Know your numbers in Afrikaans. That is how you get past grade 1. I think. But yeah, Mary also works part-time as a waitress. Was up at the same restaurant. Mary also works part-time as a waitress at the same restaurant. And then it says here, over the 15-day period, Mary collected the same mean amount in tips as Reggie, but her standard deviation was 14. Oh, you see? So this standard deviation is 22.69. This standard deviation is 14. So basically what that means is with Reggie's payments, they were somewhat, you know, you see here like 35 and the 125. You see, they are spaced, they are kind of far from each other. That's why your standard deviation is slightly, you know, high. Hers 14 just shows us that her tips, they were not too far from each other, as in the amount. You see, they were all generally around the same number or close to the same number. But it says here, using the available information, comment on the total amount in tips that they each collected over the 15-day period. So this one is going to be easy. You see, it's 1 mark. So they said get the total amount in tips that they each collected over the 15-day period. I mean, if the mean is the same for both of them, then it means, wait, the total amount in tips that they each, you see, each collected, not together, each of them. So obviously, if the mean is the same, it means that the total amount in tips is the same for both. So you just add up all these numbers, like all these numbers together. You add them all up. It's going to be the same for Reggie. It's going to be the same for Mary. So in your calculator, I don't think you need to see that. I mean, I'll just calculate it and then I'll just like pause and stuff like that. But what I even have to, let's just do that. Okay, so we're getting there. 1,420 rands. Let's put some R's there, just in case we have. Let's not badmouth examiners. They're listening. So 1,420. Okay, and then they said there, variation. Use your available information to comment on the variation that each of them received in day tips over this period. You see what we were talking about in the beginning? That's what they want us to. Hey, stop shaking. Come on, goodness. So here it says variation. We need to use. It says here technically using the available information. Comment on the variation that each of them received in daily tips over this period. So you see what we were saying in the beginning. The standard deviation here and the standard deviation here for Regis payments. These are the two pieces of data that tell you how spread out your amounts are. You see, this tells you that the numbers are not too far from each other because you see your standard deviation is low. Your standard deviation is higher than the 14. So Regis amounts are more spread out than Mary's amounts. So for 1 mark, that's basically the information that we need to communicate to our examiners. Literally that. You put it in those simple words, nothing fancy, nothing complicated. Why did I put C there? Hey, bye. It's A here. Always maybe label your things correctly, guys. No, always label it correctly. Let's change that. It's A. So B, we need to say that Regis payments, Regis tips are more spread out, than Mary's payments. Mary's, forgot the R, my bad. Mary's tips. Yeah, why do I keep saying payments? Regis tips are more spread out. You see, it's spread out, guys. Spread out. Sorry, in case you can see that. Why am I always rushing? It's funny how I rush. And then when this thing is done, it's like, what? 5 hours, 6 hours. You're like, hey, okay. That escalated. So yeah, Regis tips are more spread out than Mary's tips because you have to tell them why. I mean, it's 1 mark, yes, but if you know your stuff, it's going to be easy to tell them why. The reason here, because his standard deviation is higher than Mary's. There we go. Fantastic. You say that, you move on to question 2 because question 2, best believe it's waiting for you. It's waiting to get smashed. It's waiting to get thrashed. Okay, let's stop talking. It says here, a familiar question among professional tennis players. Oh, are you a tennis player? I'm not a tennis player. You guys, I played tennis like once or twice, but I think it's hard. Yo. People that can play tennis, hey, y'all have some serious hand-eye ball coordination type of thing going because it looks so simple, but hey, it's hard. If you play tennis, hey, holla. A familiar question among professional tennis players is whether the speed of a tennis swave or a swave. Yo, guys, dude, it's a tennis serve, bruv. You're gonna get us dissed with the tennis players. Goodness, yeah. It says a familiar question among professional tennis players is whether the speed of a tennis serve in kilometers per hour depends on the height of a player in meters. It says the height of 21 tennis players and the average speed of their serves were recorded during a tournament. The data is represented in the scatter plot that follows. The least squares regression line is also drawn. So you see, as we are speaking right now, I'm not even looking at the scatter plot. I'm not even looking at the data. I don't know what it looks like. But this is my hypothesis. I'm going to say the taller a person, the faster the serve. Because, I mean, with a tall person, it means that when you stretch your hand, the... what do they call it in physics? The moment. Yes, the moment is going to be more, I think. Guys, this is not a physics class, so if I say things that are wrong, don't come and kill me. But in physics, like AS physics, you have what you call moments. Now, the thing is, I mean, technically, the taller a person is, the moment is going to be slightly higher. So the force is going to be slightly more. So that's my hypothesis. The taller the person, the faster this ball is going to be served. Let's see what the data says. Okay, we're about to reveal the data. You see, this is not the data. We're going to flip it over and... Hey. Okay, yep. You can see it yourself. This is what's happening. You see? You can see that the taller person, I mean, clearly the faster the average serve. I mean, we can see it. That was my hypothesis, but I mean, the data is suggesting that. So, yay. Okay, yeah. That was a pointless exercise, but okay. We're here now. So with this said, they've given us a scatter plot, and then here they're saying, write down the fastest average serve. The fastest average serve speed in kilometers per hour achieved in this tournament. Well, the fastest serve, technically we need to look at this now. Which one is the highest from top to bottom? Yeah, this one. Okay, we gotta zoom in nice and, and zoomed in. And then we need to check nicely. So technically this is going to be 151 because you see 150 and then 1, 2, 3, 4, 5. So you see this is 151. No, 251. What am I saying? Yeah, my bad. 251. Wow. I'm legit two people in one sometimes. Because the one person will like say something and then I'll legit be like, no. And then I'll like change. And then I'll be thinking to myself, what the hell just happened? Am I still normal? And let's just say I'm still normal. That's what I tell everybody. But it's true. Hey, yeah, this is getting more and more awkward. I'll just stop talking now. It says, the next question says, consider the following coefficients. The following correlation coefficients. Consider the following correlation coefficients. A, B, C, and A, B, and C. So with these correlations, right, they say what do they want us to do with these correlations? Which one of the given correlation coefficients best fits the data plotted? Well, I mean, this one is also a pretty straightforward question. But firstly, our data has a positive gradient here. I mean, you see, so we can rule out this one. Wrong. You see, lies this one. Lies of the devil, this one. What is that negative doing there? It's a positive here. You're putting negative. You can't fool us. B, out of the picture. A and C are both positive, which is fine. But then when you look at our data, you see the way our data is set up. This number here is not accurate because this number states that yes, you have positive correlation, but then your data will be usually nicely or relatively close to each other. That's what this 0.93 basically states. Because remember, your value for R will always be a number that is bigger or equal to -1 and smaller or equal to +1. You see? That's your value for R. But then, you see, this is close to the positive side. So your data says, this basically says that the data should be like close to each other nicely and positive and all that. But our data is not so close to each other. But it has positive gradients, so C qualifies. So hey, I want to tick. C is the correct answer there. You give C as your answer. You move on. That's 2.2.1. So just make sure that's correct because your examiners are gonna yeah, man, they're gonna do the things and you're not gonna be very happy. So use the scatter plot. Use it to use the scatter plot and the least squares regression line to motivate your answer to 2.2.1. Okay, now we have to motivate our answer. This question is so funny. Motivate your answer. It's like, ma'am, what should I do? Should I get like a cheerleading squad? Bring them to the exam? And then whenever I get to these questions, I just go, hey, cheerleading squad, do your thing. Motivate your answer. Motivate your answer. Why does the answer need motivation now? Hey, is it depressed? No, our answer is fine. Why do you have to motivate it? Hey, but it's fine. We'll motivate our answer. So, Asia. Well, what they mean is they want you to give, what do they want to do? What do they want you to do? They want you to now use data and facts to give the reason why you chose C. But you see, they'll use words like motivate your answer. Hey, yeah, English. Yeah, it's something else. So here we have to use our least squares regression line to motivate our answer. You see, I usually motivate myself, by other things, but hey, it's fine. 2.2.2 says we should motivate this answer. Let's motivate it, guys. Come on, let's go. So firstly, we're just going to say what we were saying before we chose an answer. So what we can say here is the least squares regression line, the least squares regression line has a positive gradient. However, you see, however, I should put this somewhere. Furthermore, yeah, let's do that. However, the data is not close to each other. Right, this would easily get you your mark, but I'm trying to be funky, so let's put here furthermore. Furthermore, sir. Furthermore. Yeah, I see now I've put myself in trouble because I'm like, what are you gonna write next? So I wrote about the positive gradient. I wrote about the data not being close together. Furthermore, yeah. Let's say here, furthermore, the line or the least squares regression line, the least squares regression line is not that steep. You see, this should get you your mark. If it was 2 marks, this would be perfect. If they were being funky, which is weird, which they probably wouldn't, if they wanted like 3 marks, this should be fine as well. Let's see. The least squares regression line has a positive gradient. However, show them you write English essays, boss. However, the data is not close to each other. And then you throw in another one. Furthermore, the least squares regression line is not steep. So, I mean, if you want to be weird, okay, no, let's stop it. I was going to say therefore, but hey, what am I going to say after that? I already got my 1 mark, so hey, moving on. What does it say here? What does the data suggest about the speed of a tennis serve and the height of a player? We were talking about this in the beginning. 1 mark. Well, remember, that's hypothesis. That's we say it in the beginning. Dude, what the hell? That hypothesis. The hypothesis that we mentioned in the beginning. So if you do physics, you already know what hypothesis is. If you don't, well, a hypothesis is that thing that you think before you actually prove it. So it's just like, yeah, you see, like, yeah, guys, yeah, now I can't explain English. But a hypothesis is basically like a statement that you make before you actually perform an investigation or an experiment. So you see, before I actually had data for what we were talking about, I had said that the taller person is going to be the faster their serve is going to be. That was a hypothesis because it was a statement that was not backed by data. but then it was a statement made before I actually got the data to supplement my statement, to actually state whether or not my hypothesis was correct. Nailed it. So, what was the question saying? What does the data suggest about the speed of a tennis serve in kilometers per hour and the height of a tennis player? So our data clearly suggests that the taller a person is, the faster their serve is going to be. That's what our data suggests. The reason why our data suggests this is because you can see here, as you are going towards the right of the heights, your points are generally getting higher. You see, like this one is low because what? Low height, low speed. Look at this one, tall, high speed. You see, look at this one is just an outlier, almost, maybe not, but it is what it is. This person is probably buff or something. But anyways, you see here, you can see the trend here. The higher, the taller person is, the faster their serve is. So that's what you're gonna say for how many marks are you offering us there, sir? 1. Okay, that's fine. Take the 1 mark. It's okay. Yeah, it's okay. That 1 mark will save us, Shem. It will save us. So 2.3, you're just gonna say the taller a person, the higher a person. The taller a person, guys. The taller a person, the faster their serve. The faster their serve. Yes, their serve is fast. You see, I think if English was not like your first language and you said stuff like the higher a person, the faster the serve, it's maths, you're gonna get that stuff right. You're gonna get it right. Nobody can come to you and be like, this is not grammatically correct. Hey, it's not English, this. It's maths, okay? There's no spelling mistakes as well. So you can be rest assured that you'll always get your marks for some of these things. It says here the equation of the least squares regression line is this. Okay. Our least squares regression line, you see they've drawn it. They're saying this is the equation, but you see this equation is not complete. They say to explain why, in this context, the least squares regression line cannot intersect the y-axis at 0 coordinate 27.07. Okay, let's investigate. The police must investigate. That was random, but if you know what I'm talking about, if you know, you know. If you don't, I'm sorry. But let's see here. They say it explain why it cannot intersect the y-axis at 0 coordinate 27.07. So what they mean is, you see, this is almost giving a vague idea of what an equation of a straight line looks like. So roughly speaking, this would be the y-intercept. But then they're saying explain why the graph cannot have this as a y-intercept. So you don't even need your data for this one. You see, well, the blunt answer is, you see here, x. Let's see what it is. You see, x represents your height. Y is representing your serve. You see, x, y. So x is height, y is serve. So, let's see here. A y-intercept value would be telling you the speed of the serve together with the corresponding height. You see, this would tell you like the speed together with the height. Now, the thing is, a person cannot be 0 meters tall. Come on now. Yeah, I'm not even going to laugh about this one because it's like, 0 centimeters tall. No. So that's the blunt answer for 2.4. You're just going to say there, you're going to say what this indicates. This indicates that the height of a person would be 0 and then their serve would be 27.07. But then this is not possible because you cannot have someone that's 0 meters tall. Come on, question. Come on. But some of these questions, they're the ones that will be like, that question, Joe, you saw it. But let's just tell them. So firstly, 0 represents. So I spell represents, right? This is an R, by the way. Yeah, I don't know what is happening there. I was about to put a P because when I was saying represent, I was already at the P, but I'm starting to write, so I was at R and ish. Yeah. Or this 0 represents the height, and then 27.07 represents the Serve speed. The taller, the faster. Wait, the taller a person, the faster the serve. Yeah, that's fine. 0 represents the height. 27.07 represents the serve speed. You see. Full stop. A person cannot be 0 meters tall. Amen. That's it. That's all you say for 1 mark. They give you all your marks for this. You're safe. You're good. You're gone. So you remember your least squares regression line. All it does is, yeah, it's basically just like a straight line. You see the data here for x is height. The data for y is serve speed. So that's it for that question. You give them what they want, and then you move on. So we got to move on to question 3 now. We are done with question 2, so let's move on to question number 3. Question number 3. So the weirdest thing when I looked at this question, I was like, question 3 looks scrumptious. That was just the weirdest thing ever. Because you can see here 2 marks. Wait, 2 marks, 2 marks, 2 marks, 2 marks, 2 marks. I'm like, those are going to be like straightforward questions because out of 2s anyways. But it's like 12 marks, no, 10 marks freely given. Hello. And then there's like what, 5 marks here, 3 marks there, 4 marks there. So guys, analytical geometry, just destroy, just get all those marks. No, what do you call it? Take no prisoners. Sound like such. Yeah, never mind. Moving on. In the diagram, K, there is K. K is -1 coordinate 2. N, where is U? There. We have K and N. And then they say these are vertices of the triangle KLN. Interesting. And then it says here LKN is equal to 78.69. No. That's the wrong way to read this number. Very wrong. You want to read this number as 78.69. You see, any value after a decimal, you always read it individually. Because imagine you had like many decimals here, you see. How would you pronounce that number, you see? Or how would you say out that number? So always read values after a decimal, one after the other. KL intersects the x-axis at P. KL intersects the x-axis at P. And then it says here, let us see here. So, there we go. Don't be blurry. And the inclination, no, dude, what the hell? Where did I stop? KL is produced. Yes, KL intersects the x-axis at P. And then they say here KL is produced. Yeah, it's just a straight line going to kingdom come. And then it says here the inclination of Kn is theta. The inclination of Kn is theta. And then it says the coordinates of M are... Where's M? Oh, wow, M. So, such a strange point. Just stay in the Cartesian plane, floating. Okay, sharp M. You are probably an introvert. So this is M, right? So all these pieces of information given, they... Let us see here. For 2 marks, they said calculate the gradient of Kn. You see what I was saying? I don't even know if you're going to... I think this is one of those questions you're going to just skip through. I mean, like in the video, obviously, like, this is easy. I can do this. Let's just, go type of thing. But totally, of course. I mean, like, I sound like Majimbo there. Of course. That Kenyan comedian is that bomb.com. But anyways, 3.1.1, they said get the gradient of Kn. So we're just going to use, we can use the gradient formula. Yeah, because I mean we have two coordinates given there. So it's like literally a point blank gradient formula question. It's like, wow, some examiners are actually quite friendly. They're actually quite nice. Such nice people, just giving us free marks here. Like, oh my gosh, bless your souls. So there's N here. 1, -1. So this is like x1, y1, x2, y2. This is like -1 minus 2 because of our formula. -1. What is this? What is this? It's a 1, boss. It's a 1. This is a -1. Okay. -1 minus 2. 1 minus a -1. You see 1 minus a -1 there. And then this is obviously -3 over 1 plus 1. That's 2. Negative gradient. Yes, that line confirms it. So straightforward question this. 2 marks. You move on. You celebrate if you want. And then, yeah, you just keep going. I mean, you know, celebrate at the end. Well, you can also still celebrate during the paper, you know, because gotta keep the positive juices going. It says here the size of theta, we need to calculate the size of theta, the inclination of Kn. So here you can obviously, I mean, you're just going to use the normal tan formula, the normal tan formula. So here I'm going to write tan theta, right, is equal to m. But then what you want to note is, you see, when we're going to use this formula, we're obviously going to say tan theta is equal to our gradient, which is -3 over 2. So the funny thing is, to be safe, I would always write this formula with like a random variable here and then solve that random variable first, because I mean, you never know what your calculator is gonna pop out, you know. So shift 10 -3 over 2, shift 10 -3 over 2. So in your calculator, that's obviously giving you -56 point something. So you see here, your value for theta is obviously, I mean, an obtuse angle, and your angle should always be a positive value. So I mean, with questions like these, all you do is, I mean, I keep saying I mean. So all we do is, in our calculator, whatever we got, we're just going to say theta is equal to 180 degrees. Well, technically, let's see here, 180 degrees minus 56.30993247 degrees. And then if you put all that in your calculator again, you're going to get, let's see here what we're getting. Let's see, 123.69. But then your papers mainly want you to round up to 2 decimal places anyways. So I mean, if you round off, well, this is actually rounded off to 2 decimal places. So what am I about to do? You were about to lie, weren't you? Well, I stopped myself in my tracks. So theta is just equal to positive 123.69, because I mean, this is an obtuse angle anyways. And you see, in your calculators, you won't always jump to getting the value for theta immediately, so just have a look out for that. So here, I was about to read in Afrikaans, and that was gonna be terrible, because yeah, the boy only managed like what, 51 for Afrikaans. Yeah, I was happy, guys. Like I was over the moon, because Afrikaans plays no games, guys, takes no prisoners. Says here, show that the gradient of KL is equal to 1. Where's KL now? ISO. We should show that you are equal to 1. Well, I mean, we could definitely do that. I mean, it seems like a pretty straightforward question. So if we're going to show that the gradient of KL is equal to 1, let's see here. What do we have when it comes to KL? Let's see. Question 3.2. Show that the gradient of KL is equal to 1. So if we're going to show that the gradient there is equal to 1, well, technically what we can do is we can work out the angle of inclination here. You see, and then use that angle of inclination to work out the gradient here using our gradient formula. The reason I'm thinking that way is because, you see, we have a value for theta here already. It's 123.69. So automatically we have this value here, because, you know, angles on a straight line. And then the moment we have this, or rather, we don't even need this. I mean, like, why are we taking the long dry, boss? Just use this one. Exterior angle is equal to this plus this. Because remember, all we want is this angle here, actually. That's the angle we want. That's all we want, really. So we're going to say here, what can we say? Theta is equal to, so what's this question? 3.2, right? Huh? Yeah, 3.2. So for 3.2, we're point blank, that's going to say theta is equal to, what do we call this angle? PKN. PKN plus KPO. KPO, you see. KPO. It's equal to those two put together. Reason is exterior angle of a quad. See, you see, it all happens all the time. I'm talking, I'm thinking, I'm writing, and then the writing always gets it. EXT, exterior angle, is what I wanted to say. Exterior angle of a triangle. And the way I hold a pen, yo, it's so loose. Yo, my nails! Don't look at my nails! Oh my gosh, my nails! Dude, what the hell? But yeah, you see the way I hold a pen, it's so loose. So yeah, it's crazy. It's crazy. And on camera, these nails look so dirty, but they're so clean. But it's like this light, this useless light does not even work. Hey, enough of that. Exterior angle for triangle. So it just means that theta, which is 123.69, it is equal to, bring them closer, bro. Why you gotta have them so far? Bring them closer. 123.69, which is this angle here, it is equal to this value plus that value, which is just this value plus this value, which is just 78.69 plus KPO. There we go. So this goes over. This is going to be 123.69 minus 7869. This is KPO. Let's see. So in our calculator, let's see what this is going to give us in our calculator. So the angle here is equal to 45. KPO is equal to 45 degrees. You see, so we have proven that this angle here is equal to 45 degrees. So now we're just going to use our tan formula to show that if that angle is equal to 45 degrees, the gradient there has to be equal to 1. So just going to put here tan 45 is equal to the gradient of KL. You see, and I mean, yeah, I do abuse this handwriting. I'm sorry. It's a habit. It's a terrible habit. I mean, look at how bad that looks. Like, I mean, can anyone even see that's a 10? Like, wow, guys. This is proof that I used to give as examiners the worst time ever. Like, what the hell? But the thing is, the answers would just always come out right, you see. So they have no choice but to mark it. Yeah, I'm not trying to... Yeah, bad handwritings are just bad. But anyways, this is just going to give you a 1. And then obviously the gradient of KL is just a 1. And you've proven it. So you move on because there's how many marks? 2, you see. That's it. Not bad. Determine the equation of the straight line KL. Wow, these guys are in the business of giving away marks. But you see, like questions like these, right? Analytical geometry and everything. This is where you bank time. You know, don't waste time on these ones. Also, don't lose out by just, making useless mistakes. So what I mean is, here we already have the gradient of KL, right? I mean, it's equal to 1. So y is equal to x plus c is our equation. To get c, we obviously just need a coordinate that the graph passes through, which is just k there. So y, we can put it 2 there. X, we can put it a -1 there. C, and then the 3 go, the c go. Oh, you see, my mind is too much. I was literally, the 1 goes over, right? It becomes a 3. But I'd say 3 already. Like, yeah, too much sugar in this system. I actually don't have much sugar in my system, but I always have natural sugar, I guess. So c is equal to 3. So here I mean, therefore y is equal to x plus 3 is the answer. 3. Yeesh. I should become more serious with my life. Like, what the hell is this? Y is equal to x plus 3. So the next one says it is further given that Kn is equal to Lm. Where is it? Let's see it. Kn is equal to Lm. Okay, Lm, we see you. Finally in the mix. I'd forgotten you're there, M. Like, totally forgotten you're there. Like, don't get me wrong, but not forgotten, bruh. So they say this whole line here is equal to this whole line there. They told us. I mean, they told us, you see. So, I forgot this. My bad. Calculate the length of Kn. We should get the length of Kn. Distance formula. Hey! These guys were giving away marks. Like wow, guys. Hey, these guys were having a party. So, yeah, I mean the 2018 guys. You see, the November 2018 guys had a party with question 3 because distance formula here. We want the distance of Kn, right? And it's so blurry. Don't be blurry, camera. So the distance of Dn or Kn, where is Dn coming from? Kn, it is equal to the square root. You can start with x's if you want. So I just say x2 minus x1 squared plus y2 minus y1 squared. So if you swap these two around, it's fine. Just swap these ones as well. If you swap the entire brackets, that's also still fine. Your answers will always come back the same. You see, that's the beauty with the distance formula. So let's just zoom out and see what our values for n and k are. So k, we got the -1 and 2. N, what you got for n? N is n, boss. N, make sure it's at least visibly n. N is 1 coordinate, -1. You see, so I mean we can label this x1, y1, x2, y2, your choice. And then what you're gonna do now? Well, let's just throw those in there. Get those 2 marks real quick. X2 is 1, x1 is -1, and then y2 is a -1, y1 is a 2. Then you square it, okay, class? I never. If you ever see me in a class, yeah, you're seeing the wrong person, guys. Because classrooms are for teachers that have a thick backbone. Like, you're out never. So here, 1 plus 1 is a 2. So this is 2 squared. -1 minus 2, that's like -3 squared. And then here, we got like 2 squared, which is like 4. -3 squared, which is like 9. Okay, that's like square root of 11. 13, boss. Square root of 13. Where is 11 coming from? Like, tell us. I'm thinking of that meme where there's like a teacher and then a cat. And then the teacher is like to the cat, the teacher asks a question. So I'm thinking here, if I'd put an 11 there, obviously the meme would have been like, where did you get square root of 11? And then, yeah, I'm off ramping and I kind of blew that one. Like, yeah, leave jokes alone. Let's see, yes, 3 point. Yeah, this was pretty straightforward, square root of 13. And they said they didn't say anything about, well, I mean, we couldn't leave it in third form. I prefer leaving stuff in third form, but if you don't want to leave it in third form, this in your calculator to 2 decimal places, that's just giving you 3.61. If you want to put it like that. So I just like using thirds. But anyways, 3.5 says K, it is given. It is further given. Okay, guys? Further information. And why am I saying okay, guys? Because, I mean, you're watching this on your own. So, okay, person. I was about to say, yeah, whatever. Let's just leave that one. So, it says here, it is further given that Kn is equal to Lm. Okay, they told us that they are both equal to square root of 13. Square root of 13, square root of 13. Fantastic. And then they say it here, you see, I want to check the mark allocation, 5 marks. Yo, you're na, papalele. So this is like calculate the coordinates of L. It's a 5-mark question. Where's L? There is L. I think I know what we're going to do. Well, for 5 marks, I mean, they want us to get L, right? And L, remember, L is just 2 values, X and a Y value. Hey, people want to see. Don't cover what the people want to see. There. L is just X and Y. So X and Y, we know there are 2 variables. So we can work X and Y out simultaneously, you know. Now, the thing is, what thing is? Well, the thing is, I mean, if you can work out these 2 simultaneously, then if you can work out X and Y simultaneously, it just means we could use the gradient equation of KL and we can use the distance equation for LM. You see, use those two. We can use those two to get two equations, and then just what? Yeah, and then just work them out and see what we end up with. So let's try that out. We're going to use the gradient of that line, and we're going to use the distance of that line to help us. You see, the gradient of, oh, what? Yeah. Whoa. Yes, I'm going to put K and L in the gradient formula. And then I'm going to put L and M in the distance formula. And then I'm going to work them out simultaneously. Okay, let's see how that goes. Wish me luck, or let's wish each other luck. I don't know if you've done this paper, or if you're doing it while doing this, or watching this while doing it. I have no idea. But anyways, we have K and L here. L and K. See, I always miss the line. This as a distance, we know it is equal to... Whoa, I need the gradient of this one. The gradient of KL, we say that this is equal to 1. So we know that 1 is equal to y2 minus y1 over x2 minus x1. So I'm referring to the gradient of KL here, you see. The gradient of KL, we know it's equal to 1. But the gradient formula, if you think of K and L... why do I keep making the stupidest mistakes? I think sometimes when you're going through a paper and you're talking, yeah, guys, I'm telling you, it's so easy to make mistakes, because one portion of your brain is talking, the other one is trying to concentrate, and then the other is trying to figure it out. So yeah, it's so easy to make mistakes and write the dumbest of things. So this is -1 and 2. So let me label this x1, y1, and then this one, well, technically we don't have any coordinates, so let's label this x2 and y2. And then we should just remember that L is going to be 2 for when we work with the distance of LM. So let's just actually label this 2 and 2 so we don't forget. So here in our distance formula we would have had here, in our gradient formula we would have had here 1 is equal to y2 minus 2, and then would have had here x2 minus -1, so it's a plus there. If you want to simplify this and have one variable isolated, I think that's a good idea. So let's multiply the bottom by x2 plus 1, ching, and then here x2 plus 1. So here you would have x2 plus 1 times 1, that's just x2 plus 1. This is like y2 minus 2. So in terms of which one we're going to isolate, I mean, I think it's all one in the same thing. Might as well isolate x2 because, yeah. Well, let's just isolate y because it's nice to work with x's. So let's take the 2 over. And you'll see what I mean right now. 2, let's take it over. It's going to be 1 plus g. We got y. So y2 here, tiny 2, is equal to x2 plus 3. Okay, fantastic. Don't mind these tiny 2's there. Don't mind them. So equation number 1, kaching, done. So let's use the distance of LM now. The distance of LM, we know it is equal to square root of 13. But we said what we also know is that LM, we can put that into the distance formula. You see, with this label, there's like x1. This label, there's like y1. You see, so in our distance formula, I mean, like, square root of 13 would need to be equal to, let's see there, it would be, let me just write it out here. So we have L, which is x2 and y2. We have M. What is M? Give us M. -3 and -5. Yeah, -3 and -5. So we can label this x1, y1. So I'm going to say here, let's see, 2 minus, this x2 minus this one. Well, let me just write out the formula so that nobody gets confused for some reason, because, it is what it is. y2 minus y1, that's what our next thing would be. And then let's just drop the values now. This one, we don't have anything for it, so you know what you do? Nothing. You just leave it, x2. This one is, well, it was subtracting a -3, so it's going to be a +3. Because a negative and a negative gives you a plus. Squared, and then here y2 minus -5, so that's going to be a plus as well. Square that, and then here we go. So simplifying this, we can square both sides, you see. Square iso, swing, 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 swing. And then this is like 13 is equal to x2 plus 3 squared. Ooh, plus y plus 5 squared. So I would recommend not foiling as yet. Like, I think at this point we can already label this equation 2 and then just drop x or y in there, you see, because hey, if you foil this, you're going to have many x's, and many x's was a bad idea, pun intended. So this is 13, right? So let's drop x. No, we have a value for y, so I have to drop y there, and you see this is y2, so let's put a tiny 2 there. So let's see here, 13 is equal to this x2 plus 2. Let's just leave that for now. And then where y2 is, we're just going to drop here x2 plus 3. So let's put here x2 plus 3, and then that's plus 5 squared. And then this is also squared. Forgot the squared, remembered it now. So here it's just going to be x. Let me just write this as x now, you know, like, yeah. But let me just keep the 2 there to show that in an exam, you also need to just keep that 2 there. Just don't let it distract you, or don't, if you forget it by mistake, I mean, you see, like here, that's also not a big deal. Just keep that in mind. So here now we just need to FOIL out. So let's see here, this is just going to be x plus 2, x plus 2. I'll put the tiny 2's after. I mean, like, let's hope I don't forget them. Yeah, plus 2, like that. And then here, this is x times x, which is x squared, plus 2x plus 2x plus 4 plus x squared. Was this? Yeah, this is a plus from the beginning. That and that is that and that is 8x, and then another 8x, and then another, and then a 16 there. You see, such tiny 2's here, but these tiny 2's, guys, I just put them there, it's fine. They're not a big deal, but hey, we don't want trouble with the examiners, us. Because some examiners are mean, you know, they'll just be like, you forgot the tiny 2's, 0 marks. Kidding, that's just too much, but yeah, we're here anyway, so might as well just put them. So here, these are like terms. Ooh, forgot the tiny 2. X squared plus x squared, that's going to be 2x squared, obviously. And then here we have like terms again, 2 plus 2 plus 8 plus 8. That's like 16, 17, 18, 19, 20. 20 people. 20 x, and then 4 plus 16, that's like 20 as well. Ooh, okay. Keep my tiny 2 over there. And then trying to keep out trying to keep an eye out for like silly mistakes. And if I have made one silly mistake here, I'm only gonna see it later. But you're like super smart, so you probably saw it. But if it's not there, then it's not there. Let's see here. 13 goes over. That's gonna be like 2x with the tiny 2 there squared, plus 20x with this tiny 2 there. This tiny 2 is, just remember, all coming from how we labeled it, you see, because there's x1 and y1, x2 and y2, you see. Yeah, don't forget. If you had just labeled it as x and y, I think that would have made life so much easier. Like, why didn't I just do that? I feel so dumb. So here, 20 minus the 13, that's going to be like a positive 7. And then here, we got to use the z quadratic formula. And I don't want to lie, right? But let me check here if I did not make a mistake, because I feel like I made a mistake. I knew it. Guys, this is the oddest thing ever. Every time I feel like I've made a mistake, I would have made a mistake. How weird is that? Because it's supposed to be a 3. It's supposed to be a 3. Oh my gosh, 3. And then here would also be a 3. And then this would be like a 3. And then this is like a 3. So it's 6 plus 16. Yeah, mistakes, guys. Mistakes are very real. So always look out for them, because, yeah. Let me actually pause and double check my calculations nicely. Yeah, I'm sure you were laughing. You're like, what? 16? 2? 3? I'm sure you're like, this nigga, what the hell is going on? Maths, guys. I always say this. Maths is a scam. Like, what the hell was that? Like, how in the world was I getting 16? Where did I even get the 2 from? So, I mean, I think this is just evident that, yeah, I think it's clear that with maths, right, and your papers, like when you're writing, your brain will think of the weirdest things and it will just throw it there. And if you don't double check, hey, you'll finish, Baba. You'll finish, you'll hand in the paper, it will come back, and then you're like, what? I put a 16, but 8 times 8 is 64. And then I put a 2, but it was a 3. So, yeah, guys. I mean, I think that's why these are good and why they're best unedited, because you will see that there are some mistakes now. Like while you're writing your exam, there are some mistakes that will come out of nowhere. It's like the devil. It's like the devil sitting next to you. And then just going, write a 16 there, 16. Then you write a 16, write a 2 there, 2. And then you're like, but wait, who said that? Hey, yeah, nah, it's crazy, it's hectic. But yeah, I fixed my errors. I've corrected the error of my ways. So yeah, you see this was a 3, I'd put a 2 there. Crazy. I'd put a 16 there. Crazy. See, it's all this talking. But I can't be quiet. I have to explain to the peoples what's going on, to the peoples. Yes. So let's simplify this. So this is going to be x squared plus x squared, right? Which is going to be 2x squared. I'm done writing the tiny 2's there. That's just nonsense. That's really not necessary. And then here, 3 plus 3, that's how much? 6. Okay, 6 ne? Plus 16. How much does that give us? I must think carefully here. See, I don't want to make silly mistakes again. I'm tired. It's 22. Yeah, plus 22x. And then 9 plus 64. What is that? 73. Yeah, I think it's 73. Then I have a 13 here, you see. And then this is going to be 2x squared plus 22x. 13 goes over, so this is going to be plus 60, you see. Then you put a 0 there. Whew. Yeah, it's rough. But then this we can use our quadratic formula to work it out. But before using the quadratic formula, you could divide by 2 everywhere. So you'd have here, this whole thing here, divide by 2, divide by 2. Well, you can divide 0 by 2 as well. I mean, it's totally fine. It's totally up to you. Well, yeah, I mean, just do it, but it's still 0. This is going to be x squared. This is going to be 11x. This is going to be 30. And then x is equal to minus b plus minus b squared minus 4ac. X is equal to minus b plus minus b squared minus 4a. Concentrate. Don't make useless mistakes. Concentrate. Yeah, I'm actually gonna stop laughing on this one because this is just getting out of hand. Where's my 2a? Yeah, I'm actually not happy with myself right now. Kind of disappointed, like, dude, what the hell? I think it's because I'm kind of distracted. It's just so much on my mind. It's like, Levi, what's bothering you, bro? Talk to me. Hey, guys, it's fine, guys. I'm okay. I'm okay. I'm not depressed or anything. It's just that, it's a Monday today. And, hey, yeah. Let's see. In the calculator, this is going to give us -6. And then this is going to give us x is -6. Or, let's see. Well, 15 and 2 didn't give you 11. What factors of 30? Yeah, I mean 5 and 6 obviously. So you see, this has to be a positive number. So I mean, when you factorized, whichever way, calculator here is giving us a -6 and a -5. Okay. So obviously we have to choose an x value. So you may be thinking to yourself, do we choose one of them? Do we choose both? I mean, what you do? Well, in this case, because they're both negative, you choose both. I mean, you have no choice. You really have no choice. So these are both x values for for L, right? So you see right at the top here, when things were still nice and, okay, none of this is nice. Like, this is just all messy. Like, look, you see here with my quadratic formula, I forgot to divide by 2a. It's fine, guys. It's okay. Like, yeah. So we have x. two of them. So here we know that y2, if you want, is equal to x2 plus 3. So that's one of our equations. So here we know that y is then going to be equal to -6 plus 3. So here y is what? -3? Yeah, -3. So here basically L, this is one of your options. It's going to be -6, coordinate -3, or your L is going to be -5. Let's get the other y. Y is equal to, what's the formula? Y is equal to x2 plus 3. That sub 2 thing is so irritating. It's like, hey, I regret doing it. So yeah, but those are some of the things you don't need to stress too much about in an exam. They really mean nothing much one way or the other in terms of, where you get your marks and everything. So there, -5 plus 3, that's a 2. -2. Pay attention. Come on, man. Come on now. Hey. So yeah, L is -5 and -2. So you see, these are the two options for L. How many marks were they offering here? 5. Guys, 6, Nyana, 7. This is... Look, it's a whole page. It's a whole page. It's fine. It's fine, ma'am. It's fine. 5 marks is fine. We'll take the 5 marks. So, let's just move on. Finish up with this question 3. 7 more marks until it's done. Calculate or determine the coordinates of L. Okay. How many marks for this one? 3. Okay. Yeah, this one, you see, it has to be a specific value for L. But let me remove this paper. This one. Take it away. Bring it. Keep it close, just in case. Just in case we need it. Keep it close, boss. So here they said, determine the coordinates of L. So let's just see where L is. Yeah, we have 2 values for L, 2 options. See, these 2 options. You see them? See them? Do you see them now? Do you see? Yes, you see them. So here it says that we should determine the coordinates of L. Where's L? There's L. Determine the coordinates of L if it is given that K, L, M, N. It is given that these 4 points is a parallelogram. K, L, M, N. Okay. K, L, M, N. If it's going to be a parallelogram, we have to find the coordinates of L if K, L, M, and N is a parallelogram. So I think this makes things very easy, because if that is going to be a parallelogram, this has to be parallel to that, you see. So we just need to work out, well, do we have the gradient of Kn? I think we did. Yeah, there was a question that asked us to get the gradient of Kn. Where are you, question? Where are you? We are wanted. Yeah? Where did I put it? Let me try and find that paper. Let's check behind here. Kn. Where are you? There. There is Kn. Yeah, we have the gradient of Kn. We have it. So you see, we have the gradient of Kn. It's -3/2. So this gradient of Kn, we just have to check which coordinate of L, right? If we put it into the gradient formula, will give us, we want to check which coordinate will give us a gradient of -3/2. You see, because we just need to get the gradient of LM here using our 2 coordinates that we worked out. You see, we have 2 options as coordinates. Where are they? I think it's at the back of this paper. So many papers. This is the bed. Yeah, I see why I never write behind stuff, because it's so useless. You see, we have 2 options for L, right? So we have to test them both to see if you throw them there on your sketch. If you throw these 2 values there where L is, we want to check which of them will give us a gradient of -3/2, because for this shape to be a parallelogram, this line has to be parallel to that line. So let's just do that quickly in our gradient formula. You see, so yeah, it's a mess. 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 I'm not a singer. So let's see here. LM. We have 2 options for LM. There is LM that is potentially that one. That's the one for L. -6, and -3. Let's label this x1, y1. M, we know it's like what? Where's M? M, where are you? There's M. -3 and -5. -3 and -5. -3, -5. And then you got here x2, y2. So let's get the gradient here quickly. Let's see if it's going to give us -3/2. If it doesn't, then you don't qualify, boss. So let's see here. M for gradient of LM is equal to -5 minus 3. So that's like -5 plus 3. And then we got -3 plus 6. -3 plus 6 because, I mean, yeah, minusing, you see, negative and a negative. So let's see here, -5 plus 3. Oh man, now we have to do this again. -3 plus 3, 6. Let's give us a 3. So this doesn't work out. So you see, it's not the one. So let's get another. Let's use the other option for L there, -5 and -2. So let's see here, -5 and -2. Give this as a value for L. -3, -5. So let's label this again, x1, y1. It's an x, it's an x. It's not two things next to each other with a space in between. It's x. x1, y1, x2, y2. So here we want the gradient of LM again. Let's just make this #1. Let's call this #2, but you know, we're just testing here. So here it would be -5 minus 2. -5 minus 2. Oh, plus 2. Yes. You see, you see, negative. So it's a plus. And then here, -3 plus 5, because it's a negative and a negative. So you're saying -3, right, minus a -5. The mistake happened again. You see, -3 minus a -5. So here it would be -5 plus 2 at the top, and then at the bottom you'd have -3 plus 5. Yeah. Then at the top, -5 plus 2, that's like -3, and then -3 plus 5, that's a 2. You see, this one is the one that will have a gradient of negative what? -3/2, you see, and as long as this is Kn, right, it's gradient of -3/2, and then this is Lm, as long as it also has a gradient of -3/2, then automatically it means that you would be dealing with lines that are parallel to each other. So you see, the coordinate where where this shape is a parallelogram is if L is equal to this coordinate here. You see, so our answer, we just have to say therefore. So many therefores in a paper. I think that's the most used word in a paper too. Therefore this, even if it's wrong, but therefore is the word. But chill. Therefore this, therefore L, or rather therefore this, right, is the coordinate of L. The coordinate of L. Kablamo, kachow. From Cars, from Lightning McQueen. Kachow. Don't know if you know Cars, but Cars was quite cool back in the day. But anyways, moving on. C 3.6 says T is a point on KL. What are you going to tell us now? What story are you cooking now, mates? Tell us. How are you going to scam us this time? We're red. We don't get scammed twice in a row. No, not even. So it says here T is a point on KL. Where is T? Where is KL? You see, you're lying. There's no T here. There's niggas. But let's see here. It says here T is a point on KL. Okay, so it's a point somewhere. Wait, T is a point on KL produced. Yo, wow. So KN, no, KL. Where's KL now? There's KL and then there's L here. So somewhere along KL, you see, oh, I remember here. You see here they said KL is produced. So you have K here, you have L, and then as this line is being produced, somewhere along the lines you're going to have T. So that's T is somewhere here, I guess. It's somewhere here. Yeah, it says that T is a point on KL produced. So somewhere around here. And then it says here TM. So it would be like TM is drawn such that Tm is equal to Lm. So guys, you see when it, I keep saying guys, but I'm legit talking to one person here. So hey, you see, that's the thing. You don't know how to refer to the person. Do you say hey, bro, or do you say so dude, because dude is universal. So I think I can say dude. Just stop. So dude, this is what you want to do. So with questions like these, right? And remember, dude could go both ways. Dude could be referring to a girl, or dude could be referring to a dude, a guy. So, yo, stay with me here. So, dude, this is what's up. So, we know that T is a point on KL, you see. So, where KL is, you see KL somewhere here. Let's actually make this a bit longer. Make it longer. Yeah, somewhere there. That's going to, this looks okay. Somewhere there is T, ne? I should have made it to scale. No, why didn't I? So somewhere there is T. They say it here, Tm is drawn such that Tm is equal to Lm. Okay. So this is also equal to square root of 13. See how quick my brain thought there. I was like, this is square root of 13. So, I mean, if this is equal to this, then this also has to be square root of 13. It kinda just has to be. Let's see what we're getting into ourselves into. It's a 4-mark question, okay? So this being said, Tm is equal to Lm. They said here, calculate the area of triangle KTN. Okay, triangle KTN. Q. Oh. No. These niggas are not kidding. I should stop saying that. Some people might get offended. Sorry guys, you see, I'm black too. I'm black, so we're okay. I should really chill before I get overboard and start saying the wrong things here. So it says here T is a point on KL. So T is a point on KL. There we go. Tm is produced, or Tm is drawn such that Tm, okay, Tm here. Okay. Yeah, let's see here why this is useless. Why this is useful information. Let's see. Tm is equal to Lm, okay? And then they say you calculate the area of triangle KTM, or KTN. Sure? Yeah, guys. Yeah, like I've seen before, you know. Like, guys, I've seen many strange questions before, like, for real, but what? Why? What? Like, where is the correlation? Like, where in the world is the correlation? Like, come on, guys. Come on, why are you doing this? Well, we kind of need to look, really nicely. But let's see here. Let's see. KTN. Yeah, KTN. Yeah, this is just this is just like the weirdest question. Like, this question is just so weird. But let's see. So we have L here. Remember how funny. Remember that time when, okay, yo guys, yeah, math is a scam. Like, some of the things, it's like if you're not at home chilling, or rather thinking nicely, some of these things may not click in an exam. That's why if I was in an exam, like, hear me out, I'd have point blank just left this and then came back to it later. Because what I'm thinking is, you see, like how with the previous question that we were working on, we got 2 values for L. You see? 2 values for L. There. So, potentially what that means is, I mean, technically, if Lm is going to be equal to square root of 13, and L can be one of 2 values, and here we're seeing that Tm is also equal to square root of 13. I mean, it technically just means that T is represented by that other value for L there that we got. You see, let me just say that slowly, because, this is just like, I feel scammed too, man. I feel like, guys, how in the world? Like, how in the world? I mean, how out the box does a person need to think? Like, nuh-uh. In an exam, It's just too much. But anyways, you see, we said here L can be one of 2 points, you see, in the sense that, remember we had used the distance formula as well to help get a value for L and everything. And then we said we're getting 2 possible values for L. So technically this one is the one where you have square root of 13 as the length. This one is also a distance of square root of 13. So this value here is being represented by this coordinate, you see, because LM is equal to 13. So if you have 2 options for LM, it just means the other one is like somewhere here, of which here they've labeled it T. Oh my gosh. Yeah, examiners, I mean, hear me out on this one. This was low blow. This was a low blow. 2018 paper, I mean, like, yeah, this one was hot. The question that everyone was talking about, you know, when you're going out there, Chomi, oh, 3.3, oh, 3.6, Chomi, yo, emetila, wait, yo, nakitwets, how, chill, dude, chill. Yeah, this is one of those questions like, yo, yeah, here they brought out all the guns, like, what? Let's just answer this question because we're wasting way too much time now. So basically, yeah, the conclusion here is that for 6.3, right, whatever we're going to do, we need to use T as -6 and -3. So the reason for doing this is it's the only way. There's really no other way. So the moment we have T now, you see, we have a value for T, we have a value for K, we have a value for N. So it's going to be very easy to get the area of that triangle now. Now it makes sense why they're asking us for the triangle. Because, I mean, without a value for T, it makes no sense them asking us to work out that triangle. Because we have T down here, right? Then you have K up there. And then you have N there. You know, it's like, yeah, these people, they are just so demanding. It's like, what do you want, vele? Huh? Like, ufunani cho? What? I don't know how you say that in Afrikaans. What do you want? How do you say what do you want in Afrikaans? Huh? I know, I think what are you doing is like, what markie? So like, what do you want in Afrikaans? Let me think here. Wat wil jy hê? I don't know. Yeah, don't diss my Afrikaans. You can diss it, actually. It is what it is. So here, yeah, let's just finish this question. So it's 78 point. So with this shape, right, if you're going to get the area of it, technically it looks as though we need to use the area rule. So we basically need at least an angle on 2 sides. So here we have this angle already, luckily. That angle there is 78.69, you see. So the 78.69, let's see here. There it goes there. Why do I have to cram it in there? Yeah, 78.69. So we're just going to use our distance formula to get the length of KT. So T is like KT. I don't mean KD, I mean KT. If your name is Katie, what's happening? What's up? How's it going? Enjoy the studying. Good luck with the paper or your exam whenever you're writing. So T here, we say this is negative. If you're not KT, then, I mean, hello still. I mean, you know, what's happening. So let's see there. N is one coordinate -1, one coordinate -1. There we go. So we have all these distances. You see, our sketch is almost useless now. We don't need you. Bye-bye. Okay, let's just keep it there. Let's not be mean. So here, using our area rule, we technically need at least the length here and the length here. Because our area rule basically says, well, here technically the area of, what did they name this triangle? KTN. So the area of triangle KTN is going to be equal to a half. And then we need one side, which is KT here. One of the sides is KT. So we have here KT. And then the other side is KN. KN. And then the angle here, which we have put in this sign. Sign the angle here, which is just TKN. TK. That copy the N. There we go. So that's what we need to use. You see, with the area rule, you just need the angle and then the 2 sides that are going to that angle. You see, this line is going to K, this line is going to K. So we're going to use this formula. So clearly getting TK or KT or whatever, we're just going to use our distance formula. For Kn, we're also just going to use the distance formula. So it's a lot of distance formula stuff, but we already have, what do we already have? We have Kn. Remember Kn? Square root of 13, because you see, this is square root of 13. We know we got it. This was equal to Kn. They even told us in one of the, you see here, Kn is equal to Kn is equal to Lm. So you see, this was square root of 13. So this is also square root of 13. So we have Kn already, fortunately. So this one we have, this we have. So let's just get Kt using our distance formula. So Kt, let's just put this over here. Kt is equal to the square root symbol. Yeah, I'm not going to write out anything here. I'm just going to put the values. -1 plus -1 minus 1. So here, -1 minus 1. And then the whole thing squared. But hey, this is bad practice, guys. Just write the formula, you know. Yeah, don't be tired in exam, because you'll be like, do I really have to write down the formula? Well, yes, kind of need to. And if you're distracted like me, you're going to make the weirdest mistakes. Kt is equal to the square root of x1 minus x2. You see, I'm even swapping them because you can do that. Plus y1 minus y2 squared, the whole thing there. And then, I mean, you could label this x1, y1, x2, y2. And then let's put the, what did I do? I said -1 minus 1, fine. And then here I have to say 2 minus -1. So it's going to be 2 plus 1 squared, you see. Why am I getting Kn? Guys, yeah, I'm sorry. I'm really sorry. Because, yeah, I'm really making the weirdest mistakes today. And, yeah, let's not get personal. Let's not tell you what's actually going on in my life, because it's rough. But it's nothing major. I can handle it. So, this is Kt, right? It is equal to, this is 1. So I have to label this 2 and 2. And I just hope all these tiny mistakes that I'm making, you're noticing that, you know what, they just happen. So in an exam, just always look out for stuff like that. Let me actually end this question on a serious note, because, yeah, too many mistakes. Let me try and be serious and see if I'm actually not going to make any mistakes. So here, guys, you have, you're going to put like a, you're going to put like a square symbol. And then, so what you want to do is, in your distance formula, you're just going to have the, let's put your x1 minus x2 squared plus y1 plus y2, and then the whole thing squared. So you got your distance formula here. And with your distance formula, let's see here. So what you want to do now is you want to map it with your sketch and your figures. It's actually working. So, why the voice though? Dude, straight face. Serious mode for this question until we finish. Yeah, so, and then, let's see here, we got a -1 over there. So we're gonna need to say a -1 minus a -6. So let's put that there. Let's just put that real quick. Let's see here. So we got a -1 there. -1 over there, and then minus a -6. So we gotta put a -6 over here. And then don't forget your brackets. Okay, your brackets are very important. If you leave out your brackets, well, then just leave the paper. Wait, what is that? I was going to say, if you're gonna leave your brackets, then just be prepared to leave your marks in the exam room, because your marks are not gonna, you're not gonna see them on that report card, because I mean, you left out your brackets anyway. So, and then here you see, like, we got a +2 there. We're gonna need to say a +2 minus a -3. So if you're gonna say a +2 minus a -3, well, if you're gonna put your brackets over there, that's fine. But I would have preferred to just like write this as a plus, and then I would have also preferred to write this as a plus. But it's okay. It's okay. It's really not a big problem. And then here you're gonna have the. I'm tired. Hey, yeah. So you see here. Let's see. Yeah. Where was I? I'm lost. I put put a bracket, and then minus 1 plus 6 squared, and then 2 plus 3 squared, and then the whole thing under square root. And then let's see there, this is going to be square root of negative 1 plus 6, that's like what? 5 squared, yes. And then 2 plus 3, that's like 5 as well, 5 squared. And then here we have square root of 25 plus 25, which is square root of 50. So I think the seriousness kind of helped, but anyways, kt is equal to square root of 50. So here in our formula, it's just going to be a half. Kt is square root of 50. This is equal to square root of 13. This is sine our angle there, which is 78.69. And then all this goes into our calculator. So all that in the calculator, let's see there, it's giving us 12 so many nines, guys. 499999705, and then obviously to 2 decimal places, that's just going to be 12.50. If you want, you can put the units squared, but if you leave out the unit squared part, I mean, that's really not a big deal at all. You should get all your marks because this is not physics. But anyways, yeah, I think this question 3, yeah, I got carried away with those easy questions, because now when it was the hard ones, the kind of mistakes I was making, it was like, what in the world is wrong with this nigga? What is wrong with this dude? Why is he making so many useless mistakes? But yeah, welcome to planet Earth. So this is all we had to do for this question. It was straightforward, I guess. Well, not really straightforward. This whole thing here, yeah, that's just a scam, I guess. I mean, look at this. Huh? What? Maths. Guys, if you find out where Maths lives, tell me. Now I want to have a conversation with Maths. Be like, what the hell, dude? Because sometimes it's just too much. But anyways, that was for question 3. Now we're going to move on to question number 4. Question number 4. In this November 2018 grade 12 paper 2 memo. So obviously yeah, this is like, what's going on? So the thing is, I've gone through this question before, like a couple of times actually, on like an IG live or something like that, but this is what the original sketch looked like. They had said here, let's see, what did they want us to do? They said here in the diagram, let me actually just put this diagram closer because yeah, it says there, it's fine. In the diagram, the circle, or in the diagram, the equation of the circle with center F. So this small circle, right, has an equation that is equal to x is equal to that, y minus 1 squared is equal to r squared. So that's the equation of the small circle. And then it says here S is a point on the circle with center F. So S, there's point S there, so I should actually add that onto my sketch. Why are you so blurred? I can't even see. There's point S. What is the coordinates of S? 6 coordinate 5. Okay, so we got S here, 6 coordinate 5. And then it says there S is a point on the circle with center F. Another circle with center G, the big circle, is in the 4th quadrant. Yes, quadrant 1, 2, 3, 4. And then it says it touches the circle with center F at H. There we go. Such that such that the ratio of FH and HG is 1 to 2. Okay, so basically what that means is the radius of this small circle is half the radius of the big circle, you see, because I mean the ratio here is 1 to 2, you see. So it just means whatever the radius of FG is, HG is just going to be double. And then it says here the point J lies in the 1st quadrant. Yep, there's point J in the 1st quadrant. and then it says in the first quadrant such that HJ is a common tangent to both circles. And then it says here JK is a tangent to the large circle. Okay, fantastic. So all that means is, I mean, if this is a tangent to the big circle and this is also a tangent to the big circle, automatically these are equal to each other because of one of our theorems, you see. So knowing your theorems is a big advantage. So here, with all this being said, yeah, this sketch is all messed up. I'm probably, let me actually do this. I mean, let's just move that because it's like, I don't know if it's a distraction or what, but yeah, we'll just use this image over here. Let's try and level them up. Level up. Okay, stop it. Not even my kind of music, so why am I even singing that? So I'm not judging anybody. You listen to what you want. So it says you write down the coordinates of F. So F is clearly the center of the small circle, you see. And we can see that the center of the small circle is going to be given by the opposite of this and the opposite of that. So that is a simple question. 4.1, the coordinates of F is just going to be +3 and +1, because the coordinates of the center of a circle, you always get them from the standard form. If your circle is in standard form, then you always take the opposite of this and the opposite of that. That's going to be your center. Here they said calculate the length of Fs. Where is Fs? Distance formula thing is here. Oh well. Oh, these questions always start off so nicely, which is good. You see, this is where you can bank easy marks. Fs, we technically would need to use the distance formula. Let's see, there you can have the x2 minus x1, the whole thing squared, minus y2 minus y1 squared. And then let's just label this F. What do we have? Oh, I labeled F already. Come on, but it's fine. X here, and then let's see here, x1, y1, and then for S we have 6 coordinate 5. So let's put the x2, y2. Okay, let's drop this in the equation. Let's just get this marks, and then move on. How many marks are you offering us, paper? 2, 2, 2, 1, 4, 1. Okay, that's not bad. It's not bad at all. And don't mind my square root symbol. It's, yeah, it's the stuff of nightmares, this. So 6 minus 3. Let's see this. 6 minus 3. The whole thing squared. It's supposed to be a plus. You probably noticed that before me because, I mean, you're smart like that. Then this is 5 minus 1. 5 minus 1. The whole thing squared. Yeah, I'm sure a lot of things that I write down before I notice the error, you probably go, oh my goodness, please no, please. What is this? That's not what they taught us in school. The distance formula is supposed to have a plus. Yeah, it happens. Just, always be double checking your work. You will be fine. If you don't double check your work, then that's when you are likely going to just, flop when you get your paper back. So, 5. The answer is 5. So Fs is equal to 5. So you see what this is giving us. If Fs is equal to 5, automatically they have given us the radius of HG as well, because if this is 5, then it means this is just 10, you see, because it's just double. But yeah, let's just keep that in mind. 4.3, what does 4.3 want us to do? Write down the, wow guys, wow, these guys are so funny, like, okay. They want us to give the length of HG. So here they told us the ratio here is 1 to 2. Well, you don't have to try to give a reason, it's given. I mean, So let's put here Fs, we know it's 5. Whoa. Fs is equal to 5. Ooh, let's just finesse this. Fs is equal to 5, therefore Hg is equal to 2 times 5, which is equal to 10. This one is point blank given. It's the simplest question here. This question is so simple. You know what? I'm sticking to what I said whenever I said it. I think I was saying paper 1, the 2018 paper 1 paper was easy or something, or simple or doable or whatever. Paper 2 was, yeah guys, this is just cake. It's just like given. Let's see here. Here they had made an error. They had said given a reason. Given a reason why. But It's actually give a reason why JH is equal to JK. So they say we should give a reason why JH is equal to JK. So I mean, we already said it. Easy marks. We're happy to get 3 marks. Here we're going to say that because Beka Use. You see, if I don't say Beka Use, I spell it wrong. Beka Use, Beka use, Beka Use, Beka use, Beka use J, because because they are tangents from the same point. From the same point. So when I do finish this paper 2, right, the next few papers I'm going to record are going to be the 2020 prelim papers, like as many as I can get my hands on. See how those were, you know, just record those, upload them. That'll be cool. So for 4.5.1, determine the distance fj. Okay, that's interesting. Fj, determine the distance of fj with reasons. If jk is equal to 20, let's check the mark allocation. 4 marks. Okay, yeah, that's always important to know what the mark allocation is, because your brain needs to know how much it needs to think, you see. So they said we should get the length of fj if jk is equal to 20. Wow, guys, so funny, ain't you? So if this is 20, automatically this is equal to 20, you see. Now if they want us to work out the length of fj, I mean, this is just given, because this is a right angled triangle, you see, because this is the radius of a circle. The radius of a circle will always meet a tangent at an angle of 90 degrees. See, that's a law. The more laws you know, I mean, you're gonna have a party, you know, a party. But anyways, we are dealing with this triangle, right? I don't know, I'm redrawing it. It's kind of weird. I'm like, but y'all saw it, y'all see it, because I woke. But look at me redraw the thing, because, you know, got all the ink in the world, I guess. This is 20, this is 5. I mean, we're just gonna use Pythagoras for this one. It's just weird. I mean, 5.4.1. 4.1.5 is just odd. Let me just double check if I'm actually answering the right question here. Calculate the distance of fj with reasons. Okay, you see our marks are going to come from our reasons. So let's firstly state that we know that jh is equal to 20 as well. You see, jk is equal to jh, right, which is equal to 20. Where did we prove it? Where did we prove that they're equal to each other? 4.4. So you can put here 4.4 as your reason. You see, like that. They're equal to each other because the tangents from the same point are equal. See, they even told us here that they're equal. You see, they told us. So we're going to use you to, yeah. Moving on. So the next thing, we need to state that this is 90 degrees so that we can use Pythagoras. You see, so let's just say FHJ is equal to 90. FHJ is equal to 90 degrees. Our reason will be radius perpendicular tangent. You see, the radius is always perpendicular to the tangent. Therefore, now we can write Pythagoras, you see. Therefore, fj squared is going to be fh squared plus jh squared. So let's just pick this up so that the whole thing is in the picture. So this is going to be therefore fj squared is going to be equal to fh squared plus what squared plus jh squared. Our reason will be Pythagoras. So here we can drop in our values. This is just going to be 5 squared. JH, that's like what, 20? And then this is just FJ squared. You see, square root this side, square root the other side. This is going to be what, 25 plus 400, I think. Just have to double check that with the calculator before I make a weird dumb mistake. 2, 5. This is FJ. Calculator, please double check that answer. 20 squared. Yeah. We know it's 400, but hey, gotta check, man. Gotta check. I should stop ringing anger so much. Like, what the hell am I doing? Always making the MXM sound. That's what I mean by ringing anger. Bad. That looks like M times M, but it's actually yeah. Anyways, that's FJ. In our calculator, let's put here square root of 425. 5 square root of 17. Okay. Give them the answer and you move on. I mean, don't, make a fuss about it. Just give them the answer and move on. That's all there is to it. Not a big deal. If you want to give it as if you want to give it to 2 decimal places, 20.62, which is, you can make like curly equal to signs here. If you don't do it, I mean, that's totally fine. I mean, these are some of the things that are really not big deals. 20.62. That's what FJ is. That's what it is. Yes, that's what this is. Okay, moving on. I doubt any of these questions are going to be... Oh, what am I saying I doubt? I've gone through this before. Come on, Eva. Why are you lying? That you doubt it's going to be difficult? It's not going to be difficult. But it says that the equation of we need to determine the equation of the circle with center G. The equation of this circle with center G in terms of M and N. Okay, in terms of M and N in the form that... Okay, so technically M and N is the center, so that's going to represent A and B. So technically we just need the radius. This is how many marks? See, just 1 mark because there's really nothing to do for this question. So for 4.5.2, is it 0.2? Yeah, it's 0.2. 4.5.2, we just need to... I mean, this is just 1 mark anyway. So you see, x, and then the x value of the radius is just m. So going to put minus m there, minus m squared. And then plus, and then y, the y value of the radius there is just the 4. N. Where are you getting 4 from? Hey, n squared. And then our radius, remember what we got for hg is equal to 10. So our radius is just 10, so you have 10 squared there, you see. In this format, you get your 1 mark, you move on. For 7 marks, if I remember correctly, okay, they said here, calculate the coordinates, determine the coordinates of G. Okay, there is G. If it is further given that the equation of the tangent JK is equal to x is equal to 22. So the equation here of this straight line is x is equal to 22. So automatically what that means is this straight line going straight downwards passes the x value 22. Now here's an interesting fact. Very interesting simple fact. This is one of the easiest questions here. The reason is, firstly, if this x value here is equal to 22, right? You see it's touching a circle here. Remember, this is going to be a 90-degree angle. You see, because I mean this is the x-axis, and then here you have a radius and a tangent. They meet at an angle of 90 degrees. You see, so this is 90 because this is 90, or rather this is 90 because of our law that says a tangent is always perpendicular to a radius. So because we know that, automatically we know that the x value here is equal to 22. Yes, the x value here is equal to 22. Don't forget that. So what that means is we know that the x value of k is 22. Now, if this is 22, we know that the radius is just 10 units, you see. So if this is 22, 10 units back, it gives you the x value of g. So we'll just say that slowly. We know that the x value here is 22. They told us because they said the equation of j is x is equal to 22. So it means that this straight line going downwards only cuts the x-axis at 22. So it means going down, this x value is also going to be 22. Now the radius of our circle is 10 units. So 22, if you got 10 units back, you're going to end up at 12. So for the first few marks that we're going to get, we just need to lay out what we have just mentioned. Now you see, bit by bit, until we have it all down. So let's take it all the way up. All the way up. Oh my goodness, look at that, it's so high. Okay. So we say it here, firstly we need to state that what do we need to state here? I mean, well, we want to get as many marks as we can, so let's just say here k, the x value of k, let's put here yeah, let's just state that this angle is equal to 90 degrees and stuff like that. So let's just put here g k j. Let's put here g k j is equal to 90 degrees. The reason is radius perpendicular tangent. You see, so we've stated that this is 90, right? So here we can then say therefore m is equal to 22 minus 10, which is equal to 12. You see, so you may be thinking to yourself, how do they know what I mean? How do they know that I mean that the radius is 10 and that we're moving 10 units backwards? Trust me, they know. They set the paper. So they know all the different variations of getting these values. So here you're just trying to, map your way towards how you got this 12. You see, you basically said that this is 22. You see, and you know that this is 22 because you have proven that this angle is equal to 90 degrees. You see, so you know that it's a line going straight downwards. So whatever the x value is there, it's the same x value here. And then 10 units back, that's 12. So if you didn't do like word for word here, you should still get your marks, you see, because m is quite simple. What our main task is actually getting n. N is the one that's, excuse me, that's maybe going to be a problem. You see, so what I would do for n, well, let's see what I would do for n. What would I do for n? I know when we have the radius, fine. We basically want the y value here, right? What else? Oh, wait a minute. Can we get a, what? No, what can we do? Let me see here. What, this are, for our equation, we have m so far. Because what is the question asking us to do actually? Calculate the coordinates of g. Okay. So we have m, and now we just need n. So we could maybe get a coordinate that the line passes through, I guess, or a coordinate that the circle passes through. That does seem a bit, like overkill. But I mean, at this rate, it's almost inevitable. It's honestly speaking almost inevitable. However, let's see what we can do with our ratio. Remember, we were given a ratio to work with. So yeah, you see here, we know that this is 5 and we know that this is 10. The good news is so far we have at least one coordinate here. You see, it's just 12 and n. You see, this is x, y. And then here for f, we have the full coordinate. Remember, it's up here, 3 and 1. You see, so you have a coordinate up here, you have half a coordinate here. But then we have the distance here, you see. So we're going to make use of our distance formula here, because this is just 5 and then this is 10. So the whole distance here is 15. Yes, very simple. You see, I was just making this line here because might as well just, why have a new page for this? Not necessary. So let's just use the distance of fg, you see. So we know that fg is equal to the square root of x2 minus x1 squared plus y2 minus y1. And then for f, we can just label f here. Let's see what f is. F is 3, coordinate 1, which is x1, y1. G, it's 12 and n, you see. So we can label this x2, y2. We know that fg is equal to 15. You see, that's not like rocket science. It's, if you want, well, let's just give maybe a working to why we did that. So we know that fg is equal to fh, right, plus hg. There we go. Straightforward, this question actually. 7 marks. Wow, this is like the most easiest 7 marks I've seen in a long time. I am not even joking. So this is like n, right? So here we're going to have, no, that's x. We want x2, it's 12. So we're going to have 12 minus 3 squared, and then n minus 1 squared. And then technically, I mean, you can have a square root symbol here. 12 minus 3, that's like 9 squared. Plus, let's not remove that square for now. Let's just leave it. Don't do things like cancelling out here. You're so wrong. Don't do that. You will not be happy with yourself. You will cry. So let's just square both sides to get rid of the square root. And then here we have 15 squared. 15 squared. What is 15 squared? Calculator, tell us, please. Or wise calculator, please give us your knowledge. What the hell is that? 225. 225. And then here we have like 81, because 9 squared is 81, plus n minus 1 squared. Don't multiply inside or anything. I mean, why would anyone even think of doing that, dude? Like, why you sound so condescending? Like, nobody would think like that. And also, don't make this n squared and 1 squared. It's wrong, you see. This, you have to get 2 brackets that look exactly like that. You see, let me take the 81 over. Here, 2 brackets that look like this. I don't know, I'm taking them over because I'm going to take them back anyway. So let's just have 2 brackets that look like this. But let me actually show you another way to work with this, just to showcase different ways that math works, you know, because maths is interesting, I guess. So 225 minus 81. I'm just going to show you a different method here. 144. So this is going to be 144 is equal to n minus 1 squared. So if you want to get rid of the square root, you could actually, instead of having 2 brackets, you could square root this value and then square root this value. However, here you have to put plus or minus 12. If you don't put the plus or minus 12, you're going to end up with one answer, and then you're going to cry, you know. So always put plus or minus 12, so that now you know that 12 is equal to n minus 1, or negative 12 is equal to n minus 1. You see, so here working out n, the 1 goes over, you're going to have n is equal to 13. Here the n goes over, you're going to have n is equal to negative 11. So I mean, let's just look at our picture here real quick. N, yeah, go all the way up, bro, all the way up. Still can't see it. Okay, we can see it now. So n is definitely going to be a negative value because n is y, you see, so it's below the x-axis. So n has to be a negative number. So here we can disregard this 13 here. See, swing. So you see here, showcased another method, because here you could have also just like gotten 2 brackets, use the quadratic formula and everything together. You would have still gotten these 2 values. But here we're cancelling this one because our n has to be a negative, you see. So therefore, G, M, we got it to be 12. This is the value of G. Fantastic. Very fantastic. 7 marks. Wow. Wow, question. Such a generous question. Bless your soul. So that's for 7 marks for this last bit. And this analytical geometry portion was how many marks in total? 18. Okay. That's not bad. That's okay. That's fantastic. Let's move on to question number 5 now. So my assumption is that most people just jumped to this timestamp. Maybe not. I don't know. Because in question 5, I mean, look, there's this question down here out of 5. Like this question, guys. I've gotten so many questions on like my IG page or on the WhatsApp support group, the math WhatsApp support group, on this question so often. It's just weird. It's so funny and sad because I so get it. I get how this question is just madness. I think it's madness until this very day. I was like, what kind of a question is this? Why is it even in maths? Like, who needs this? But it's fine. We will work on it later. But here we are. Question number 5, right from the top. And let's just see what we can get here. It says in the diagram, P, we see you, is a point in the second quadrant. Quadrant 1, 2, 3, 4. It's in the second quadrant. And then they said here, in the second quadrant, and square root of 5 is, man, come on, man. P is a point in the second quadrant. Oh, and it is, come on, man. Just be more friendly with your English. And it is 5, and it is square root of 5 units from the origin. That's the distance of P. O, distance of PO, it's square root of 5 units. And then it says here R is a point on the positive axis, R is a point on the positive axis, and ROP is equal to theta. So before you work on these kinds of questions, they say calculate the value of K. The one thing you want to remember is here, always draw a dotted line going straight downwards to your x-axis. Always have a line going to your x-axis. Never have a line going to your y-axis. Never, ever, ever in your life do it. Always make sure your line goes to the x-axis. You see, if you have a curve, if you have a vertical, if you have a slanted line like here, your straight line has to go down. If your slanted line was here, then your line has to go up. If your slanted line was here, your line has to go up. If your slanted line was here, your line has to go down. Your lines always go to your x-axis, always and forever. So don't forget. Don't say nobody ever told you, because I mean, yeah, we kind of just stated that right now. But 2 marks, they said calculate the value of K. So what we want to remember here is, you see where K and R1 is. This is an X value. This is a Y value, you see. So an X value, remember, runs across. So this is X. So this is K. And then Y, it means that this is 1. And you see K has to be a negative. But let's get those. Getting the value of K here is actually quite simple. I mean, look, it's just going to be Pythagoras. Pythagoras is one of those things in math. They are so nice to use because they just remind you of the good old days, you know, grade 10 math, when things were like super duper nice, I guess. But they can still be super duper nice in grade 12 if you really want them to be. Just, you know, it's just the mindset and stuff like that, and a whole lot of studying and a whole lot of, you know, mental whatnot. And let me just do this quickly before I just... Actually, I don't even know how to write, because I'm like, where is this paper supposed to be? Why is it even there? Like, it's so... let me just fix this thing here. Let's put this on top. There we go. I think that's better. I think so. Starting to sound like Jose Mourinho. I think so. So here, 5.1.1. We said here Pythagoras is just going to tell us that, it's going to make things weird, because what are we going to label this point? You see, let's just put here square root of 5 squared is equal to K squared plus 1 squared. This is Pythagoras. You don't even need to give a reason for this. You know, you can just write it out, get your marks, get your answer, and move on with life. You know, it's that simple. If you want to put a formula before this, you could put like R squared is equal to X squared plus Y squared. It's totally up to you. But because you know it, I mean, just put it. Just put it. You know, put it. So here, this is going to cancel that. This is going to be a 5. The 1 is going to go over. This is like a -1, K squared. This is like 4 is equal to K squared. But if you square it both sides, I mean, look, K is going to be plus or minus 2. However, K is equal to -2 because, I mean, it's on the negative side, you know. So 2 marks there, you move on. Yeah, let's just keep moving on, because we have no time to waste. We've got like 5 other questions to go through. So it's like, wow, maths, wow. Without using a calculator, determine the value of tan theta. So you see, the idea is, you see, if this is labeled theta, go ahead and label this theta. Just do it. It will make your life very easy, because here now tan theta is just going to be, and you can label this -2 as well. Let's put here equal to -2 there. Give it an upgrade. So 10 is going to be, oh heavens, another hour of algebra. So opposite over adjacent, you see. Opposite over adjacent. That's how I always remember my algebra. Oh heavens. See, like this. Oh heavens, that's for sine. Another hour That's for course of algebra. That's for 10. I think that's probably how you remember it too. Some people use things like so car toa. I was like soka toa, soka what? Okay, you do you. But anyways, 10 is going to be opposite over adjacent. So 10 theta is going to be opposite, which is 1 over adjacent, which is -2. You get your mark, you move on. I mean, look how much they're offering you for that. 1. It's fine, we will take it, ma'am, we'll take it. So moving on, the next one, you see I already have some markings there because, hey, don't mind this is totally wrong. It's not totally wrong, it's like a long method, and I wouldn't advise anybody to do it, but we'll just get there now. Let's see here. B, this was A, B. Well, for cos, they want us to work out cos 180 plus theta. So obviously cos 180, you could just use your cast diagram. Cast South African Technical College. Oh, I don't know how you remember this. But anyways, 180 plus, it would be 180 plus. So you'd end up in this quadrant. Now the idea is whenever you're working with 180 plus or 360 plus or 360 minus or 180 minus, as long as it's 180 and 360, whatever you have in the beginning, you will have it at the end here. You see, this angle is this angle. And then you need to ask yourself, 180 plus in this quadrant, you see, because you go 180 degrees plus, so you end up here. That's cos is a negative there, so you put a negative there. So what we need to work out is a value for cos theta in our triangle, and then we just need to put a negative in front of it. So cos theta is going to be adjacent, which is -2 over hypotenuse. You see, this O there is for the origin. It's not the number. I did not put that there. I don't write this nicely. Shade. Self-shade. Self-shade. Wow. Okay. Interesting. So here, it's going to be adjacent over hypotenuse. So here, you're going to need to put your negative, and then adjacent is -2 over hypotenuse square root of 5, you see. And then if you simplify, this is 2 square root of 5. Fantastic. Easy marks, easy going. Yeah, we'll have to see it. So let's keep going. So the next one says, write this in the form that. How many marks you want us to do that? How much you pay? 5. Okay, we'll take it. We'll take the bid. Sold. So for 5 marks, we are not skipping this question or anything like that, because it doesn't have to be skipped or anything like that. We don't have to come back to it or anything like that, because it's kind of straightforward. Because here you should be seeing this should remind you of your compound angles. You see, sine something plus. So on your formula, yeah. What? I was not even looking where I was writing. Wow, yikes. Sine theta plus 60. Using your compound angles on your formula sheet, you're going to have sine theta cos 60. And then if it's a plus there for sine, it's a plus here. But then, you don't have to cram these things. You can just look it up on your formula sheet. There we go. So because we cannot use our calculator, you just need to remember your special triangles. You see, this is how I remember my special triangles. This is the one for 30, 60. I always put 30 first. Here down here. I always put 30 there. And then I always put 60 there. And then I use my calculator. This is what I do. Sine 30. Use sine 30. It's the easiest one. Sine 30 is a half, you see. Sine 30 tells you opposite over hypotenuse. So you put those opposite over hypotenuse. And then automatically the last one here has to be square root of 3. You see. The other way I remember it is I always put the 30 here, the 60 there, and then I just count clockwise. You see. 1, 2, 3, and then I put it in a square root. So a very easy way to remember it. And then obviously if you ever need the other special triangle, it's just 1, 1, square root of 2, This is the easy one, 45, 45. But we're going to use this one because we want to have values for sine 60 there. For the sine theta and the cos theta, we're going to use our triangle, because you see they want us to end up with this, but bit by bit, biki by biki, mark me here. So for sine theta, let's start. Sine theta is going to be opposite over hypotenuse. So here we're going to have opposite over hypotenuse. Kablamo. And then cos 60, let's see there. Cos 60, what you got? Adjacent over hypotenuse. Okay. Adjacent over hypotenuse. And then cos theta, okay. Where's cos theta? Cos theta is adjacent over hypotenuse. Okay, okay, very nice. Let's put that in bracket. Adjacent. What was adjacent again? Negative 2. Negative 2 over square root of 5. Adjacent over hypotenuse. And then sine 60, which we got here, opposite over hypotenuse. It's going to be square root of 3 over 2. There we go. Okay, okay. Seems to be looking up. Luckily, here, if you simplify, you're going to have 1 over 2 square root of 5. Here, let me keep this in brackets for now because I keep putting plus first before I see here. This is going to be negative 2 square root of 3 at the top, and then these two multiplied together, it's going to be 2 square root of 5, you see. Yay, what you doing? Just one big bracket. So here, this is technically going to be the 2 here is going to cancel the 2 there. Then you're going to have 1, 2 square root of 5. And then this is going to be a minus, right? So it's minus here, square root of 3 over square root of 5. No. Why did I do that? So I'm actually going to pivot here and reverse my step. You'll see why just now. Because here you see we're trying to end up with something like this. Square root of 20. So square root of 20, if you check in your calculator, square root of 20. Where is square root of 20? Ah, yeah, square root 20. You see? Wow. 2 square root of 5. So at the bottom we want this 2 square root of 5. So let's not cancel it. So let me actually do this here. Pivot. Be ready to pivot in an exam. It's allowed. You don't have to stick to what you did the first time. So here I can redo this, right? Now this is going to be a negative 2 square root of 3 at the top, and then here I'm going to have 2 square root of 5 at the bottom. So the bottom, because the denominators are the same, it's 1 minus 2 square root of 3. You see, this makes life easier because what you're trying to do is you're trying to not do stuff that pulls you away from ending up with this. You see, we wanted to have this, wanted to have one denominator anyways. So here, if I had cancelled the 2 and the 2 there, I'm going to end up with denominators that are different, and that's going to take me a step back because I still need them to be the same anyways, you see. So let's just keep them the same and work with this. So here you see, so far we can see what the value of A is. It's just 1. We can see what the value of B is. It is just negative 2 square root of 3. The bottom, this is just square root of 20, remember? Because anytime you want to mix something that's outside and something that's under a square root, this is all you do. Firstly, this number here, you just throw it in the squared. It's like a weird law. Not a law per se, it's just like how you want to do it. This here, you just throw it in here squared, which is just a 4. And then here you're going to have 1, 2 square root of 3. The whole thing here square root of 20. You see? You see? Because from square root of 20 to get this, you have to split this up into two numbers. One that's a square number, one that's not, you see. And then this is technically saying square root of 4 and square root of 5, which is just 2 square root of 5. But at this point in time, there's just, yeah, at this point in time, I think I just lost my train of thought. That's so bad. But anyways, all I was trying to say is, when you get here, right, say you don't know how to get this square root of 20, just check it in your calculator, like what we did. Just put square root of 20 in your calculator, see what it pops out as, and then you could literally just finesse the question. You could even just go from here and then jump straight here. You will still get all your marks. There's no one that can be like, oh, how did you get this? How did you get this? Ah, my guy, I got it. So let's see here, 5.1.3 in your car. They said here 5.1.3, use a calculator. You see bold. These words here, use without a calculator. Here they're saying use a calculator. And we're so used to saying use without a calculator that it's so easy to read this and think, oh, okay, I should not use my calculator. But they said use a calculator. So we are definitely going to use that calculator. In terms of us using our calculator, this basically is suggesting that if we're going to work this out, we should get a value for theta first. Don't mind this here. This was me thinking, yeah, this other day when I was going through this, I think, during like a live session or a Zoom session. Because on Saturdays, I started having like Zoom sessions with like, yeah, to replace like my IG live sessions. Because IG live sessions, they're okay, but I mean, I feel like Zoom sessions are more useful because, yeah. Let's see here. Use a calculator to calculate the value of 10 to theta minus 40. Yeah, so the Zoom sessions I'm referring to, those are like group sessions every Saturday from like 3 to 4. That's like a group session. But obviously one-on-one sessions, those are like, you know, private one-on-one sessions that people like pre-book and pay for in advance and all that. But let's see here. Use a calculator to calculate the value of this correct to 1 decimal place. But the Zoom sessions, the ones on Saturdays, I keep getting distracted. The Zoom sessions on Saturdays, the ones from 3 to 5, those ones are free. Those ones are just, you know, just have them every Saturday from around 3 to 4. Yeah, 3 to 4 roughly there, but we always spill over, but it's cool. So those ones, if you want to join, just hit me up on IG. But then those are group sessions. You see, the one-on-one sessions, those are the ones that are like pre-booked and prepaid for and all that. So cool stuff. Now here we need to use a calculator to calculate this value correct to 1 decimal place. So we need to get a value for theta first in our sketch, and getting a value for theta is going to be the easiest thing in the world, the easiest thing in the world. So let's just use let's use anything that we got. You see here we have here 10, theta is equal to negative a half. So we could even use that to eventually work out our value for what? Our value for theta. Yeah, we can use that to work out our value for theta. It's perfectly fine. You can definitely do it. You don't got to worry. But the thing is, you want to be careful that, you see, when whatever you're going to use to work out a value for theta, you need to make sure that you choose an obtuse value. Choose an obtuse value. So this is what I mean, you see. For 5.1.3, let's put here, yep, 5.1.3, might as well do this, 5.1.3. So here we know that 10 theta is equal to negative 1 over 2. We're just using one of our expressions from my previous answer. We're technically just using our triangle. You see, we have our triangle here. So you can just use your triangle to get a value for theta. You can use opposite over hypotenuse, sine or adjacent over hypotenuse, that's cos, or opposite over adjacent, that's tan. You can use any of them to work out a value for theta. So here what's going to happen is, you see here theta is going to shift tan negative a half. Kablamo. Yep, I was doing that while talking. You see, this is not our value for theta because theta is an obtuse angle. You see, so what you need to do here, obviously this is going to be 180 degrees minus 26.5. Let's just put the whole thing. So what I'm doing here, you see I'm just using this as a reference angle. You see, literally the word reference. Remember, the word reference it's an English word, yes, but it's just basically a number. This is basically going to give us a point of view, or it's just giving us somewhere to start off in terms of us getting a value for theta. Because here this is telling us, this is technically, you want to take this as a positive number. This is telling you that this tiny part here is 26 point something. So if this tiny part is 26 point something, this is going to be 180 minus that tiny part. So let's put here 180 minus this whole number here, 26.56505118. And then here, let's just put here 180. Let me put here 180 plus that answer because I'm trying to minus it. This is going to be 153.4349488. You see, the effect of what I did was, yeah, I mean, I just basically just went 180 minus 26.56505118. You see, it's this value, but because the calculator had a negative number in it, you see I said 180 plus that value. But here we are now. Theta, this is our value for theta. So I've been using our calculator to get this value. It's super easy. How many marks you give? How many marks? 3. Ish, it's fine. We'll take it. Beggars are not choosers. Beggars are not choosers, guys. Marks, they're all, yeah. Don't choose your marks, guys. Just get all of them. You know, don't be like, 2 marks, I'm leaving it. Or 5 marks, it's too much. Hey, baba, If you're going to leave it, always come back to it. So here, getting this value is going to be 10 2 multiplied by this value here, and I suggest that you just use the whole thing before like rounding off, because you see it's not a final answer anyway. So don't put yourself in that situation where you like round off and then now you're gonna have problems with like your examiners. I mean, come on, don't do that. I mean, like, you're literally almost there. Just let me just put all this in the calculator. All this in the calculator. This is going to give us 18. Let's see there. Hey, calculator, give us the answer. Oh, wise calculator. For we know not what the answer to this question is, but we know that you are wise and know all things to do with math, because you are weird like that. So let's see here. 153.43. Where's 3? 43.49412 minus 40. Fantastic. Yay. 18.29 if you round it off. So, wait. Did they say we should round it off? Hey, you see, to 1 decimal place. Yeah, reading our questions, guys, is important, because it's always the small things. You know, they'll always shy you with the small things. Round off to 1 decimal place, but the front says round off to 2, unless stated otherwise. Ish. Yeah, English. So 18.3 is our final answer, because they said round it off to 1 decimal place. So you get your 3 marks. We're happy about it, and then just like to thank the calculator for giving us the answer. Just like to thank the pen for, you know, writing it down. Just like to thank the paper for, you know, being there for the answer. That's just weird. Okay, this question says 5.2. Prove the following identity. Check out this identity. How many marks? Okay, that's not bad. So this question is, obviously, it looks long. It's like, what in the world? Like, what in the world is going on here? It's just so long, and I'm just like, maths, I have to get a new page for this one, because this is going to take long. But let's not have a bad mindset when it comes to math, because it feels like maths has ears. The more you bad mouth it, the more it kicks, baba. The more it kicks, the more it chows. So yeah, don't have a negative outlook when it comes to math. I know I'm always bad mouthing math as well, but yeah, I kind of just do it from, it's like banter, you know how you just have, like, you know, just random banter. That's just how it is with me and math. Because I mean, once upon a time we were not the best of friends, but I mean, we've settled our differences. You know, you can't be angry with people forever. You know, you have to, yeah, make amends. Now I've made amends with maths, guys. I'm telling you, one day, sat down with math, I was like, hey bro, hey girl, like, we need to talk, because, you know, this is just not working out, but I kind of need you in my life, and, you know, I just want to make this work. So, I mean, if you're willing to make this work, I'm willing to make it work too, you know. And then, I mean, we just settled our differences, you know. We agreed that we were going to work together, and then we were going to, you know, help each other out to, you know, just make it through. And I mean, before you know it, look at us, man. We're like, you know, best pals and stuff. So I mean, all things are possible, man. Like, yeah, because I mean, I remember getting those 30s, those 40s, those, you know, those really I'm not crying for real. Hey guys, man. Hey, I remember the days, guys. I remember the days. And then, yeah, things changed because, yeah, the mindset changed, really. Honestly speaking, that's one of the things that changed. The mindset, and then just putting in the work, putting in those hours to catch up because I was so behind. You know how it is to like catch up with grade 10 work and like catching up with like a bunch of grade 11 work. It's like so hard, especially if you catch up and then you end up with a distinction in grade 12, but you didn't even barely get like a 50 in grade 11. It's like, it's kind of dope, man, but we did it. We made it, but I'm kind of wasting time now. Anyways, let's see here. So, what you got? They want us to solve this identity. So this identity looks straightforward. What I mean is, it don't be overwhelmed. This identity, we're just going to do a ton of writing. A ton. When I say a ton of writing, I mean a ton of writing. There is no two ways about this. I'm actually going to write as tiny as possible because it's a ton of writing. Ooh, tiny ton. Okay, so let's use the left-hand side here. The left-hand side, this question is somewhat straightforward. The only thing is, see, the denominators have to be the same first. This is just a fraction and a fraction. So here you're going to have cos, you see, writing very tiny because I know this is over. You see, I can't even make it down here. It's like too much. I should have just put it on the same line. Come on, man. Minus sine x. This thing here, we're multiplying it by cos x minus sine x. The whole thing over cos x minus sine x. You see? Because we're trying to get an LCD. Our LCD here, C, man. Come on, C. LCD is equal to is equal to cos x minus sine x times, let's make that a bit focused, times cos x plus cos x, no, plus sine x. It's just basically these two denominators put together. That's our LCD. So you see, for this one, it has cos x minus sine x, so we have to multiply it by the plus. Errors, guys. Errors are bad. So you see, we already have cos x minus sine x, so you have to multiply by cos x plus sine x at the top and at the bottom. And then minus, let's see here, we're going to have cos x minus sine x at the top, and then cos x plus sine x at the bottom. Here we're going to multiply it by, you see there's a cos x plus sine x at the bottom, so you have to multiply it by cos x minus sine x at the top, and then cos x minus sine x at the bottom. You see, so always take note of these tiny errors. This should show you that always be ready to change, always be ready to look at what you're doing, and always be ready to correct it. Don't be too arrogant and think, it's right, or something. Well, that was just a tiny mistake, a weird dumb mistake, and always look out for those. So here now, you see this here times that. This is going to give you cos x. Let me actually do this. Let's just do this all at once. You see, because it's here, you're multiplying it by this bracket. And then here, you're multiplying it by this bracket. Always remember that. So here it's just cos times cos, which is cos squared x. And then here cos times sine x, which is cos x. Why am I writing here so squashed? Cos times cos is cos squared x. Cos times sine x is positive cos x sine x. There we go. And then here sine x times cos x, it's also another. You can write it like this if you want, so that it looks alike, because it doesn't matter if it's swapped around. What I mean is, you see, cos times sine x here is just this, and then sine x times that, we know it's the same thing again. And then here sine x times sine x is just going to be sine squared x. Yo, I'm running out of space, am I? Oh, no, we're still good. Okay, fantastic. And then at the bottom, At the bottom, remember, we definitely have our LCD. Now, the good news is, yeah, let me write this whole thing because it has to go all the way to the other side. See, there's no avoiding this. So you see here, our LCD, this is the difference of two squares. You see, cos and cos, sine and sine. One has a minus, one has a plus. So you see your LCD here is actually just the difference of two squares, which is just cos squared x minus sine squared x, you see. So because here our denominators are going to be the same anyways, you can write this as cos squared x minus sine squared x. You see, so we did this, we multiplied these two, and then here be careful to put a minus here. Why didn't I just add these two together simultaneously? And now I'm just giving myself work. Yeah. Why did I do that? That's not nice. So here cos, you see we have to put this minus here. Don't forget it. This minus, put it here. Big bracket for this two here. For whatever answer you get. Cos times cos here is going to be cos squared x. Cos times sine there is going to be negative cos x sine x. And then here sine x times that, you see it's going to give you, let's just not cut corners here because who knows who's watching, you know, but like, don't cut corners, bro. I want to see what you did. I want to see what you did. Show me what you did. So here's sine x, negative sine x times negative sine x, that's going to be a positive sine squared x. Okay, fantastic. Yeah, ne? The top here we just have cos squared x, this plus that, that's going to be two of them, 2 cos x sine x, and then the sine, the plus sine squared x there, minus this whole thing here, cos squared x, yeah, I'm just dealing with what's inside first, cos squared x, minus 2 of these, cos x sine x, and then plus sine squared x. And then if you can simplify as best as you can before like mixing and matching and all that, do that. So what I mean is, hey, and don't mind my line, you see, because hey, I'm sorry, I don't have a ruler. I really actually don't. Cause the last time I had a ruler was when I was doing EGD, which is kind of dope. EGD was so cool, guys. EGD is so nice. Like, EGD is the stuff of dreams. But I know a lot of people hate it because, I don't know, man. It's just like, okay, bro, you do you, you know. So you always want to simplify as best as you can. But because here you see, can you see here you have cos squared x plus sine squared x. You see, that's a 1. You see, cos squared x plus sine squared x, that's just going to give you a 1. Minus, and then here the same thing, cos squared x plus sine squared x, that's also going to give you a 1. So simplifying is king, guys. Simplifying is key, and it is king or queen, whatever you want to call it. So here this is just cos squared x minus sine squared x, and then here this is like now we can simplify the top. You see, 1 plus 2 cos x sine x minus 1 plus 2 cos x sine x. You see, the signs are important. Make sure you always have your eyes peeled for those things, because those are the things that are gonna come back to bite you. Those things bite. Yo, they're like pit bulls, guys. Yo, signs and pit bulls, same WhatsApp group. I did this, I was like, same WhatsApp group, but yeah, let's just forget that. So here, 1 minus 1, that's just a 0. So this plus this, you see, it's 2 things. 2 with 2 this and 2 that, that's just 4 of them. You see, 2 cos x sine x plus 2 cos x sine x is just 4 cos x sine x. The whole thing is still over this square identity, you see. No, it's not a square identity. It's the double angle of cos, but this is the difference of 2 squares, but let's just write it out for now. And then end it. So you can see it's just a lot of writing with this question. Now the idea is, you see where they want us to end up. Where do they want us to end up? There. They want us to end up with 2, 10, 2x. So this should remind you of, you see the 10, 2x there. You see. This is the same as 2 with sine 2x at the top. and technically cos 2x at the bottom. Don't mind how this was just, yeah, but let's just do this. I hope it doesn't look weird. It definitely does look weird, but anyways, this is what we should be seeing, you see, because 10 is just sine 2x over cos 2x, because if this is a 2x, this whole thing also, this has to both have 2x as well, and then this 2 in front is just that 2 there. So that's the vibe we're going for. Now when you're looking at this should remind you of your double angle of sine, but the only thing is, you see, because of this tiny 2 up here, you see this tiny 2 is giving us a hint that we should do something with this 4. Let's split it up into 2 outside and then leave 4, let's leave 2 inside. Oh, come on, man, come on, bruv, let's just write nicer, come on. Let's have 2 here, and then let's have here 2 sine x cos x. Now the reason for doing this is we know that that's just the double angle for sine. At the bottom we know that this is a double angle for cos, so let's put here cos 2x already, and then we're gonna have there 2, this thing here is just sine 2x, the whole thing over cos 2x. This is what's gonna give you a tan. You see 2 here is over 1 anyways, and then this here is tan 2x. Kablamo! Therefore left hand side is equal to the right hand side. Done, done, done. It is so long, like, oh my goodness, why you got to be so much work, but yeah, it was a lot of writing. I mean, look at this line, look at how messed up that line looks. Look at this. Sure, hey, deplorable. But hey, as long as you get your marks, guys, as long as you get those marks, you're safe. So that's what we did here. You see, you had to get an LCD, and then just had to pay attention very nicely, keep in mind your signs, and then boom, here we are. Now for the moment we've all been waiting for. I don't know if you skipped to this timestamp, but if you did, what's up? Because it's about to get real. Or is it? No, I don't know. I don't know, but it's for 5 marks. Yeah. So this question is quite interesting. It's just one of those wild card kind of questions, really. I always say this. That's what I always say. Now, the idea with a question like this one is, well, obviously, I'm sure you've checked the memo, you know, I think. But with a question like this one, it's just one of those questions which you would most probably just do at the end, depending on how you feel and stuff. So with questions like this, we want to remember the essence of sigma. This is saying we need to add up cos squared 38 and cos squared 39, cos squared 40, going on and on and on until cos squared 52. That's what we need to do. So if you're not going to use a calculator for 5.3, this is what's going to happen. I'm going to need to write, even if I write slow, I mean, because look, between 52 and 38, this is how you check how many numbers there are between two values. And this is very important. You see, just to give you an idea of how many numbers we're going to deal with, all you do is the number you're ending off with minus the one you're starting off with plus 1. Always. You see, there are 15 numbers to deal with. You see, that's very important. Between 52 and 38, there are 15 numbers. And all you do is you take the one you're ending at, you minus the one you're starting at, and then you always add 1. You see, the analogy behind that is, think of values like between 1 and 5. You see, 1, 2, 3, 4, 5. Between 1 and 5, there are 5 numbers. But then if you go 5 minus 1, you're going to get 4. You see, which is wrong. There are no 4 numbers between 1 and 5. So anytime you want to work out the values between two numbers that are in incremental order of 1, as in, if you just want to work out the distance between two values, where you know where you're starting and you know where you're ending, always take the one where you're ending, you minus the one where you're starting, and you always add 1. Always and forever. You see, that's very important. So now we know between 38 and 52, they are 52 minus 38 plus 1 values, which is 15 values. So this is what we need to remember. We need to put cos squared with 38 and cos squared with 39, going on and on until cos squared 52. And we're going to have 15 values. Imagine, guys, it's a whole test that wants you to write out 15 things. These guys are not playing. Like, they're not playing. Let's just do it. Let's just do it. So this question wants us to put, this is what they want us to do, literally. Cos squared 38 plus cos squared 39 plus cos squared 40. Hey, yeah, we are far. Plus cos squared 41 plus cos squared 42. These are 5 numbers. Let's have 3 rows. Cos squared, let's put here plus cos squared 43, cos squared 44. Who would have thought that a math sum like this would come out? It's like so much writing. Like, wow, guys, y'all are such mean people. Like, yar, man, yar. Let's not complain. 5 numbers. So cos squared 47. So the best way to get revenge is to kill the papers. You know, just like get, what was that? Just get all the marks, as many as you can. You know, shove it in their face. Be like, you see, yeah, I thought I was gonna fail, but I showed you, didn't I? Plus cos squared 50 plus cos squared 51 plus cos squared 52. Okay, this is what we need to add up. Now, obviously, you may be thinking, what in the world? How are we going to do that with a calculator? So luckily, this one already we can work it out without a calculator. It's the only one we can work out without a calculator. The others, we have to finesse them. So what you will note is, you see between 38 and 52. Look at this. 38 plus 52. That's 90, you see? I mean, where there's 90, there is fishy stuff going on. So what you could do for yourself is, you want to change half of these. You see, half of them. You want to change them to sine. You want to change them to cos 90 minus. Yeah. So what I mean is, you see, for 38, let's start. Wow, guys. You see, you write this out. Yeah. You know that this is equal to, I think here we're going to have 2 rows only. So here, I'm going to change this to cos squared 90 minus, well, then you see, this is the nice thing you see here. This is technically the middle. Yeah, if you check 1 2 3 4 5 6 7 values, 1 2 3 4 5 6 7 values. So let's see, this one technically goes with this one. You see, 38 and 52 is what gives you 90. So here we can write it as 90 minus 52 plus this one we can write it as 90 minus 51. 90 minus 51. Who would have thought, guys? I'm still in shock. Like, wow, okay. These niggas were not playing. They were like wanting to destroy. And then here, this is just going to be cos squared, because I mean, yeah, minus 50 plus cos squared, let's see here, 90 minus 49, yeah. Hey, just 4 numbers. Hey, we still have 7 to go. And then here plus cos, we were here, right? We did 4 values so far. So we're here now. That's going to be cos 90, let's see, 1, 2, 3, 4, 5. Cos 90 minus 48 with the squared there. And then here we're going to have plus cos 90 minus 47, the whole thing squared. And then for this one, we're going to have plus cos 90 minus 46 squared, you see. And then from here, we can just plus the rest. These are just fine. Plus 45 plus cos 45 squared plus the 46, 47, that one, plus cos squared 46 plus, because so what we're doing is half of them are going to have them as sines, half of them are going to have them as coses, because if they match, we'll be able to add them. They'll give us ones and all that. So here 46 and then 47. and then 48, and then 49, and then 50, and then 51, and then 52. I am not about to just make a song out of that because I'm not an artist, a song artist, or whatever you want to call them. I'm not a rapper either, so I'll just stop. Everybody's a rapper these days, but trust me, I'm not one of them. I am not one of them. Like, y'all do you. It's okay. So you see all these ones before cos 45. You see all these ones here. These can be changed to sine. And remember, 90 minus will always end up as a plus anyways, you see, because you see, 90 minus, you end up in this quadrant, and everything is a positive in this quadrant. So you see from the top here, we're going to have sine squared 52. And then here, sine, I'm saying sine, but I'm writing cos. This is weird, 51. And then sine squared 50, sine squared 49, sine squared 48. I sound like I'm playing some kind of counting back game or like one of those weird games. Sine squared 47 plus sine squared 46, and then now we're back to the 45. Man, so much writing. It's like these guys were really not playing games. Like, they were really not playing games, guys. They were out to just not be nice. They had no good intentions with this question, and they keep making it pop up. I just had someone tell me that they wrote it, they saw this question in their paper. I'm like, what? Wow, they just, sometimes I feel like examiners just sit around a table and go, you know what, what's the best way we can get these people to start complaining about this paper? What's the best way we can get the best memes out of these guys? Because we must set the worst paper ever so that they can post memes about it and we can feel good about what we're doing, because we are just giving out stress because that's all we know what to do. No, that's all we know how to do. No, that's all we know to do. Wow, botched my words there. Yeah, man. But anyways, you see now we have pairs. You see, the sine squared 52 there goes with the I left out one. I wrote one twice. I did not leave one in and one out. Yeah, you see, the sine squared 52 and the cos squared 52 go together. So you see, these have the same angle, and it's sine squared an angle and cos squared an angle, so that gives you a 1. You see, this and this gives you another 1. 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 And then this is just alone. I should really stop singing because my singing is terrible. 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. How many ones, man? Come on. 1, 2, 3, 4, 5, 6, 7 ones. You see, you got 7. Okay. Plus cos squared 45. And then we got z squared. No. We got the, what do we have here? The 45 angle triangle. So don't mind my triangle, it's super bad. So here we got 45, and we got 1 and 1 over there. This is square root of 2. Why do I keep singing today? It's so weird. Oh no. So cos 45 is obviously just adjacent over hypotenuse. You see. So if this is squared, it means that this whole thing needs to be squared. So let's just, do that. They said don't use a calculator, so you see we have to show them these things. 1 plus 1 over square root of 2, the whole thing squared. Now you see your third laws, or your exponential laws rather, will tell you that 1 squared will be at the top. At the bottom you'll have square root of 2, the whole thing squared, you see. And then 1 squared is just 1. the square root cancels the 2 there, you're going to have a half there. You see? 7 plus a half. Guess what? You're going to need to put this under over 1. And then you need to use your normal fraction laws, you see? Your LCDs are 2, so you're going to multiply the 2 at the bottom, the 2 at the top, and then you're going to have the 14 over 2 plus 1 over 2, and then you're going to have your 14 plus 1, which is like 15 over 2. Wow, mind blown. Just madness. Just madness 101. But I mean, we did it. We did it. All that writing, and we did it. Like, I'm so finally this question is like, oh, but this question, yeah, obviously if you know the idea or the drill or how to go about it, I mean, it's not so bad. It's just a lot of writing, like a ton of writing, and it's like so much. I'm sure, yeah, this is one of those questions where you're like, yeah, now just skip it, just skip it, like, just skip it, because this is how it was given. I mean, look at how it was given. Sigma notation in paper 2, you're like, but guys, come on, man, I thought I left it in paper 1, come on. Nope. Here it is, hello, type of thing. So, yeah, man, it's just bad, but it is what it is, man. We keep moving, we keep making it happen, and yeah, it's just gonna be 15 over 2 there. If you wanted to just put 7.5, you could have done that if you wanted. It's your choice, because 7 plus a half is 7.5. I don't know why I did this. So extra. But that's all we had to do for this question. So you do it, you get your 5 marks. 5 marks for this though. Sure. Yeah, you see, this is why you leave these questions until the end, because this legit took longer than 5 minutes. Even if it's not explaining it or whatever, this would take longer than 5 minutes. And in an exam, every question, you see, 5, your mark, you always times by 1.2. This question, what was allocated to it is 6 minutes. Now, I can prove that this question takes longer than 6 minutes. So this question was totally unfair. Like, oh my goodness, people just want to kill everybody, and it's not good. We should save the planet and save the kids of America and South Africa and the world, because school is just not something people should just be depressed about all the time. I don't know, I was muffling my words there, but enough talking. Let's move on to question 6. Hopefully question 6 has good tidings. I'm very, very talkative today. Hey, what am I hiding? What are you hiding? Because when you talk too much, there's always something cooking. Here we need to obviously just, what? We haven't even read the question. What do we obviously need to do? Why are you lying? So it says here, consider this 10 graph. Okay, interesting 10 graph. And again, you see, if you want a breakdown of, like, you know, standard graphs, what this means, this is frequency, this is, well, technically 10 does not have an amplitude, so that's not amplitude, but this is the frequency of the graph. You see, it gives you an idea of the period as well. So if you want to run down on, like, you know, what your standard graphs mean and all that, you can always just go on the main channel, Bright Young Brains. Write that down. Let me write that down for y'all. Bright Young, oh, what the hell, man, Young Brains. Just search for Bright Young Brains on YouTube, and then go to the playlists. You see, the best way to navigate the main channel is to go to playlists. You see, and then check through the topics there, and then under functions and graphs, let's put here functions and graphs. I'm really waddling right now. Functions and graphs. And then right at the bottom, you're going to get sine, cos, and 10 graph tutorials there. After, like, the hyperbola, the what, the whatnot. So, yeah, if this is not your cup of tea, that's the best way I think you can start off right now. But with this question, right, question number 6, or question 6, we have gone through 6 already, or gone through 5. But here we are. They said f of x is equal to this. For 1 mark, you see, 1 mark determine the period. So they're only offering the 1 mark because they know that with your period, you have a formula that you need to remember forever and ever. Amen. So that period formula, this is how you remember it. So firstly, your formula is actually, it goes like this: frequency is equal to 360 divided by period. This is for period, you see, this is for a sine and a cos graph, you see. However, for a tan graph, your frequency, you can already guess it. I mean, you're smart like that. Frequency is equal to 180 divided by the period, you see. So don't forget these formulas. This is just a U, by the way. So to work out your period, you need your frequency. And we have our frequency, you see. The frequency is always this number directly next to x, because you see your brackets here. You see, your equation of any graph, especially a trig graph, will always be in this format. Your equations will always be in this format. Your trig function here, let's put here, for example, 10. And then here you'll always have, what is that? Bx minus p, and then here you will have the plus q. Yep, this is your standard form. Don't mind the square brackets. I don't know why I did that, so extra. So you see, this is your standard form. This will always mean amplitude if you're dealing with sine or cos. This is your frequency. This is a shift from left to right. This is a shift from top to bottom. And you might be like, why are you going so fast, bruv? Come on, chill. Well, yeah, for this question, you know, we're trying to work out the question paper and stuff. But again, as mentioned, full tutorials over here. Full tutorials. I don't know how many videos I have so far. I think there's like 90. Well, I was recording this video, so I don't know how many there are now. I mean, like, you know, always adding. So here, frequency is this number here. So you use it to get your period. You see 3/2 is equal to 180. You can say here P. Now to get your value for P here, you can just cross multiply. P times 3 is 3P. 2 times 180, that's 360. Divide both sides by this 3 here. You're going to have 120 period is equal to 120. And because this is a 1 mark question, I mean, if you just wrote 120, yep, you're safe. Yeah, you're safe. You are very safe. So that's your period. What that means is it takes 120 degrees to get a complete graph. More info here. I'm really not trying to plug myself. I'm really just trying to, you know, let you know what you need to look at if this is not very friendly to you. Now it says here, point A, this is what point A is. It lies on the graph. Determine the general solution of T. T? Oh, come on, man. Well, oh, okay. Well, T is in the place of X. So this question for 3 marks is literally asking us to throw this coordinate into this equation and then just solve for T. That's literally what they're saying. This point is a point on this graph. This is an X value. This is a Y value. You see, X value, Y value. They said determine the general solution of T. So it just means put Y here, put T there, solve for T, and then do it in like general solution style, meaning you're gonna get reference angles and all that shandies. So in our let me see here, this thing is, excuse me, we're almost going. I'm just trying to remove this thing here. It's gonna go black. Oh no, it's not black, it's actually white because I had tangled myself. Entanglement. Entanglement. Why are we speaking of entanglement? Let's see here. So for 6.2, right? All you need to do is this. You need to take your equation. They said A is this coordinate. What is D? 2. T and 2. So this is X, this is Y. In your equation, obviously where Y is, you're gonna drop a 2 there. And then where T is, you're gonna drop, where X is, you're gonna drop a T. T. X 10, 2, negative 210 with 3/2 T, like that. That's what we need to do. Now, solving for T here, you're obviously going to divide by -2 on both sides. Divide by -2 here and there. and then you're going to get negative 1 is equal to 10 3 over 2t. And then here, this is where you gotta be careful, okay, bro? Okay, dude, okay, girl, or whatever you want to call yourself. Okay, this is where you want to be careful. Very careful. So you see, this is a negative number. This is a negative number. So we need to get a reference angle to work with. Now, the reference angle that we're going to get, you always use the positive value of whatever you're working with. So you see here we have a negative 1. You always need to use a positive number. You see, it's like non-negotiable type of thing. So always remember to use a positive number. So here in our calculator, you want to put the shift 10 positive 1. So let's put here to get a reference angle. Shift 10 positive 1, 45. You see, 45. So what you do is, before you start, you can put like your cast diagram here, CAST. So you want to work with where 10 is a negative. So you're going to work here and here. Now here you've gotten your reference angle to be equal to shift 10. Let's put here shift 10 positive 1. Your reference angle is 45 degrees. You see. So remember, for what? We're dealing with the second quadrant first. So for the second quadrant, shing, shing, it is always your angle, your value here, right? 3 over 2t is going to be equal to 180 degrees minus your reference angle. You see, and then plus k 180. K is an element of integers. So let me just leave this up for a second or two so that you can like take some time to take it in, you know, and all that. So here, that's what you do for your second quadrant. You see, for your other quadrant, which is what is the other one? The other one, what's the other one again? I mean, what is it? What's the other one? 4, man. Why you gotta think so weirdly? Yeah, in our other quadrant, we are obviously going to have the what are we going to have? Let's say the fourth quadrant. Let's just deal with this first before we make things crazy and stuff. So it's just going to be 3 over 2t is equal to 180 minus our reference angle plus k 180. K is the element of integers. And then here, if you simplify here, this is 180 minus 45. That's just 135. Plus k 180. K is the element of integers. So here, we are what? We need to just solve for t now. 3 over 2t. So if you're going to have t as the only variable left, if you want to isolate t, well, you can obviously divide by 3 over 2 here. Divide this whole thing by 3 over 2. And then you see what's going to happen is in your calculator, you're going to put the 135 divided by 3 over 2. What is that? 90. Okay, so bright. So this is going to give you 90 plus, and then 180 minus 3 over 2. You also need to do that. 180 divided by 3 over 2. I meant divided. I'm sorry, I meant divided. Plus k 120 is our answer here, because 180 divided by 3 over 2 is 120. And then k is the element of integers. Now you may be asking yourself, why don't we just do it for the fourth quadrant as well? So for the fourth quadrant, you would have had the IV, and then it's just 3 over 2t is equal to 360 minus your reference angle, 360 degrees minus your reference angle, plus k 180. K is the element of integers. Okay, and then here, if we carry on, we're going to have the 315 3 over 2t. This is going to be plus k 180. K is the element of integers. Divide by 3 over 2 on both sides. I don't know, I always write this too early. Like, why though? Come on. this cancels that. Our t value here in your calculator, let's see there, 315. Yeah, was it really 315? 360 minus 45, what you get? Okay, it's fine. 315 divided by 3 over 2, let's see there, 210. 210 plus here divided by 1, divided by our 3 over 2 there, we got it to be 120 plus k is the element of integers. Okay, this should be fine. Get you 3 marks. So if you check with most memos, they just did this. So it's just like, what? Why? But here we go. The good news is obviously for these two values, if you throw t as 90 in your equation there, let's see what you get. Let's see. If you throw t as 90 there, let's see. Let's put here negative 2 and then 10 3 over 2 there. And then this here we got, how did you get 90, right? Let's see. That works out. And then let's try the 210 quickly. Works out as well. So these are fine. These are okay. You just leave them there. Moving on to 6.3 for how many marks? 4. It says there, on the grid, determine the graph of f. On the grid, I don't have a grid, guys. I don't have a grid. I'm gonna need to write it all out. Like, oh my god, the horror. So on the grid, they say there, on the grid, draw the graph of f for the interval negative 120 to positive 180, and then clearly show all asymptotes intercepts with the axis and endpoints of the graph. Oof. Very good question, this one, because this question is gonna legit help us showcase how you draw trig graphs anyways, because I mean, I'm sure we've gone through drawing normal graphs once upon a time, but then with the trig graph, yeah, this is what you do. So most people would say, why don't we just use the table method? So I hardly ever use the table method. You can use it if you want. So basically what the table method is, you know what, let me not be funky, let me not try and be all weird, let's just use the table method, because the table method is actually quite simple. So basically what the table method says is, well, firstly you need to, this is what, 6.3, right? Draw your grid nicely, don't make it fancy or anything, just draw a grid, you know, it's just a grid, it's nothing else, nothing extravagant. So this grid here, why did I make it so big? This is the y-axis, obviously. So from negative 120, let's just maybe do it like this. Come on, bro. I was doing such a nice line. Had to ruin it, didn't you? So until there, this is, you see, and legit this, if this was an actual exam, I would not even need to use a ruler, because no one says anything about rulers anyways. Just make sure that your sketch at the end is visible, it is clear, and it is easy to read. So you see, I have my Cartesian plane there, or whatever you want to call it. And then here, because we're dealing with such a large, not so large, this is our given domain, from negative 120 to 180. So a step, roughly speaking, usually a step of like 45 or 30 is good. So I'll choose 30, because you see, it looks like 30 seems like a nice value to work with. So let me count 30 is going back. See, this is going to be like negative 30, negative 60, negative 90, and then negative 120 somewhere there. So negative 120, negative 90, negative 60, negative 30. And then here we get like 1, 2, 3, 4. Let's put here 30, 60, 90, 120, 150. Where's 250 coming from? 150. And then here 180. See, just wow, such a perfect scale. Wow, man, wow. That's just weird, but yeah, I don't know, maybe it's just the confidence level, it's just like all the way high when it comes to math sometimes. But yeah, let's see, we have our Cartesian plane now. In terms of values going up or down, I mean, it's a 10 graph, so those you can just have a few of them. Let's put here 1, 2, 3, 4. Let's put here -1, -2, -3, -4. minus 2 minus 1. Kablamo! I mean, they didn't give me a grade, but look at that. Oh, yeah, you have a grade. Oh, oops. Oh, wait, fine. So the one thing you want to put first is, well, clearly let's put our equation in so that we can build from there. So our equation looks like negative 2 tan 3 over 2x. So this is the big idea. A standard 10 graph will have the equation y is equal to 10x. Now this equation will have an asymptote at 90 and 270, and obviously at like negative 90 and maybe somewhere at negative 270 if you're looking at it to the left. And then because it's a positive standard graph, your graph, well, our asymptotes, let's put them there, da 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 da. This is the standard one, right? Da 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 da. So I'm doing this so that you can, yeah, map out what we're going to do. But we said we're going to use the table method. But anyways, the standard graph looks like this, goes up, that, and then it goes down like that. And then here you see credit on to the left, and then here in the middle it's up, down, and then here is just going to be like that. You see, so it is what it is. So all you want to do is, what you can do for yourself is, you can what can you do? Well, you can just use the table method. Here, let's not make things complicated because it's just a format question. So what it means is in your calculator, well, you can clear it first if you want. Shift, clear. Oh, yes. Do the things. And then now, let's see. So you want to sketch this graph. What you do is you press mode and then table. Tafel. Yay. Yeah, I don't know what press is in Afrikaans. I really don't. I just know table is tafel. Ons sal gebruik die tafel method. So what you're going to do is, in your calculator, we're going to put the negative 2 and then 10, you see, and then close bracket. Now you want to map it exactly what you see here. So the fraction button, 3 over 2. Hey, 2. Next to it, you want to put x. So to get x, you're going to press alpha and then this other bracket button, you see? See? Let's make it focused. Alpha and then the bracket. Alpha and then this close bracket button. There we go. If you had used any other letter, it really doesn't matter because you have many letters here. A, B, C, D, E, F. But, I mean, there's X, so use it. I mean, you see. So we have put our graph into the calculator. Then you press equal to. It's going to ask you to put in another graph, but we don't have another graph. So you just say equal to again. We want to start at negative 120. So where's the negative symbol? Yeah, negative 120 equal. We want to end at positive 180. And we're using our given domain, you see. It's not from the top of our head, this. So we want to end at 180. So let's put here 180. And then step, let's make it 30. 30 because we want to go in 30 intervals of 30. 30, 30, 30, 30, 30. So this is 30. Equal to. And then we wait. And then kablamo. You see all the errors? Ha ha ha. Those are giving you your asymptotes, boss. So you can even just go ahead and put those first. So let's put here, we got a asymptote over here. Ek weet nie wat 'n asymptote is in Afrikaans nie. So ek sal nie dit yeah. That's where my Afrikaans bundle ends. I really don't even know what to say after that. It's just like game over. It's chai, gone. So we have this dotted line there again, another asymptote, and ooh, another asymptote. Would you look at that? Well, thanks, man, thanks. So let's put that there. So we have our asymptotes there. And then now you can just use your data to map out the sketch. You can actually plot it and then just throw it afterwards, you see. So negative 120, it's at 0. So negative 120 is at 0 there. Yeah, let's just put this somewhere where I can see it nicely. There. Don't be blurry now. It's not the time to be blurry. Negative 90, it's at negative 2. So negative 90 is like negative 2 somewhere there. Hey, come on. Right. And then we have an asymptote. And then if you go down, it is negative 34. So for negative 30, it's at positive 2. Ooh. Okay. That escalated. And then here, it's at 0 again. For 0, it's at 0. So Don't worry, the shape is going to come out. It's going to come out. There's no choice. And then down here for 30, it's going to be at -2 again. So we got down there. And then for 60, we said that's an asymptote, hence why it's an error there. And then because the graph won't go there, for 90, it's at +2 again. So it goes back up there. It's up there. And then for +120, it's at 0. And then at -2, that's for 150. 150, it's at -2 again. And then at 180, it's a asymptote. So you see, here, the one thing you want to remember is, you see, it's a -10 graph anyways. You see, this is a standard +10 graph. A standard -10 graph would have looked something like this. It would start by going down. And then here you'd have what? I'm lost. I'm lost, ma'am. Ma'am, I'm lost. Please, come find me. Let me see. Oh, yeah. It would need to, like, go curvy like that. And then go down like that, you see. And then you have an asymptote. And then here you would need to have something like that. And then towards this side, you would have that. And then an asymptote. And then you'd have this here. And then another curve there. And then, hey, yeah. My 10 graphs. Look at them. So pretty. And you see it's even touching, but it shouldn't. Well, I think you get the idea, you see. So with our case, that's the idea. These curves are going to be going down, you see. Like here, you can already see the picture. You see, it's going down. It has to go down. Then it curves. Then it carries on going down. And you see, the ones that I'm actually going to, have on my answer, those are kind of nice. You see, they're fine. Then here you do the same thing. Just make it curvy. Just make it go down, go down. Let's put there, go down, go down. There we go. Then there we go. Kablamo. And you see I'm like making it sketchy. That's fine. That I've done that for all the papers that I submitted in my exams and got all my marks, like all of them, all the marks. So here you see it ends here, so you don't make another one there. It has to end there. And then here, yeah, this I mean 100 marks, guys. I mean, look at this. They said draw it on this, clearly show your asymptotes, yes, intercepts with the axis and endpoints. You see, intercept with the axis, 1, 2, 3, and then we got our asymptotes over there, and I mean it's all there. It's all there, examiner. So give the marks now. So here now it says use your graph to determine for which values of x. The question we've all been waiting for as well. Use your graph as in this picture. Okay, we're going to use our picture to answer this question, because if they say use your graph and you don't use your graph, you're wasting your time, man. If they say use your graph and you use the equation, wasting your time again. So here they said use the graph to determine for which values of x will your equation. You see here, this represents y values. You see, this is telling you use your graph to determine the values of x for which your y values are going to be bigger or equal to +2 for where x is between -120 to +180. So what they mean is, in your graph, I mean using your picture, your graph is between -120. This looks like a 110, man. Come on, fix it. Yeah, it's a -120. Yeah. So they're saying with our graph from -120 until +180, we should spot the points where your graph is above or equal to 2. You see, we want the points where your graph has y values that are bigger or equal to 2. You see, so I mean, where does y values equal to 2 start? You see here your graph has a y value of 2. Here there's a y value of 2. So let me get a pencil here for this one. So if you check, you see your graph is above 2 starting here going up. You see, above 2 starting here going up. You see, so this is the part that's above 2. That's the part they want. And this is the part that's above 2. That's the part that they want. So when they're asking you this question, determine for which values of x, f of x, come on, man, determine for which values of x will f of x be bigger or equal to 2, starting here going there. So if you look within that domain, the only portions where your graph has y values that are bigger or equal to 2 is starting here going up. starting here going up. So here they want you to give the x values, you see. So what that means is, looking at your picture, you need to trace. So you see it starts here and then, you know, it's going up. So that's fine. So you see this x value is from -30 until -60, you see, excluding -60, but it's getting there, you see. Here you do the same thing. This x value starts is at 90, or rather it's between 60 and 90, you see. So that's the span where your graph is above 2, and then this is also the span where your graph is above 2, between these two x values and between these two x values. So when you give your answers, you see, what question is this? It's 6.4. So when you give your answers for 6.4, all you need to say is, firstly, we are seeing that our x values need to be bigger than -60. You see, x needs to be bigger than -60. Not bigger or equal to, because it won't touch -60. It won't reach -60. It will get close, you see. So we have to say x values need to be bigger than -60, or our x values need to be smaller or equal to -30. So we're saying smaller or equal to -30 because at -30, that's a valid point, and at -30 our graph will be equal to 2, you see, because the question says, where is the graph bigger or equal to 2? So you see, it's bigger or equal to 2 between these two x values. So I almost ran out of film there, like that was almost sad. So yeah, you see, the first portion we have to say x needs to be bigger than -60, or x needs to be smaller or equal to -30. The other portion of your answer, you have to say that your x values clearly need to be bigger than +60, you see, bigger than +60, or your x values need to be smaller or equal to 90, smaller or equal to 90, you see, because these, between these two x values and between these two x values, those are the x values where your graph is having y values that are bigger or equal to 2. So that's how you answer that question, people. I understand these kinds of questions were always madness, but that's how you answer them. You see, they're just asking you, here, this represents y. You see, where the y value is bigger or equal to 2. The y values are bigger or equal to 2. Here they're equal to 2, you see, going up. Equal to 2, going up. So the x values where that's happening is from here to there, or from here to there. So you give those as your answers. Your memos will maybe have stuff like x is an element of -60 until -30 or something like that. Don't worry about how your calculator will have stuff. Don't worry about how your memos will have stuff like that. This is perfect. You can have your answers like this. That's going to give you all your marks. How many marks? 1, 2, 3, 4. You see, your memos may have something like x is an element of, well, here they would have open bracket for -60, and then for -30 they'll have a closed bracket to say from -60 to 30, or rather from -60 to -30. -60 is not included, and then they would have had stuff like x is element of +60 until 90, where 90 is included. You see, this here is fine, but then this and that, you can also have them out on your paper. You will get all your marks, so don't stress about stuff like that. Last and not least, for 2 marks. Oh, nice. So this is just a 2-mark question. This 2-mark question is point blank simple. And take note of how this 60 is a 60 degrees. So it's a shift from left to right, not a shift from top to bottom. So if you remember when we spoke about the standard form of your trig graph, we spoke about this, you see. So as long as you see something directly next to x, that means a shift from left to right, you see. If it was all the way here and it had no degree symbol, obviously that would be a value from top to bottom. So you see, shift from left to right, shift from top to bottom. So don't forget that. I mean, don't forget that. So here, this is just the equation of f moved 60 degrees to the left. Because if it's a plus, it's a shift to the left. If it's It's a minus, it's a shift to the right. Yep, it's just that weird. Wow, that's what the question wants. Well, okay. Describe the transformation of graph f to form graph g of x. Easiest 2 marks because there's literally not much to say here. So, but wait a minute, why does it look weird? Oh, our original graph. Uh-oh, where's f? Snap. I feel something bad about to happen. What does f look like again? Oh, that's what f looks like. Okay, fantastic. So they said here we should determine the shift from left to right. So, I mean, this does look like a graph that has been shifted. Oh, what am I doing? Let's see. So this is the original graph. And we know that if you move it to the... Oh, let's see here. Let's check this nicely. I feel like there's some catch here because why is it out of 2 marks? Like, why are you being funky, Matt? Like, why are you doing this? Negative, let's compare the two. Negative 10 there, yes. And then here you have 3 over 2x plus 60. Yeah, that's just crazy. That's just proper crazy. So let's see here. Oh, okay. So with a question like this one, you want to be very careful because let's see here. The graph of f, right? Technically, this is our frequency, yes. But then here, let's see there. This is technically what's happening here. This is just one of those weird questions. Like, it's just so bad. It's like, wow, guys, you gotta be so mean. Y'all just had to be so mean with this question. So g of x, firstly, we're not gonna directly say it's a shift to the left 60 degrees. It's a shift to the left, yes. That will get you 1 mark. But then you need to state how many degrees to the left. And here it's not point blank 60. And here is why. So g of x looks like this, right? G of x is equal to, what is g of x equal to? So let's actually use an easier method. Let's just make things simple. So firstly, this is the new graph of g. You see what's inside 10 here? There's 3x plus 60. So we have the 3 over 2x plus 60. You see, this is for the graph of g of x down here. For the graph of f of x, we had what did we have for the graph of f of x? You see, for the graph of f of x, we basically had the 3 over 2x, right? So here we basically have the 3 over 2 with, let me put here x. You see, so basically from f to g of x, we know that there's a shift somewhere along the lines. We cannot directly say it's 60. Here's why. If you move your graph of f a certain number of degrees left or right, what will happen is where x is, right, you will have an effect that will look something like that. You see, so I'll repeat. We had g of x, and then we had f of x, which was just 3 over 2x inside 10. Because you see, the f of x graph looked like this. Negative 2, 10, and then we just had 3 over 2x like that. Our graph of g of x looks like negative 2, 10, and then here we have 3 over 2x plus 60. You see, so what we're saying is, if you're going to move your graph of f to the left or to the right, what will happen inside here is this 3 over 2 will be here, right? But then where x is, you are going to move it left or right, meaning you'll have a value for p there. You see, so that's basically what's happening here. Your graph of f was moved a certain number of degrees, and we know that once it was moved, this is what it ended up as, this whole thing here. You see, this whole thing here is represented by this whole thing here. So all we're going to do is, this is just an equation here, basically, because this is represented by the graph of g. Here we said if you move f of x a certain number of units, you're going to have a placeholder here, you see. So if we solve this equation, funny enough, the x's are going to cancel out at some point. But then we're going to solve this equation to find out what the value of p is. because the value of P, considering this negative sign, will give us the shift from left to right. I know it's just a 2-mark question, but then this may be the easier way to say this without like just botching the answer or something. So here, solving for P, you're going to multiply the 3 over 2 inside, 3 over 2P here, and then here you're going to have 3 over 2x plus 60. And then, if you take the 3 over 2x to one side, you're going to have 3 over 2x here minus 3 over 2x there, and then plus 60. This is equal to 3 over negative 3 over 2p. This is obviously going to cancel out, and then you have 60 is equal to negative 3 over 2p. Divide by negative 3 over 2p on both sides. I mean negative 3 over 2, sorry, only. You're going to have this cancel out, and then p is going to be equal to negative 40, you see. Now be careful. If you throw negative 40 there, you're going to see 3 over 2 with x and negative 40 here where p is. You see? And then this is clearly showing you that you have here 3 over 2 with x plus 40. You see? Now you can see what the shift was. The shift was 40 degrees left. You see? Because all we said was, okay, fine, there's a shift, right? So meaning there has to be x being minused by something. So the moment that shift happens, we know that this ended up as 3 over 2x plus 60. So we said as long as we get a value for p here, you know, we're seeing here this is just x plus 40, so it's a shift 40 degrees to the left. Because, I mean, if you simplify this, you're going to end up with 3 over 2x plus 60 anyways. You see, this is what they gave us. So we had to, like, you know, just do whatever we can to find out what this plus 60 is representing here. You see? And this is how we did it. We said for f of x, it's just 3 over 2x, you see. So the moment you move it to the left or to the right, where x is, you have to put a minus p there to show that there's a shift that has occurred, you see. So this shift that has occurred is being represented by 3 over 2x plus 60. And then whatever we have here, we just said get a value for p so that you can drop that in there up here so that you can see that, okay, my graph of f was just moved 40 degrees to the left. So this is for 6.4. Very, very interesting question. But let's move on. Let's move on. If it's not your cup of tea, it's fine. Still have 3 questions to go. Gosh. That was a weird sound. But let's see here. Question 7, right, says a pilot is flying a helicopter. What's up? And then it says here at point A, she is flying, yeah, it's probably a she. He. A pilot is flying a helicopter. And then it says at point A, which is h meters directly above point D. And then it says here, he notices an object at B. Why are you noticing this object? You're supposed to be concentrating on flying. Then it says here that pilot determines the angle of depression from A to B is 30. So the angle of depression from A to B is equal to 30 degrees. And then he says he also determines that the control room at point C, he determines the control room at point C is 3h meters away from A. And then here he also determines that BAC is equal to 2x. So that angle here, BAC is equal to 2x. You see, BAC is not saying, BAC is not this tiny part plus this tiny part. No, BAC is a whole angle on its own, you see, because it's a 3D triangle. And then it says here points B, C, and D are in the same horizontal plane. And then it says this scenario is shown in the diagram below. You see, so this is the distance from the ground to the helicopter, and then on the ground, these are all points on the ground, you see. So then here, an angle going to, the angle of depression between A and B is 30. this value is 3H. You know, they just gave us random information. Not random per se, but they gave us information which we are going to use. Fine. So for 7.1, they said for 2 marks, determine the distance A, B in terms of H. Okay, very interesting. So with a question like this one, right, you don't want to overthink anything. And when I say you don't want to overthink anything, I mean, what do I mean? I mean just that, you know, don't overthink anything. Your answers are somewhat bottled in your description and bottled in your sketch as well, you see. Because the one thing you want to remember is that they want us to determine, what do they want us to determine here? They want us to determine AB, this AB. So to get AB, we can basically use this right angle triangle here. Now with this right angle triangle, we only have H, you see. But then the other thing is we also have this angle here. This angle here is going to be 30. The reason is, you see, your angle of depression is going to be equal to this, because firstly, your helicopter is like flying here, you see, right? Your helicopter is flying here. This is point A. And then here you have the ground, you see. And then they said your angle of depression there is 30. See? So if the angle of depression here is 30, it means that this angle with the ground is also going to be equal to 30. Because remember, if you're flying straight, you're parallel to the ground anyways. You see, the helicopter is flying, so we cannot assume it's flying downwards or flying upwards. No, it's flying straight. You know, helicopters need to fly straight. Otherwise, what are you doing? So you see, this is A, this is B, and then there's D here somewhere, you see. There's an angle here of 30, so this angle here is also going to be 30. So we're just going to state that is equal to 30 because of alternating angles. So that's the first thing we're going to say. A, B, D is equal to 30, and then these are just alternating angles. So this kind of a question should give you the idea that with math, don't overthink anything. I mean, you know, don't want to argue with the paper because it's not going to end well, you know. So here we have this angle is 30. That gives us more information in this triangle here, because this is a right angle triangle. This is D, this is A, this is B. So if this is 30, it means that, let's see, if you're going to get AB, right, you're going to have, this is hypotenuse and this is opposite. It's just labeled H, but that's opposite. So here, let's see, opposite and hypotenuse, we can use sine. You see, so here if you say sine 30, let's see here, sine 30, we know it is opposite, which is H, over hypotenuse, which is AB. And then getting a value for AB, we can multiply by AB on both sides, times by AB there, times by AB there. And then we have AB sine 30 is equal to H. Divide by sine 30 on both sides, we're going to have AB. Paper, please stop moving like us, I believe. H over what? Over sine 30. Well, sine 30, we know what sine 30 is. I would rather simplify this thing here. Yeah, because here you technically have H divided by sine 30. And then in your calculator, sine 30 is just a half. You see? So this is technically just H over 1 divided by a half, which is just H over 1 times, you flip it over, so it's going to be 2 over 1. And then there's just 2H. So you see? Very important stuff here. My paper keeps moving because it's, you see, it's not like stuck to the ground. It's like so annoying. Paper, I thought we're on the same page. Now you're being on the sides of the examiners, you know, trying to make us fail here. So anyways, that's AB. AB is 2H. AB is 2H. So you got AB, you can label it 2H if you want. Yeah, I'd suggest you do it. 2H. So we have values there. Now for 4 marks. Okay. They say it shows that the distance between the strange object at B and the control room C is given by this equation. So what I suggest is, this question, just imagine they said get an expression for BC. So whatever you do, get an expression for BC and then eventually do what you can to make it look like this. Because whatever you're going to do to get BC, you will end up with this anyways, you see. So try not to focus too much on this early on. Focus on your sketch. Your sketch has all these values here. There is angle 2x there. Oh, okay. There is a side given here, you see, and a side given there. And then you're looking for a BC. See, that's the cosine rule, you see, because we have a triangle here. You see, this triangle, this angle here is given. It's 2x. It's technically given because it's a value. You see, this has x's and h in it. So use the x's and the h's. Don't be like, we don't have values and stuff. No, you have them. Use them. So this is A, this is C, and then there's B down here somewhere, right? So here we have a value, it's 2h. Here we have a value, it's 3h. And then here we have a value, it's 2x, the angle there. See? So that's point blank the cosine rule, because the cosine rule, you use it when you have two sides and an angle in the middle. That's your cosine rule. So we're legit going to use the cosine rule to get a value for BC, because that's what the cosine rule says, you see. The opposite here will go with this angle. So your formula, you remember your cosine rule always has stuff like a squared is equal to b squared plus c squared minus 2 with these two, 2bc, and then cos a, you see. So this, always remember it goes with that, you see, meaning for our sketch, the angle that you have, which is this 2x, has to go with this value here, which is BC, you see. So BC has to go there, angle has to go there, and then these two here, there's 2h here, there's 3h here, there's a up there. Those two are being represented by that. So if you want to write it out even as a formula first, you can. It's just BC squared is equal to AB squared plus AC squared minus 2AB times AC times cos ABC. I mean BAC, like that, you see. And the big idea here is just so that you can see what's happening, what we're going to throw into our formula. And you see, that's why there's also just a 4-mark question, because we're just using the cosine rule here. This paper was actually, honestly speaking, not that difficult. The guys in 2018, yeah, rolling okay paper, don't even lie about it, because we are seeing it here. So BC squared, let's see here, BC squared is what we're working out. BC is what we're working out. AB is 2h squared. So remember, take things slow. 2h squared. AC is 3h squared. 3h, the whole thing squared. And then you have 2h, and then 3h. You see, because AB and BC anyways. And then here you have cos 2x. The mistake I always used to make was, I always forgot that this is together. So I cannot say this goes with that. No. This is on its own. This is on its own. So this is just 4h squared, because the squared goes for the 2 and the h, because they are pasted together. You see, 2h squared is 4h squared, because they are pasted together. The 2 has to be squared. The h also has to be squared. Remember, if it was 2 plus h squared, you cannot say 2 squared plus h squared. That's wrong. You see, you'll have to say 2 plus h and then another 2 plus h, going on and on. So remember stuff like that. They're small, but you know they're important. 3 squared here is 9. H squared here is h squared. And then here you have negative, let's see here, 2 times 3 times 3. No, 2 times 2 is 4. 4 times 3 is 12. And then h times h is just h squared. See, no, we didn't do anything funny here. We just said it's a negative 2 times 2, so it's a negative 4. Negative 4 times 3 is a negative 12. And then h times h is h squared. So this is cos 2x here. And then we need to, don't worry about this for now, I guess. We can just leave it. Here we have like terms. 4 plus 9, that's just 13, h squared. And then minus 12h squared cos 2x. So the mistake I was referring to is, you see, it's easier to say, oh, 13h squared minus 12h squared, like terms, and then have negative 1h, and then have 1h squared. No, that's wrong. You see, these two, you cannot do anything to them, because you see, this is together, and then this minus is telling you that two different terms. So they are not like terms, because there's cos 2x here. So the least we can do here is, I mean, we need a value for BC, right? So now you can start checking and seeing what do they have for BC and what do we have for BC. So what I mean is, what am I still doing with this? Go away. You don't need to no more. Okay, that's kind of mean, but it's just the paper. It has no feelings, but let's not be extra now. So here, BC, you see what we have here? We have this here. Now we have this here. So I would not go ahead and square root yet. No, I would try and finesse things first. What I mean is, you see here, technically, what do we have here? We have, this is a double angle, yeah. And I mean, yeah, let's see what we can do here. What can we do? Should we take out h squared as a common factor and stuff like that? Yeah, let's just compare. Is there 13 here? Well, there's 25 and 24. Wow, where are those gonna come from? Crazy. Well, we're almost there, unless I've made a weird mistake again, which is just depressing, but I don't think I did. So what would I do here? I would take out, this here is just making things weird, but let's see what we can. You see this cos 2x, remember that cos 2x is the same as cos squared x minus sine squared x, right? And it's also equal to 2 cos squared x minus 1, and it's also equal to 1 minus sine squared x with the 2 there. So keep in light of that, looking at what they want us to have at the end. You see here we have cos squared, and then here we have two things that have cos squared, this and this. However, this sine squared would mess things up for us. So let's do this. Let's change this into this first. The reason for doing that is we want to have something like this in our expression. So let's just carry that on. Let's do that before we do some squaring or whatever. So this is 13h squared minus 12h squared. The whole thing here in brackets, we're going to change it to this here. 2 cos squared x minus 1. And you may be asking, and remember we just mentioned why we're changing it to this. We're changing it to this instead because we want something that looks like this, you see, without the sign there. We don't want it, we want this. So if you simplify further, we're going to have 13h squared here minus, this is our 24. This times that is going to give you negative 24h squared cos squared x. You see, because here it's just 2 times this value here, which is negative 24h squared, and then the cos squared x just comes there. And then here negative 12h squared times negative 1 is going to give you a positive 12h squared, you see. So now we can see where that 25 is going to come from. You see what we did? We worked as best as we could, and then now we start comparing so that you get ideas of what to do next. Don't just do everything and then think you're going to end up with this. No. At some point in time, you do start off somewhere. You need somewhere to start. But then when you've seen that you have reached the end of your wits, then you just start looking at what they have and then start doing the things. So here, our BC squared is equal to, let's see here, 13 plus 12. You see that's going to give us 25h squared minus 24h squared cos squared x is going to be c squared. Now we can square both sides. It makes sense. Let's not do that. The reason I'm not doing that yet is because you see here we can see that there's h out. So let's see here, we can take out h squared as a common factor first. See if that's going to, no. Why is that? Yeah, let's just add this. Let me just redo that step. 25h squared minus 24h squared cos squared x is going to be c squared. So I'm thinking to myself, let's see, why is there h squared here? It's so weird. Let's take out, why is there an h here? So let's take out h squared as a common factor first. Let's see here, h squared, if you take it out, you're going to have 25 minus 24 cos squared x. So you're factorized now. Now the good news is now you can put a square root there. The reason is now once you've put your square root, you need to remember that your third laws tell you that, you see these two are being multiplied together. This thing times this whole bracket is being multiplied. So it means that the square root symbol goes for the h squared, and the square root symbol goes for this whole thing here. 25 minus 24 cos squared x. And then here, this h cancels that. I mean, this square root symbol cancels the 2 there, so you're going to have h here, and then this here now. 25 minus 24 cos squared x. So you see, you need to lower your laws and stuff like that. You know, this is being mad. This here, you factorized, right? So it's this thing here times this whole bracket. So when you put it under square root, the square root goes for this individually, the square root goes for this individually. And then you can just deal with both individually. And then guess what? Voila, that's what they have. You see? That's exactly what they have. 25 minus this here cos there with the square root h, da 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 da. 4 marks, you get your 4 marks, you move on. It's okay to move on. Just move on. So now we are going to look at question 8. Where is question 8? Yeah, let me just find question 8 and then we'll do question 8. Okay, question number 8 says that we have here P and O. P and O is the diameter of the circle, okay, centered at O. And then it says TM is the tangent to the circle at M. Okay, so you see here, they spoke about a diameter. I mean, already we should be thinking of Dr. Cape Town. Dr. Cape Town. So D reminds you of the diameter. So meaning anytime you see stuff talking about the diameter, remember this theorem. We already know that this is equal to 90 now. You see? And then the R speaks about the radius. I mean, I don't have to go through this again, do I? C, I mean, it's like cyclic quads. Hey, what's going on there? Hey, yeah, it happened. It's in the past now. P talks about parallel lines, you see. And then T talks about tangents. You see, where's tangent? Let's see, tangent in Afrikaans. Raak lane. You see, I checked. I was like, T is a. TM is an reuk lane. I don't know what that is, right? Reuk lane? I don't know. Yeah, but tangent. T is for tangent. Yeah, Dr. Cape Town, the tutorial, you know, it's on the other channel if you want to look at it and stuff like that. The main one. So they gave us the diameter. We got a theorem there. They gave us a tangent, so automatically you should also be thinking of a theorem. Now look. Turn your paper around. Let me flip this thing around. Let me flip this camera around. Let's see. You see it? You see it? Do you see it? No. Oh no, no. This is not working. Let's do it. Flip the paper. I'm so dumb. So if you flip the paper, right, you will see that you see this angle here. This is an angle at the tangent. You see there's a tangent and a chord. Remember the 10 chord theorem? The 10 chord theorem says you have a tangent and a chord, you see. So whatever line or whatever angle rather is going, or whatever angle is subtended by this chord here is equal to this angle. You see, the angle subtended by this chord is also equal to this angle. You see, so you should check the angle here is being subtended by this chord there. You see, that's what the 10 chord theorem says. A tangent, the angle between a tangent and a chord is equal to this angle up there. You see, the 10 chord theorem, because you have an angle here subtended by this chord, and then you have an angle here between this tangent and this chord. So as long as these 3 points are touching the circle, you're safe. So if this was 66, by the way. So I might as well flip it over and write 66. 66, where are you? Over here, 66 degrees. Okay, well, technically we already know what this is if we ever need it. But moving on. Let's keep things moving. Can't be dwelling. Ooh, dwellings. I did not just say that. TM is a tangent to the circle at M. Yes. A point, TM is a tangent to the circle at M. M is a point on the circle. And then it says R is another point on the circle such that OR is parallel to PM. Yes, we can see that. And then it says NR and MN are drawn. Yeah, those are just lines drawn. So, okay. And then it says your M1 is equal to 66. Thank you. Well, you know, all Euclidean geometry questions that actually have like angles given, those are the nice ones, because it's like, oh, they gave us numbers. Wow, oh my goodness, these guys are so nice. But you'll always have a question like that in your paper, one that at least has numbers and stuff like that, so that you can, you know, get some marks. But anyways, let's see what we can do here with this question. So for P, let's see here, they said calculate with reasons the size of each of the following angles. So for 2 marks, let's see what they want us to do for 2 marks. And why are you blurry again? Please tell me. Please tell me why you're being weird. 2 marks. They want us to get P. So P. Oh, look at that. That was weird. But yeah, we already got P. Yeah, because yeah, we're smart like that. But yeah, let's not get ahead of ourselves, because hey, this paper is still got a long way to go, man. Not really, just 2 questions left. Whoop whoop. So P, we say this is equal to, we need to say P is equal to M1, and our reason is the 10-chord theorem, M1. And funny enough, the 10-chord theorem is the one theorem which you can actually say as a reason. You see, if you check your memos, they also do stuff like that. So P is equal to M1, which is equal to 66 as well, and then the reason will be 10-chord theorem. So if you want a tutorial on all the theorems, I mean, you know the drill. It's on the channel, the main channel, Bright Young Brains, blah blah blah, all that shandies. So M2, they want us to get M2. Ooh, another 2 free marks. Okay, that's fine. Thanks, guys. Such nice people, these examiners, sometimes when they want to be, but sometimes yo. Yeah, let's not go there. M2 is equal to 90. Our reason is angle subtended by the diameter of a circle. There we go. Angle subtended by the diameter of a circle. 8.1.3. Let's see there. Because you see here, statement, reason. 2 marks. N1, 1 mark only. Guys, but ish, here we're only going to get 1 mark. Sharp, Joe, sharp. You see, these are interior angles of a triangle there. So N1, we're going to say N1 is equal to 180. And then minus what? Let's bring them closer to each other. Don't keep them too far from each other. They're going to get cold. Okay, what is that? N1 is equal to 180 minus M2 minus P. You see, minus M2 minus P. The reason is interior angles of a triangle. You see here, we're going to write the most, but we're only getting 1 mark. Wow, these people are so mean. Like, okay, fine, we'll take the 1 mark. We need it. We definitely need it. I mean, hey, that 1 mark. We all know what 1 marks can do. 24 marks. I mean, 24 degrees. 24 degrees. That's the answer there. 28.1.4. We want to get O2. Well, wow, guys. Another 1 mark or 2. Let's see. Ooh, 2 marks. Thanks, Billy. Because, this one is flowing. Well, O2 is going to be equal to P. Why? Because they're parallel lines. You see why Dr. Captain is necessary? Because parallel lines remind you of fun. F-U-N, or fuzz. I don't know why you would say fuzz, but I want to have fun, not fuzz. But anyways, each to their own. So if this is 66, this is going to be 66. So let's just state that O2 is equal to P with a reason. So let's put here 8.1.4. We say it here. O2 is equal to P. Let's see. O2 is equal to P, which is equal to 66 degrees. What's our reason there? Corresponding angles. Why am I writing out the whole thing? Like I got ink, huh? Corresponding angles. I save ink, guys. There's this joke someone was telling me, but hey, yeah, let's just leave it alone. It's not time for jokes, this. Really? Yeah, I mean, yeah. 8.1.5, N2. You get a value for N2. Oh, now they are starting to be funky. Like, oh, now you want to ask serious questions. You were busy here giving us questions. Now this, like, what is this now? But they want us to get N2. So you see N2 is 3 marks, so you obviously need to do a bit more thinking here. Yeah, I see now. I'm like, okay, got a serious question. So let's put in what we have. This value here is 24. This value here is like 66. Where's my 24? Is it clear? I hope it's clear. But yeah, you see the 24, there's 66. It looks like 6,624. But ish. It's for separate angles, ne? For O2 and for N. So they want us to get N2. So it looks like for us to get N2, we might have to get the whole thing. I don't know. That's just a suggestion. It's just, a way of thinking. It's not right. It's not wrong. I got something. Something just clicked. So you see here, to get N2, we said we may have to get this whole thing here. So let's just get this whole thing. And we can, you see, because look at this. Look here. You see why this stuff is necessary to know. You see angles on an exterior angle of a triangle, right? You see here you have this line here, P O N, and then you have this thing going on. There's R there, there's N here, there's O, and then you see there's like a split here, like that. There's N1 here, there's N2. We already have N1. You see, it's covered. This one we have it. The only thing is, you see, we have this as well, which is 66. So what we're saying is, you see, with most questions, try and focus not too much on everything. You have to take into account everything, yes. However, you also just need to remember your small laws and everything. Like here, I have a triangle, so I mean, there's an exterior angle here, so don't take that for granted. So basically what we're going to say here is that this entire angle here is equal to this. Oh man, yeah, I kind of ran myself into a wall, because I was like, oh, we're gonna say this exterior angle is equal to these two combined, and then we're gonna get N2, but it's not working. It's not working because I don't have R. So you see, it's fine. You come up with ideas. If they don't work, you change them. But what are you going to do with an idea that's not working? You change it. How? Change it. So that's not working. So let's see what we can do. Let's see what else here. In terms of us thinking of theorems, let's see where N2 is going. N2 is going to M and R. There's no other angle going to M and R. So yeah, you see, when things get a bit weird, ne? I turn upside down the picture. I turn it upside down, and then I don't know, some things might start. Oh, you see why turning upside down is good? I'm sure you probably saw it, but I mean, this angle here is equal to 90. Wait, how is that going to help now? Let me think why this is useful to us. Wow, actually, I don't know. Maybe it's going to help us get the angle. Goodness, yeah. So, yeah, this is 90, right? So what else do we have? Well, we have information here. If this is 90, technically N2 plus R should give us 90. So I mean, everything is leading towards us getting a value for R first, one way or the other. But the other thing is, you could check in your question if there's a point where they're going to ask for R. Nope. So might as well get R first, and yeah, maybe it will help us get our answer. Where's the thing again? So let's see if there's a way to get R. If you found the answer already, then good for you, bro, or good for you, girl. Cause now I'm just struggling here. I'm just like, what's going on? Why is R? What do we do for get R? Like, oh my gosh, this is too much. Hey, yeah, I'm being extra now. So just chill. So let's see here. We have 90 over there. And then what else do we have? Let's see. Let's see here. We get quite a lot of stuff here. But it looks as though, well, technically, if we're going to use Dr. Cape Town, do we have a radius? Boom. You see, Dr. Cape Town comes to the rescue. Because I was like, do we have a radius? Because you see, I was like, diameter, we use diameter already. But then I was like, do we have a radius because of Dr. Cape Town? Yes, we do. Because you see, OR is the radius, because it's the line from the center to the edge there. ON is also a radius, you see, because it's the line from the center to the edge there. So, trust me, that's going to get us OR. That's gonna get us N2 actually, because you see, look here. So we have this line here, you see, OR. Wow, this is so cool. At least now we can showcase why Dr. Cape Town is useful and why you want to use it. So let's see here. This is N. And then these are equal to each other, you see. And then we already know that this is 66. And then here you see we have like a mini, and then it's like cut here a bit. It's not cut in half. We just know that one side is 24. So what we're going to do is we're going to use the laws of an isosceles triangle to get what this angle is and to get what this angle is. You see, because these are equal to each other, because base angles of an isosceles triangle, boss. So, so let's do that. So firstly, we're going to state that OR is equal to ON, red eye. So OR is equal to ON, red eye. And all this thanks to Dr. Cape Town. I mean, this question, guys, credit to Dr. Cape Town. This is why you should use Dr. Cape Town. It works, guys. It worksies. It worksies. Yes, it works. Yeah, works isn't that a word, but nobody cares. So OR is equal to ON, red eye. So now we're going to say that, therefore, ORN is equal to ONR. You see this angle here, ORN is equal to ONR. The reason is base angles of N. I forgot how to spell isosceles again. I remember in like the first paper too, I kind of learned how to do it and then now I've forgotten again. So yeah, isosceles, I think. Hey, goodness, base triangles, base angles, man. Come on now, base angles of N. This is maybe not how you spell an isosceles triangle, but I don't know, an isosceles triangle. So good thing is spelling doesn't count. So yay, woohoo! So as long as you're proving that these are base angles of an isosceles triangle, then technically you can now say, therefore, ONR is equal to 180 minus this 66 divided by 2. The reason is 180 minus 66 gives you these two. So because they are equal to each other, you know that whatever this is, you're just going to cut it in half to get you ONR. It's that simple. So let me say it again. Therefore, ONR, which is this angle here, the whole thing is equal to 180, the whole triangle, right? Minus 66 divided by 2, because 180 minus 66 gives you this and this together. So dividing it by 2 gives you the length of each, you see. So the reason for doing this is we can say interior angles of a triangle. So here we can just finish this up to getting ONR, which is, let's check what Dr. Calculator says. Dr. Calculator, okay, that's new. You see, it's still showing that, what? You see this thing here from the stats question. So you want to clear your calculator by pressing shift and then number 9 for clear, and then number 3 for all, and then yes, the equal to sign, and then AC. Boom. Now it's working again. 180, not that it was broken, but you know, it's doing that weird thing. We don't like that thing. So here 50, what is this? Hey, you see, where is the 22 coming from? Exams, guys, exams are a scam. Like, what is this? I mean, like, where is the 22 coming from? Huh? 57. Okay, so this is equal to 57. So we can here say therefore, and wait, we're looking for N2, right? Yeah, therefore N2 is equal to 57 minus 24, which is equal to, what's 57 minus 24? 57 minus 24, 33. You see, I mean, this is given. This 25 is, we worked it out. When did we work it out again? 8.1.3. So if you want the reason for this thing here, you can put the 8.1.3. We proved that this is equal to 24 there. So not a big deal, stuff this. So 33 degrees, you give it as an answer. And then you move on. You move on. You throw yourself a party in your head. Take 2 seconds or so to celebrate. But you're still in the exam, so it's not over. You gotta get back in the game and yeah, man, just keep going, just keep going. Keep going. So let's see over here. We got a question. Okay. Yeah, I thought the description was so much, but that's the Afrikaans part. So if you're Afrikaans, then here you go. So if you're English, here you go. If you are none of the above, well, here you go. What's up? In the diagram, AGH, where is G? AGH, okay, is drawn. Then it says F and C are points on AG. Hey. F and C are points on AG and AH. Okay, yeah. AG you see, and then there's F. AH and then there's C. Okay, yeah. Okay, makes sense. I was like, hey, these people, what you saying now? And then yeah, respectively, such that AF is equal to 20. Okay. FG is equal to 15 units, and then CH, where are you? CH is equal to 21 units. Okay. D is a point on FC. D is a point on FC. Such that ABCD is a rectangle. Ooh, you're a rectangle. Okay. Then where are your lines? Where are the lines showing us that opposite sides are equal? These people. So here, if this is a rectangle, then put your own lines, guys. Put them yourself. And you they don't want to put them for you. They're mean. They're strict. They are stingy with their lines. They don't want to waste their printer ink, but it's fine. We have our own ink there. Rectangle, opposite angles are equal. If they say this was a square, then you would say all of them are equal, but it's a rectangle. You see, a rectangle, guys, is not a square. It's a rectangle. So, it says that this rectangle with AB also parallel to HG. Yes, the diagonals of A, B, C, D intersect at M. Okay, And then it says here a point on AH. Yeah, M is a point on AH. Whew, okay, this description though. Yeah, so much information. Where's the question? Are you here? No? Hey, where's question 8, guys? Question 8. Where in the world are you? Let's see here. Question 8. Is that you? Nope. Hey, guys, I lost question 8. Question 8 is gone. Question 8 is gone. Like, I can't find question 8. Oh no, that's so tragic. No, I got it. Got it. That was weird. Always extra. Like, just be normal. Let's see. So, finally. So, with all this said, the first question says, explain why FC, for 1 mark, okay? Explain why FC is equal to HG. 1 mark though. Well, I should stop complaining about 1 mark because we need those marks. Every single mark is important. So let's see why these are parallel. Let's see if there's like a funny theorem to look at, or we can just try and look for corresponding angles, or what, or gotcha. So you see here, this is a rectangle, né? Remember, I mean, if this is a rectangle, then opposite sides are equal, yes, but then if it's a rectangle, I mean, opposite angles are parallel too. You see, they didn't want to tell us that 1, 2, 3 are all parallel, because I mean, if this is parallel to this, right, it means that this is parallel to that, because I mean, this is a rectangle, you see, so opposite sides are parallel. So you see, these two are parallel to each other because this and this are parallel, and because this is parallel to this. You see, they're all parallel. I mean, I don't think I said that slow enough, but y'all are smart, so you got that, because parallel sides are, opposite sides of a rectangle are parallel. So if this is parallel to this, and this is parallel to that, it means that these are parallel to each other. I mean, it's there, it's in our faces. So we just need to show them that FC is parallel to AB, or let's just say AB is parallel to DC. Then what do we have to write here? 8.2.1, right? 8.2.1 How do you write your 8s? May I write my 8s like 2 rocks on top of each other? So sometimes one rock is up there, the next one is there, and then it's like a gap, and then it's like, hey, what is that? But 8.2.1, we can basically state that AB is parallel to DC. AB parallel to DC. The reason is opposite sides of a rectangle. I mean, this is what a rectangle does. You see, opposite sides of a rectangle. So, I mean, AB, wait, let's say here, yeah, remember DC is the same as FC. I mean, DC is the same line as FC, so don't worry about how DC is just a tiny part. Then here we just need to say that AB is parallel to HG given, you see, and then therefore, what did the question ask? Yeah, therefore FC, where's my dot up there? Therefore, FC is parallel to HG, because I mean AB is parallel to this one, AB is also parallel to this one, so these two are parallel to each other as well. I mean, it is what it is. Moving on, it's just 1 mark anyway, so not a big deal. So 5 marks here. Calculate with reasons the length of DM. Ooh, DM. Yeah, let me not speak about DMs. But I mean, if you have math questions, you can DM your math questions. Just don't DM like questions of papers that you don't have memos for and stuff, because hey, those papers are shady, guys. Like, I had people sending me questions of, yeah, let's just not go there. Let's just keep that away from this video. But yeah, you can, if you want to, if you're working on math and you need help, you can send me the questions, but then just make sure it's like a question which you have like worked on, you have checked the memo, you have tried your best, and then you can send it, you know, because when you send easy questions, it's going to hammer your confidence, because I'm going to just send a simple answer, and then you're going to be like, oh snap, that's so simple, but why didn't I get it? So it's going to affect your mental capacity, your mental well-being. So try to work on the questions as best as you can, and then when you're really stuck, look at the memo. If the memo does not make sense, then you can ask. Then, you know, yeah, we keep it going. Yeah, how did that come about? Oh yeah, DM. Calculate with reasons the length of DM. Where is DM? There is DM. Well, I mean, if we're going to get the length of DM, chances are we're going to need to use this here and this there, and then this here and this there, because I mean, you know, yeah, we're going to get AC first using the proportionality theorem. You see, because AC we can get it using the proportionality theorem, because these two lines are parallel anyways. So if those two lines are parallel, then I mean, we got room to use the proportionality theorem. So with our proportionality theorem, we are basically going to state that AF over what? What are we going to state? Yeah, we're going to state that AF over FG is equal to AC over CH. And our reason for stating that would be what you call proportionality theorem, right? Or what? Yeah, proportionality theorem basically. Or line on one side of a triangle, or whichever way, we'll just roll with the punches until we get it. Stop laughing, dude. Just stop it. Let's just work on the question. So yeah, let's just see what we can do with this proportionality theorem. So we're going to say that AF, let's put here 8 point, let me bring this closer. Bring it closer. So let's see here, 8.2.2, right? Let's get some values here, you see, and then get more values into this picture. This question seems like it's going to be easy. So AF over FG is equal to AC over CH. The reason is what do you say now? This is one of those theorems where I'm always like, but you know what now? What's the real reason for this one? You see? So normally what I would revert to saying, I would always say things like proportionality of similar triangles. But then because we have not, well, this small triangle up here and the big one, they are similar, yes, but then in terms of giving a reason for this, you can write stuff like line parallel one side of a triangle. You see, it's just, yeah, like here you have a line parallel to one side of a triangle. It has the weirdest reasons on some of these textbooks, but let's see here. Here we can just say line parallel on one side of a triangle. You see, line parallel one side of a triangle. That's literally it. Line parallel one side triangle. It's the weirdest reason ever. But what we're saying is, you see, we have a triangle up here and a triangle, a big one there, and then their lines are parallel to each other. You see, one line of this triangle is parallel to one line of this triangle, hence line parallel one side triangle. Yeah, let's just say line parallel to one side of a triangle. Let's just put the 2 and the off here there. It helps, you know, line parallel to one side of a triangle. And then putting values in this shenanigans, we're gonna have the 20 over 15, which is equal to AC over 21. And the reason for doing this is, want to get values for AC, get more values into this sketch here. So here obviously you can cross multiply to get rid of the fractions. 21 times 20, that's like 20, 21, and then here this is like 15 AC. So let's see, 20 times 21, nangas, but let's just divide by 15 first. Divide by 15 there, and then this is AC, chop and chop. Put all that in the calculator. Let's see what the calculator gives us. Ooh, so bright. It's not focusing. Where is it? There. 20 times 21 over 15. 28. 28. 28. There we go. So we got AC now. Oh, got AC finally. Well, the thing is, you see, as long as you have AC, you are you're almost there now, because let's see here, this is AC, right? Remember, AC is the same as DB. I mean, it's a triangle, it's a rectangle, you know. So remember, our main issue is to get DM. So we got AC. So we just need to state that AC is equal to DB. And the reason why AC is equal to DB is because, I mean, those are diagonals of a rectangle. Diagonals of a rectangle are equal to each other. It's just simple stuff here. So here, let's just go ahead and say that, what are we going to say here? Let's bring the picture in the image, no, the image in the screen. So that, yeah, so here we're going to say that AC, you see, AC is equal to DB. The reason is diagonals of a rectangle, of a rectangle. So here, that's BD or DB. You see, DB, we proved that it is equal to 28 as well, you see. So if this is 28, well, remember that, I mean, diagonals of a rectangle, they cut each other in half anyway. So this is equal to that. I mean, when they say this is a rectangle, they gave us so many things, guys. You see how easy it is to like know some of these properties, because they're just so simple. I mean, it's a rectangle, opposite sides are equal, diagonals are equal, diagonals bisect each other in half. I mean, it's just a rectangle. So here we say this is also equal to 28. So let's say AC is equal to DB, which is equal to 28 diagonals of a rectangle. And then here we're going to just say that DM, this is B, on DM. DM is equal to MB. Our reason will be, let's see here, diagonals of a rectangle cut each other in half, or diagonals of a rectangle bisect each other in half. Let's say here, diagonals of a rectangle. How do you spell rectangle? Rectangle. Yeah, I was like, come on, bro. Rectangle. Diagonals of a rectangle bisect. Bisect means cut, you see. They bisect. bisect each other in half. I'm sure sometimes you might have some people think, has this guy even finished school? The way he writes though, it's like he didn't even go to grade 1. I need to grade 1, they teach you how to write. But this nigga doesn't know how to write. Oh yeah, guys, writing, eh? Diagonals of a rectangle bisect each other in half. In half. And you see this paper is moving. Diagonals of a rectangle bisect each other in half. You see. So here we can then say, therefore, dm is equal to 28 divided by 2, which is equal to 14. Very, 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 very simple question, this one. Because, I mean, every question was like, are you really serious? Are you really asking for that? Okay, fine, we'll give you that. Just make sure you give us our marks because we don't work for free. So, yeah, I think this question was okay. Not bad at all. Just straightforward, I guess. Very simple marks because the nice thing is they told us that is a rectangle. So everything we got here, it was literally coming from laws of a rectangle. Laws of a rectangle. So, yep, that's for question 8.2.2, and then that does it for question 8. No, that does it for question 8. Because the next one is question number 9. Oh yeah, and we're gonna go through the proof here. The proof. Yeah, let's dive into it. So, question 9 in this 2018 November Maths paper 1, grade 12, past paper. Question 9 was, it looked like one of those friendly Euclidean geometry questions, you see, because, I mean, look here, we have a proof which is straightforward, and then we have other questions here that actually have values given, like here, you see 30 degrees and all that. So with this proof, well, the good news is on the main channel, it's also there. However, because this paper also has this as a question, we are obviously just going to now prove this theorem again or showcase how to prove it. Because here it says in the diagram, right? JKLM. Yeah, come on, dude. JKLM, is a cyclic quadrilateral. We can see that. And then it says, and the circle has center O. Yes. It says you prove the theorem that states that J plus L is equal to 180 degrees. So what we do know is that with all cyclic quadrilaterals, opposite angles do add up to 180 degrees. That's actually one way we can actually prove that something is a cyclic quad. So in this case, they are just trying to, well, they're basically point blank asking us to prove the theorem one way or the other. The theorem that states that opposite angles of a cyclic quad are supplementary. Opposite angles of a cyclic quad add up to 180. That's what they want us to prove. So with all this that I'm doing, all this talking, I'm actually stalling because I'm kind of just sketching the picture here, but I'm done now. So with this image, if we want to prove that these two add up to 180, I should have actually drawn this a bit higher so that it's not, yeah, where it is. But anyways, you'll see why just now. So with this theorem, we need to prove, well, let's put here to prove. What we have to prove again? We have to prove that J plus L is equal to 180 degrees. You see the copy there? You see it? There we go. Oops. So proving this, it's very simple. It's one of the easiest theorem to prove ever. I'm not even joking on this one. I would say this is the easiest Euclidean geometry theorem to prove. Easier than theorem 1. Yeah. So all you do is, if you need to prove that these two are supplementary, all you do is, you see, you draw a dot, you construct a line like this. This was actually supposed to be, a bit angular. You see, it looks like a straight line, but man, it doesn't look like the best line ever. But what you'd actually sometimes see is, you see we have a circle here, and then let's say the center is here, and then we had a cyclic quad like that. This is almost the same idea. But your dotted line, you see, this is just making an angle here. You see your dotted line goes there, and it goes there as well. So you see there's an angle here, and then there's an angle there as well. You see it's not a straight line, so just bear with me. And as I said, with the main channel, it's also, this proof is also there, and you see this is not a straight line. So you basically, your proof, you can basically write here, why does it keep saying basically? Well, let's put here construct OK and OM. That's your construction. Now the idea is, when you have constructed these two, you have a angle here and an angle down here. You see, now with your papers, right, remember when you write your final exams and all that, you always have like an answer sheet. So on your answer sheet, you will be able to, make these constructions. And then here, let's just label this O1 and O2. So on your answer sheet, you will also be able to label it accordingly. You see, so we have constructed OK and OM. And once you've done this, you're literally almost home free, because what we are going to do is, we are funny enough going to use this theorem to prove our law here. So you see this theorem, just pretend that's an angle there. This theorem, remember, states that an angle at the center of a circle is double the angle at the circumference. We're going to use this theorem twice to help us prove that these add up to 180. So this is how. The first thing you need to state is that O1 is equal to double whatever J is, you see, because of this theorem. So we'll explain it just now as well. O1, we are saying that it is equal to 2 times whatever J is, and our reason will be angle at the center of a circle. There we go, angle at the center of a circle. You see, because this angle here is going to be double this one there, because they are both going to the same 2 points. You see, O1 is going to K and M, J is also going to K and M. You see, that's why we have said this. Now you do the same for O2 and L, you see, because remember this theorem as well, if you have a circle, right, and you have an obtuse angle here, or rather a reflex angle. You see here, let's say you have 2 lines here. This is a reflex angle. You see this angle here is bigger than 180. This reflex angle is going to be double the one here. You see, that's also another variation of this theorem. So this angle is double this one. That's what we are using here. You see, we are basically using this analogy for this sketch here to say that this angle here is double this one there. You see, so writing that out, it's literally just us writing out O2 is equal to L times 2. Reason is angle at the center of a circle as well. Angle at the center of a circle. There we go. Okay, now you're literally almost done, because all you want to do now is to write out that O1 plus O2. You want to show that these two are adding up to 360, because the angles around the point. So here we're going to write down that O1 plus O2 add up to 360. Your reason will be angles around a point. Angles around the point, boss. So, oh, that's an A. What does it look like? Angles around the point. And then literally all you do is, where O1 is, you wanna throw 2J. Where O2 is, wanna throw 2L, you see. So O1, we know it is equal to 2J. We have proved it. O2, we know it is equal to 2L, and you can already see that, oh, we're done. Oh my gosh, look at that. Yes, because the 2 goes out. This is going to be J plus L. This is going to be 360. Divide both sides by 2. And then, I mean, voila. This is, again, as I said, the easiest theorem to prove ever. Because, I mean, like, wow. That was just so simple, because you just construct your 2 lines there. And then, I mean, 2 angles formed. So you use your theorem to prove that this is double that, and to prove that this is double this one. I mean, easy marks this one. 5 free marks. And if you want a recap, you can, even look at it in the channel, the main channel, where everything is all nice and stuff. So anyways, in the diagram, a smaller circle Oh, we got a diagram. Okay, this is a proper Euclidean geometry diagram. I mean, look at that. Look at all these lines flying around. Well, the one thing that I always say about Euclidean geometry sketches is don't judge them too early. Just like what I was about to do now. I was about to judge this sketch. I was like, whoa, 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 chill, 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 hold up, hold up. It's just a sketch. So what I mean is, you see, even before I've read the description, I'm trying my best not to judge the sketch. What I mean is, don't put your sketch on a pedestal. Don't think that, oh snap, 2 circles, so many lines, oh it's gonna kill us. No, forget about it. Just treat it fairly. Just imagine this is like a not a human being, but yeah, don't judge the same way you don't like judge people. Well, don't judge people at all, but let's just say the same way, like the phrase don't judge a book by its cover. Just think of that when you think of Euclidean geometry. I mean, it's just a sketch. It also wants to be treated equally. Okay, so it says here in the diagram, where's the pen? I see you. In the diagram, a smaller circle, whoa, stop shaking, a smaller circle A, B, T, S, this smaller circle here, and you can already see the funny thing, just by looking at this circle I can already see there's like a theorem here, but it's kind of hard not to see it sometimes, because it's like, oh, we have a theorem, angles subtended by the same chord, yay. But anyways, we just have a small circle here, right? And then we have a bigger circle here. The small circle, they've labeled it A, B, T, S. The big one, they labeled it B, D, or they are calling it B, D, R, T. And look at that. I mean, we have a cyclic quad there somewhere. Wow, this sketch is loaded. You see there? And you see what I'm doing over time. I mean, the more of these you go through, I mean, some of these things you just can't help but see them. You see cyclic quad here. But anyways, it says here, BT, where is BT? Yes, where is BT? BT is a common chord. You see what that means is BT is a chord for the small circle. BT is a chord for the big circle. Okay, BT is a special chord. And then they said the straight lines STD. Let's not comment on that one. Straight line STD. Yeah, ne? And ART, they are drawn. You see, these cross each other here. STD and ATR. Chords AS and DR. So we have AS here and then we have DR. They are produced to meet C. Okay, so this chord is produced until C. This one is produced until C. And then it says here, are produced to meet C, a point outside the 2 circles. And then it says BS. BS and BD are drawn. Yes, these are also just lines that are drawn on the sketch. And then they said A is equal to X, R1 is equal to Y. Interesting sketch this. And you saw how slowly I read it. The same, even though I know I'm like trying to explain and all that, but just reading it slowly is the way to go. Don't read your descriptions like you're reading a novel, by Mickey Mouse or something. In the diagram, a smaller circle, a bigger circle, draw lines. No, that's not gonna work. You see, that's definitely not gonna work. Yeah, so don't do that. Just take it nice and slow. I mean, if you had question 9, you're almost done anyway. So it's time to just hone in and make sure you don't lose unnecessary marks because of, any. Yeah, let's just move on. I'm wasting time now. Name, giving a reason. So looking at our sketch, we said we can already see there's a theorem here in the small circle. That's nice. And then we are seeing we spotted a cyclic quad. That's also nice. It's fine. So I think highlighters are good, but sometimes with Euclidean geometry sketches, it's so easy to have so many colors flying around. So yeah, just keep your eyes peeled. But then if push does come to shove, then yeah, throw those colors in there. So here, let's see, it says your name, giving a reason, another angle equal to X for 2 marks. Oh, wow, look at that. Wow. Well, we had already said that this angle here is definitely equal to B1 because, I mean, those are angles subtended by the same chord. You see them? You see there? We have a chord over here. So this chord, you see, it's subtending B1. and then this same chord is subtending A. So I mean, for 2 marks, that's a proper given away. 2 marks, we don't mind because we like marks being given away anyway. So for 2 marks, let's just put the, what question is this? 9.2.1. We're going to say here A is equal to B1, which is equal to X. The reason will be angles subtended by the same chord. Stop it, please. Just be normal. Act normal. Thank you. So, act normal. Dude, don't act normal. Just be normal. And I'm legit talking to myself on camera. That's embarrassing. But hey, it is what it is. Name. Giving a reason, another angle equal to y. Okay, we need another reason equal to y. So remember we said that we have a cyclic quad here. Wow, you see, like, knowing your theorems kind of helps, and knowing Dr. Cape Town also kind of helps, because Dr. Cape Town is, you know, an acronym that helps you remember your theorems and all that, because it basically goes like this. Dr. Cape, yeah, DRCPT, Dr. Cape Town. So this one reminds you of things like diameters, you know, and then R reminds you to look out for things like radiuses, you know, like the radius and stuff. C, what does C do? Oh, cyclic quads. You see what I just did there? I actually used it to remember. C helps you remember things like cyclic quads. And P, parallel lines, just in case. Parallels. Wow. This is definitely how you know it. This is not how you spell parallel lines. Let's try that again. Parallel. I don't know, but let's just guess this is how I spell it. Nobody knows. Nobody here to ask. Can't ask Google at this time. Kind of busy. Tangents. The T helps you remember theorems that have tangents. You see, that's Dr. Cape Town, and I think you have gone through it in the main tutorial, in the main channel. If you haven't, then you could always look at that. But here we said we have a cyclic quadrilateral, you see, because here points, all these points, 1, 2, 3, 4, they're touching this big circle. So that's a cyclic quad, you see. Now this cyclic quad has an exterior angle over here. You see the exterior angle? This, you see, this is a straight line, you see. So this straight line going out, it forms an exterior angle of this cyclic quad. Now an exterior angle of a cyclic quad is equal to the opposite interior angle, you see. Y is going to be equal to B2. How many marks are they offering for that? 2 marks as well, you see. Speak normal, it's okay. 2 marks as well. Yeah, guys, this is getting too serious. The more of these videos I make, the more I tend to talk to myself in the first or second person, whatever you want to call it. It's kind of creeping me out. Let's see here. A and B. Y, we said, let's see. Y is equal to, this is just gonna look weird for most people, so let me not write it like that. Let's just say R1 is equal to B2, which is equal to Y, and then the reason for that is exterior angle of a cyclic quad. Exterior angle of a cyclic quadrilateral, but we just want to say quad because quadrilateral is too long. 9.2.2 says prove that SCD B is a cyclic quadrilateral. And then how many marks? 3. Well, proving a cyclic quad, you can also go through a tutorial on that because there are like 3 ways to prove a cyclic quad. And I mean, because we're here, we're obviously just gonna brush through the 3 and then choose one that will work for the sketch, because whenever you need to prove a cyclic quad, right, this is how you do it. So with the cyclic quad, one of 3 ways. The first one is what we just looked at now. The first one is you either prove that an exterior angle is equal to the opposite interior one. The second one, you prove that 2 lines, hey, Ben, work. The next one is you prove that 2 lines that are subtended by the same, the next one you prove that 2 angles that are subtended by the same line. See, we've got a line here somewhere. You just need to prove that they're equal some way, somehow. If you can do that, you would have proven that this shape is a cyclic quad as well. The last one is the other one that we used for our proof. The last one is, all you need to do is to prove that, hey, my pen is giving me problems now. So, shit, man. So in an exam, I mean, this is a no-brainer. But don't you dare go in with one pen. I mean, like, if you go in with one pen, that's like, wow. It's like, yeah, it's like a recipe for distraction, because the whole time you'll be thinking, I hope my pen doesn't run out. I hope my pen doesn't run out. So you see the third law here, the third way to prove a cyclic quad is to just prove that opposite angles add up to 180. See? That's the third way. And yeah, the more this happens, the more like, let's reach out for the next pen. You see, dropping this pen over here, reaching out for the next pen, which looks the same. And I hope this one actually writes. I actually don't think this one writes. Let me see if it writes. Oh, it writes. Okay, bye-bye. See you later. Right, go. So yeah, 3 ways to prove a cyclic quad. Now, within these 3 ways, we have to choose one for this sketch. Where's our sketch? Here's our sketch. Now, the only issue is, you see, we have to choose one appropriately. So let's look for this one. It won't work well because we don't have any values. We don't have anything that's like 90 and 90 or anything like that, or any values given, nothing, not a zilch. So this one may not be the best approach because, you know, we need actual figures or stuff. This one, you want to look for lines that are crisscrossing in your sketch. You see here, nothing crisscrossing per se. You see, so nope, not gonna use this one. Are y'all doing the same things? Yeah, it's working. Not gonna use this one, not gonna use this one, so we're stuck with this one. You see, stuck with this one is a good thing because now we know exactly what to look out for. Let me put this in the middle. Creative, isn't it? I actually didn't plan that, but it seems to be working. So let's see here. So what we need to then do is to look for exterior angles of this shape. Now, I mean, the way our shape is lined up, I mean, the way our shape is aligned, you see here C, it's S, boss. S, C, D, A, B. You see this cyclic quad? I mean, fortunately, it only has one exterior angle that we can work with. This one, you see it? This one here. So let me just actually get a pencil for that one. Well, I don't think you're gonna note the difference because it's all gray and stuff, and yeah, and I didn't bring highlighters. Yeah, I didn't bring highlighters. What am I bringing? They're just somewhere in the house, but they're just so far, and I'm just like, I don't think I'll need them for now. Let's just see here. So this is pencil. Okay, this is pencil. I hope it won't confuse anyone. Let me actually do it like this. Let's put it like that. Yeah, this is gonna make it, you know, distinct. So this angle here, you see, this is our only exterior angle. So technically, we just need to prove that this angle here is equal to this angle over here. You see, this is the opposite interior angle. This one here, the whole thing, we need to prove that it is equal to S1. Now you may be thinking, oh my goodness, how are we gonna do that now? Like, how are we gonna do that, Levi? Like, bro, what the hell is going on? Tell us. Well, the big idea is, firstly, the consolation here is that it's a 3-mark question. So just hold your breath. No, don't hold your breath. What? How does that expression go? I don't know how that expression goes, so I'm just gonna forget about it. And what I was trying to say is, yeah, don't overthink anything. Just try and keep it light, keep it simple, keep it real, you know, keep it, yeah. So let's see here. Let's see. So the one thing is, you see, we want to prove that this is equal to this angle all the way here. But then normally when you want to prove that 2 angles are equal to each other, you see, we want to prove that these are equal, because if you can prove that they're equal, we would have proven that we have a cyclic quad. But then for you to prove 2 angles being equal, always try and look for angles that are equal to, like, for example, what's best to do is look for something equal to this, and then look for something equal to this, and then you will actually note that these 2 are going to be equal to the same angle without you making them equal to each other directly. What I mean is, for example, you see here, our theorem. You remember that theorem we were talking about? So always remember, this theorem always comes in pairs. You see, so this angle here is equal to that one there. Yes. However, let me actually make that a bit. No, let me not. You see here, this is equal to that. We proved it. Angles subtended by the same chord. But then can you see that S1 is equal to T2? The reason is they're angles subtended by the same arc there. So even though there's no chord here, you could, if you said chord, you're not going to be penalized for that. Penalized. Well, whichever way. Yeah, it won't be a big deal. So here, we're going to say S1 is equal to T2 because they're angles subtended by the same arc. You see, S1 is going to A and B. T2 is going to A and B. So, I mean, you can already see it too, right? But let's just say those two are equal to each other first and, take our wins later. But let's just, yeah. S1, we're saying it is equal to T2. The reason is angles subtended by the same what? Same arc. Yeah, arc. Same arc. You see, angles subtended by the same arc. Now, if you look carefully, can you also see that this is an interior angle of a cyclic quad? This is the exterior angle of this cyclic. You see this cyclic quad here? You see it's a cyclic quad, this one, because it's in a circle already. We don't have to prove it. So here, we can already see that this angle here, hey, so messed up. This angle here, right? We have proven that it is equal to S1. We are just now going to show that this angle is also equal to D, the whole thing, just D, because D is this angle here. So if you want to refer to D1 and D2, you can just call it D because it's the whole thing. So T2, we're going to say it is equal to D because exterior angle for cyclic quadrilateral. So, writing with the back, but that doesn't work, does it? Let me actually write here D first. D is equal to T2. The reason is exterior angle of a cyclic quad. So I think this question was quite simple. Yeah, one or the other. Question 9 was not so bad. So here we're proving that, you see, we're proving that S1 is equal to, what have we proven? S1 is equal to T2. And then we've also proven that D is also equal to T2. So because they are both equal to T2, it means that they're both equal to each other. You see, so that's just a conclusion. Therefore, S1 is equal to D. Therefore, SCDB is a cyclic quad. That's a Q. Yay. Supposed to be A. Also, you're abusing this bad handwriting thing. Yeah, you know, what if I actually have like this really nice handwriting, but this is all like a persona, a facade. Facade, boss. Facade. Is that even the right way to use the word? I don't know. What I'm trying to say is maybe I actually have a good handwriting, but because I always write so fast and I always talk so fast, I will never know. Well, one day I will talk slower and write slower. Maybe I will have a good handwriting. So SCDB is this is A. It looks like a 9. Wow, boss. Wow. A cyclic quad because Bekause. Yep, that's how I remember how to spell because. Bekause. Bekause. I don't know how you spell I don't know how you remember how to spell because, but yeah, because this is a cyclic quad because an exterior angle, running out of space. An exterior angle is equal to the opposite in the, how do you put it? Oh wow, look at this, in and then interior. That's so weird. Interior, goodness, interior. Yeah, is equal to the opposite interior angle. Let me actually finesse this here. Angle. So this will be the angle. Yeah, there we go. Don't waste ink, guys. There we go. Yeah, so you see, we said here this is a cyclic quad because an exterior angle. Yeah, an exterior angle is equal to the opposite interior angle. So yeah, I think you get the idea. Yeah, you're smart, so you got that one. You see, 3 marks. So you get your 3 marks, and then you move on of which the next question here says 4 marks. Ooh, okay, 4 marks. 4 marks. 4 marks says, what does 4 marks say? It says, it is further given that D2 is equal to 30. And then AST, where is AST? AST is equal to 100. Okay, this is 30. So that's 30 as well. That's 30 as well. You see, oh, no. I had made a classic mistake. The whole thing is D. But then this tiny portion is 30, you see. So don't get confused like I was about to get confused there. Strange. But it says here AST is equal to 100. And then this is equal to 30. They said here for 4 marks, prove that SD is not the diameter of circle BDS. So with a question like this one, this is what they mean. Here's what they mean. Let's hack their brain. So what they mean is, right? What they mean is. So we technically have an angle here given. They said this angle here is equal to 30. Okay, very nice of them. And then they said here that this whole angle here, AST, they said that whole angle there is equal to 100. Okay, that's nice. So this is 30, this is all 100. That being given, they said we should prove that this line here, SD, is not, you see, keyword is not the diameter of circle BDS. So all that means is if you had to draw a circle around BDS, we should prove that SD is not the diameter. Now, point blank, anything you need to prove, use what they are telling you to prove what they want you to prove. What I mean is, if you're going to prove that SD is not the diameter of this circle that goes through these points, then the easiest way to do it is to prove that B is not a 90-degree angle. You see, because, I mean, if this was the diameter of a big circle that goes through these points, if it was the diameter, then B would need to be 90 because of our law. So what we are going to do is we're going to show that B is not equal to 90, because if B is not equal to 90, then it means that the circle that goes around those points will not have SD as the diameter. Yep, that's how we're going to do it. So let's see what we can do with this 100 and this 30 that were given. So if this whole thing is 100 and this tiny part is 30, so you may be asking yourself, why did they give us D2? Like, why are they focusing on D2? Like, why are you giving us D2, eh? But let's see. They also gave us, well, technically AST. They gave us the entire value of AST there. So it's also kind of weird why they've given us that. But, wow, guys. Wow. Well, remember, all we're trying to do here is to prove that this is not equal to 90 degrees, you see. So the best way you could do that is you could maybe get yourself, well, why is that guy making noise with his car? I need to pause until he's done. Oh, no, he's done. Or it could be a girl. Why is this lady making noise with her car? Like, you know, it's possible, people. It's very possible. So, oh yeah, where was I? Wow, I'd already got distracted. Interesting. So here, we said here, let's try and get more figures into our sketch. You see, the more figures and the more values you have in your picture, the better things work out for you, you see. Don't bottle things in. Like, don't keep things in your head for too long. You know, just what? Yeah, you know, just keep calm. So the easiest way to do is, you see here, we have been given the whole value here. This is 100, and we want to get more values into the sketch. So you look at where D2 is. D2 is an angle inside this triangle here. You see this triangle here? This one. Like that. You see, so I might as well draw it out. Let me actually sketch it. Ooh, paper. Let me actually... So today, I'm going to be using the back side of the paper. You see? trying to save the trees because hey, I've been seeing those festive papers. Ooh, those past papers, child paper people. So I'm like, here at this rate, I'm going to finish the trees. I should chill and use the back side of the paper. So if you look at our sketch, right? So many distractions, and I'm still here just talking, blabbing, whereas I should be explaining. People want to do other things, but I'm here. So you see with this sketch here, let me just draw this line here. This is A somewhere, right? And then somewhere here you have S, and then here you have D. And you see what I'm doing now? Feel free to do that on your what? Yeah, like on your answer sheet if you want, like in pencil, right? So that it can help you think or whatever. Because I don't think you have scrap paper in exams. You can't. I don't think so. If you can, then good for you. I mean that in a nice way. So this whole thing here is AST somewhere here. You see, they said this value here is 100. You see, here the value here is 100. You see, we're trying to prove that this is not equal to 90. You see. So the angle I'm coming at is, you see here, this, if we can show that this plus this is not equal to 180, then, whoa, what am I saying now? Yeah, this 2 should add up to 180, you see, because it's a cyclic quadrilateral, this one. So if we can show that this plus this, let's just get this angle first. What I want to say will make better sense as soon as we get this. So you see, this is 100, ne? And then this is D2 here. We have D2 here. There, you see? See it? See it? We have S, C, D. S, they see here, there's D there. This angle here, we said it is equal to 30. You see? So what I'm going to say is, you see, this is an exterior angle of a triangle. This is an exterior angle of a triangle. So basically what it means is AST is equal to C plus D2, because exterior angle of a triangle, you see. So that's the first thing I'm going to write down. AST is equal to C plus D2. The reason is exterior angle of a triangle. AST is equal to 100. C is equal to C. We don't know what it is. D2 is equal to 30. And you see what's happening here. C. I said C so many times right now. It's like, just cut it with the C's. So, I was about to say you see again. But anyways, you see here we have like 70 now. So you see, it's a habit. It's stuck. I'm stuck like that, guys. I'm sorry. C is equal to 70. So we have gotten a value for C now. You see there, we have this value here. Might as well drop that in there so that it's like, So you see, if this is a cyclic quad, now I see why this question was only 4 marks. You see, if this is a cyclic quad, which we have proven, S, C, D, B. You see, we proved this is a cyclic quad. So if we are just going to show here that these two, they should add up to 180. You see, so automatically this should equal 110. So let's just put here C plus B is equal to 180 degrees. And the reason is opposite angles of a cyclic quad. Opposite angles of a cyclic quad. Cyclic quad. Not quad. So if this is so, then it just means that C, which is 70 plus B, is equal to 180. B is going to be equal to, wait for it, 110. B is not equal to 90. So, I mean, we need to prove that this is not going to be the diameter to a circle that passes through these 3 points. So to do that, we just said prove that B is not equal to 90, because you'd be disproving the theorem that says the diameter of a circle subtends an angle of 90 degrees. So we have done that. You see, B is equal to 110. So here we literally just need to put some words here, like a mini paragraph, like a few letters, a few words. Yes, a few words. Words. Hey, yeah, potato. So we're just going to write here, therefore SD, you see, we're just concluding, therefore SD is not the diameter of circle SBD, or what do they call it in their question? BDS, of circle BDS, If you say it SBD, it's still fine, you know, just you can just refer to it the way they want it, the way they say it, you see. Circle BDS, you see. This is not a diameter to circle BDS because B is subtended, subtended. This is an N, by the way. Subtended. It's like 10, sub 10, and then d, ed. I think this one I actually spell it correctly. Let me actually show it nicely a bit. Sub 10, d, sub 10, ed. Who would ever have thought that I am giving a spelling whatnot? Yes, guys, this is how you spell subtended. I think I'm actually not even sure. I'll actually have to check later, but whatever, let's just keep going. This is not a diameter of the circle because B is subtended by SD, but B is not equal to 90. You see, B is not equal to 90. So the theorem that says that an angle subtended by the diameter of a circle will not hold. So SD is not the diameter of a circle. SD would be the diameter of a circle if this was equal to 90. This question could have easily maybe have said, prove that SD is the diameter of circle BDS. Then somewhere along the lines, I mean, depending on how our sketch would have been aligned, we would easily have been able to prove that this is equal to 90. But because of the way our sketch is aligned, they told us to prove that it is not the diameter of a circle. So we literally just do the same thing, you see. So yeah, easy marks. So let's move on. Did I give a reason for this thing? Yes. Opposite angle of cyclic quad. So there's question 10 here, and in my head I'm like, oh, those things again. Question 10 is such a nightmare. Well, not really, but these things. Oh, whoa, what is sine doing there? What? Oh no, sine. How did sine get there? Oh yeah, and I'm legit judging a question before attempting it. Wow, Levi, such a good example. You are not a hypocrite at all. Well, I'm not. I'm not. You see, I'm coming back to my senses, not judging the question, just keep it together, and then just do the question. Believe it, we are finally at the end. Would you believe it? Question number 10. Here we go. Last stretch. 16 marks. Let's check what's left here. 16 out of 150 times 100. 11% of the paper is left, so 89% down, unless there's like a weird mistake in there somewhere that only you spotted because you're a genius. And I was just like, let's just go. But anyways, let's see here. It says in the diagram, okay, very neat diagram, and you can clearly see this question is neat. So let's see here. Question, be kind, please, be kind. It says in the diagram ABCD, ABCD is a cyclic quad. Yes, we can see that. Might as well let's just mark those points for now. 1, 2, 3, 4. You're a cyclic quad. We can see it. Thank you for telling us. Such generous people. Because sometimes they don't tell you, yeah? Then it says it's a cyclic quad such that AC is perpendicular to CB. Okay, so you see, this angle here is a 90-degree angle, so it means that it is subtended by the diameter of a circle. They didn't tell us that, but we know it. Why? Dr. Cape Town. DRCPT. You see, we need to be always thinking of diameters. You see, so we have to think of diameters, radius, what do you see? Cyclic quads. They spoke of cyclic quads. We need to think of parallel lines. Well, here we don't have any, but it's fine. And then we need to think of tangents, and we can see we kind of have a tangent here. It looks like a tangent, but we'll see. let's see here. It says here such that this is perpendicular to that, and then it says BC. Yeah, I mean DC is equal to CB, and then it says here AD is produced to M. AD is produced to M, and then it says here such that AM is perpendicular to MC, and then it says let B equal to X. So here it's kind of tricky here to think that this is a tangent. You see, if they did not say this is a tangent, you don't assume. But look at the first question. Look at that. They're asking us to prove it's a tangent for 5 marks. Hey, these guys, they're giving away marks. Because look, this is 16. So 5 marks. Hey, fine, we'll take them, We'll take them. So they say to prove that MC is a tangent. You see what I was saying there? They did not tell us that it's a tangent. So you don't assume. You see here, we can see it's a tangent, yes, but they say we should prove it. We should prove it, Baba, prove it. So the easiest way to prove a tangent is to use a 10-chord theorem, like point blank. Meaning, you see here, let me not ruin our sketch, our very nice sketch. Let me try and like draw it out with my mad circle drawing skills, which I don't have. So here we have a circle, né? We have a line here, and then my line is totally off. So let's just put that there. Let's finesse it. Don't mind this. I'm sorry. So we have a line going up there. Yo, it's gonna not be to scale, this one. And then you have one going down there, and then you have a line going there, and then you have that there. Fantastic. Oh, this is not bad at all. I mean, look at it. I mean, look at that. I mean, yeah, that was just weird, but it is what it is. It is what it is. So let's see here. This is 90, and then this here is that, and then they told us that these are equal to each other, right? Bring them close to each other, man. You don't gotta be so far. Yeah, ne? Yeah, ne? It's coming along okay, I guess. This is 90. This is also equal to 90. That's equal to this. And then here they said we should label this X. And then they said here this is like 1 and 2. This is A. This is D. This is B. This is C. Remember, you will always have a sketch, another one on your answer sheet. So basically, what we said is we need to prove that this is a tangent. This is M. That was a finesse this mistake here. This is M. You see, they say we should prove that MC is the tangent to this circle at C. So that's, it seems like a difficult question. The reason why I was like shocked is because it's 5 marks. So all you need to do is either prove one of two things. You're either going to prove that this tiny angle here is equal to that angle, because that's the 10-chord theorem. You see, because you have a tangent here. You need to prove it, remember. They say we should prove it. It's not like proving the 10-chord theorem. You don't like have to make constructions and all that. You don't have to. You have to just show that they're equal to each other using some laws. So, why don't we just use the 10-chord theorem proof to prove this? Yeah, that's what I'm thinking. Like, why don't we just use? But that would just be a long drive for this question. Like, it really would be. So here we're going to say, yeah, they're going to prove that this is equal to this, because you see this angle is going to this chord, you see, so that's the 10-chord theorem. Or you're going to prove that this whole angle here is equal to this angle here. Reason is, you see, this angle is going there and it's going there, you see. So you have this chord here and you have this tangent here, you see. That's the 10-chord theorem. Tangent, chord. So the angle there, you also can prove that it is equal to that. So you see two options here. Maybe with a nicer picture it will make better sense. You see, we are going to either prove that this angle here, I didn't want to draw it here because I don't want to mess it up. We're going to prove that this angle, tiny one there, we're going to prove it is equal to that angle there, right? Or we're going to prove that this whole thing here is equal to that whole thing there, because of the 10-chord theorem. So yes, we have got our work cut out for us. Very, yeah, a lot of work this, a lot of work. So the one place where we can start off is, let's see here, let's see what we can do. these two triangles here, remember we said we could maybe prove that this is equal to x some way somehow. So yeah, we're either going to prove that this, yeah, it looks like proving that this whole thing is equal to x maybe easier, I think. Yeah. Yes, that's exactly what I'm going to do. I'm going to prove that these two triangles here are are similar. Well, let's see here. A1 is equal to A2 because the angles subtended by the same line. And then this is both equal to 90. Yes. So this is what I'm going to do here. I'm going to prove that AMC, you see this big triangle here? I'm going to prove that it is similar to this big triangle here. Because if they're similar, it will show that this angle here is equal to that angle there. And this is how. Oh, wow. I feel like a genius. So 10.1.1, 10.1.1. Remember, we said we're going to either prove that this is equal to this, or we're going to prove that that tiny one is equal to that tiny one. I prefer the big one because why go for tiny things? See? So, anyways, so here the first thing I'm going to state is in triangle AMC. So in triangle AMC, so triangle AMC and triangle ACB and triangle ACB, you see these ones, AMC and ABC. In those two triangles, I am going to prove similarity. So I'm just stating out which triangles I'm working in. So in these two triangles, the first thing I'm going to state is that A1 is equal to A2. You see, the reason is they are angles subtended by chords of equal length. It doesn't have to be the exact same length. I mean, it doesn't have to be the exact same chord. They just need to be equal to each other. You see, that's how your theorem has it. You can have a circle. Your two angles can be subtended by the same chord. Yes, they'll be equal. That's fine. However, if you have two separate lines, as long as they're equal, your theorem also stands, you see. So A1 is going to be equal to A2. Our reason is angles subtended by chords of equal length. There we go. Chords of equal length. That's what it is. So we've proven that, you see, one set of angles are equal. The next ones, I mean, that's given, guys. Like, wow, these guys are giving away marks. So we're going to show that AMC, let's put here, AMC is equal to ACB, angle ACB, and the reason is given. Oh, my bad. I didn't even see that. Given is given, you see? So, therefore, ACM is equal to ABC. ABC. Because of interior angles of a triangle. Interior angles of a triangle. The reason is, you see, as long as you've proven that two pairs are equal, the last one is automatically equal to each other because of interior angles of a triangle. So if two are equal, the third one automatically is going to be equal. You see, we proved that this is equal to that, and then this is equal to that. So this has to be equal to that. Hence, you see, we've proven that these two are equal without using the 10-chord theorem. So because you've done that, you have also proven that this is a tangent. You see, we've proven the 10-chord theorem in reverse because we are seeing there's a tangent here and an angle. We have shown that they are equal, so this has to be a tangent to the circle. So in conclusion, we're going to say, therefore, MC is MC is a tangent to the circle because of the converse of the 10-chord theorem. You see, MC is a tangent because of what we have just proven. So let's put here, MC is a tangent to the circle at C, right? And then our reason for that is converse of the 10 chord theorem. Converse of 10 chord theorem. You see, we have just proven the 10 chord theorem in reverse, as in we have shown the angles are equal. So because we have shown the angles are equal using some other way, we have then shown that this is a tangent. You see, that's what we have just done here, because yeah, we can do stuff like that. Easy 10, easy 5 marks. And you want to think of it that way as well, because at first glance it's like, oh wow, wow, wow. But anyways, here we are. There were two options to work this out. Remember, you could have chosen to prove that C2 is equal to A1. Yeah, that you can do that. That's your baby. You can definitely do that if you want to. So here it says prove that A, C, B. Oh, that triangle. We should prove that it is similar to C, M, D. Oh, the tiny one. Okay. So you see, they're asking us to prove that the big one, the big one here, C, ACB, the big one, ACB, we should prove that it is similar to CMB, the tiny one. So anytime you prove similarity, there's one way to do it, just like what we did here. Anytime you want to prove similarity, you just need to prove that that all three angles are equal. Here we were not proving similarity per se. That's why we did not have to end up by saying therefore these are similar, blah blah. No, we just wanted to show that one pair is equal, another pair is equal, so the third one has to be equal for what we wanted to do. So here, for future reference, let's just actually throw that in there so that we can use it as something we have proven already. So let's just put here somewhere, therefore AMC, triangle AMC is similar to triangle ACB. You see, I'm doing this because the reason is angle. I'm doing this because later on in the question, if we ever need to prove that they are similar, or if we ever need to use these two as similar triangles, we can just do so because we've proven it already. If you have to reprove it for some odd reason, if they ask you to prove it, just do it, baba. Copy paste. So let's see. Here they said prove that the tiny one down here is similar to this one here. So you see, proving similarity, same idea. Just prove that two pairs of angles are equal. So the first one is here, I mean, this is 90, this is 90, that's given. So let's just say here, what is this? 10.1.2. 10.1.2. 10.1.2 says we need to say that DMC, that angle, DMC, no, we have to state what triangles we're working in first. So let's put here in triangle ACB and triangle CMD. In these two triangles, DMC is equal to ACB. That's given. ACB, that is given. Thank you for giving us. Now we need to find another pair that is equal to each other. You see, well, here this one is easy because you see, here we already know that this is a tangent, so we can use its law now. So we said that we're going to show that C2 is equal to A1 because of the 10 chord theorem. And then we already know that A1 is equal to A2. So if you prove that this is equal to that, then automatically you would have proven that this tiny angle here is equal to that angle there, because these two are equal to each other. So let's just write it out. You see, we're going to state that C1 is equal to, we're going to state that C2 is equal to A1 because of the 10 chord theorem. C2 is equal to A1. Reason is 10 chord theorem. This is fun enough, one of those theorems which you can actually say 10 chord theorem as a reason. Dope, right? So because of the 10 chord theorem there, right? And then you are now able to say, let's just put here A1, A2 is equal to A1. That's, did we prove it here, up here somewhere? Yes, we proved it in 10.1.1. so that's proven, and then we can just tell them where. Proven in 10.1.1. That's a reason. You won't be penalized for that. It's valid, it's marks. So you see, we have proven that this is equal to A1. We've proven that this is also equal to A1. So therefore these two have to be equal to each other. You see, the C2 there has to be equal to the A2 there. So you can see here, therefore C2 is equal to A2. It's a conclusion from these two things. So you see, we've proven that one pair of angles are equal. We've proven that another pair is equal. So automatically the last pair has to be equal. So here it's literally just saying therefore D2 is equal to B. The reason you see this is nicely labeled. Here we can just call this B because it's not cut up or anything. So this is D2 is equal to B. The reason will be interior angles of a triangle because we've proven that two pairs are equal. Interior angles of a triangle. Yes, that's it. So now we can say that therefore our two triangles, therefore ACB, like they said, therefore triangle ACB is similar to triangle CMD. The reason is angle, angle, angle. This is the only reason ever for similarity. So don't forget that. You get your 3 marks and you move on and you keep marching on because look, it's just 2 questions left. Ah, I'm so excited. 8 marks. So 10.2 here, point 1. They said hence or otherwise. Questions that start with hence or otherwise, they just make me go, what do you want, Joe? Like, what do you want? Why? But anyways, hence or otherwise, we should prove that this is, this here is equal to that there. So the only thing here is, I mean, it's a 6-mark question. And the other thing is, remember, we have basically proven that the big, just as a, not a coincidence really, but you see our first question, we proved that the big one is equal to this big one as well. And then this one, we have just proven that this big one is similar. No, wait, why did I say equal? I meant similar. We had proven that the big one here is similar to the big one there. And then here we have just proven that this big one here is similar to that small one there. So literally all it means is all 3 triangles are similar to each other. The tiny one here, the big one there, and this big one here. They're all similar to each other. So just remember that for this question. That's out of 6. So here they said MC squared. We should prove that MC squared. So there's MC involved. And DC squared, there's DC involved, is equal to AM. There's AM involved. And then there's AB involved. So you see, I mean, it's just a mess. So the thing is, you see, because there's DC twice, you see DC is there twice, and then MC is there twice. And then here you have something from the one big triangle, which is AM, and then you have something from the other big triangle, which is AB. The first thing you can do for yourself is, firstly, you can state out that these all 3 are similar to each other, and you can say obviously proven at 10.1.1 and also proven at 10.1.2. So this is what I mean for this question. The first thing you can state out is you want to state out that all 3 triangles are similar. So let's just see, we need to label them accordingly. So let's see what we can do here. What can we do? So the first thing is let's see what we did for this one here. Here we had proven that AMC. So here we can start off by saying that AMC, triangle AMC, is similar to triangle ACB. This is proven. Where did you prove it, sir or ma'am? Proved it at 10.1.1. And then the next one, we know that here we have proven that this same triangle ACB is similar to MCD. And then here we have also proven that triangle ACB, you see, ACB twice. ACB is also similar to triangle CMD. CMD. We proved it. It's proven at 10.1.2. So you see, this is equal to ACB, and ACB is also, this is similar to that. You see, and ACB is also similar to that. So you see, it means that these two are going to be similar to each other. It's a conclusion. So we can say here, therefore, triangle what? Triangle AMC is similar to triangle CMD. You see, it's a conclusion from the previous two statements. Because I mean, if this is similar to that and this is also similar to that, it means that these two are similar to each other. So you see, similarity galore. Whew. And I'm about to flip this page over, but I really don't want to because I want to use this side. So let me just pause here and get some more paper. Got some paper. So we said here that all three triangles are similar. Great. Now what? Now what, bruv? Now what? We get all this stuff going on, like how are we going to do it? So just to recap, we said, you see here they're talking about MC twice. They're talking about, you see MC twice. They spoke about DC twice. And then here they've mentioned something about the big triangle here. And then there's something about the other big triangle there. You see, so it basically is a scenario where we need to use the smaller one and this big one. And then we need to use the smaller one and this big one as well. So this is what I mean. Firstly, let's see what we want to prove. We want to prove that CM squared over DC squared is equal to AM over AB. Okay. Okay. So now we need to just look at our sketches or our pictures. So firstly, we know that all these triangles are similar to each other. All of them, you see. So here we technically have a scenario where we have, let's use this. What can I say here? What do I want? This is the small triangle, right? We have the small triangle here and the small triangle there, you see. So these two bottom scenarios are what we want to use, because this is the big one and this is the big one. We want a scenario where we're working with the small one and one big one, the small one with the other big one, you see. So we're going to use these two here. 1, 2, 1, 2. So using those two scenarios, this is what you want to remember. We know that as long as triangles are similar, you'll always be able to write out things like AC, I call it the McDonald's face. AC, let's put it down. AC over CM is going to be equal to what? It's going to be equal to CB, it's an M there. It's going to be equal to CB over MD over MD, which is also equal to AC, smiling, you see it's a face. Let's go to AB over CD over CD. The reason for writing this out is proportionality of similar triangles. There we go. Now you do the same for these two down here. AM over MC, AM over CM, CM, MC, same thing, is equal to MC, there, MC is equal to MC over MD, MD, which is also equal to AC over CD. CD. The reason for writing this out is, again, proportionality of similar triangles. Now you're almost home free, or you're legit home free here, because all you want to do is now, you know, here from this top part you just want to formulate one equation. From this bottom part you also want to formulate one equation. So what I mean is, you see from the top part, just looking at this, we need something that is MC. So let's see, this is MC, so that's definitely gonna, we need to take at least this is MC, and then we also at least need something that is DC. There's DC here, so let's take that. See, so our one equation here, we're going to have the AC over CM is equal to AB over CD. Let's just have this here, #1, call this equation 1. And then down here we also want something that at least has MC in it, because you see we're trying to map stuff that has, you see here we have something that is AB already, which is fine. There's no AM here, so that's fine, but we want it focus on these things here. So you want stuff that has this here in this equation. So here, MC, so we can see there's MC twice, which is good. There's MC here, there's another MC there. So you may be thinking, why don't we take this has AM and MC together, which looks useful. So let's see there, AN and MC. And then you may be asking yourself, why don't we just take this? Because there's already MC twice. Or, well, here there's AC and then there's DC, which also is DC there. So, yeah, it's kind of crazy, eh? It's kind of crazy. It really is crazy. But here I need to just pick one. And you may be thinking to yourself, are you going to pick one randomly? Are you going to pick one methodically? I mean, what you going to do? I mean, like, tell us. So let me just look here a bit closer. Is there anything here that is coming out twice? Let me also just double check if I also made sure I made this thing correctly. You know, can't be too sure. AC over MC is equal to CB over MD, which is equal to AB over CD. Fine. And then here, down here, we said AM over MC is equal to, AM, over MC, yes, is equal to MC over MD, yes, which is equal to AC over DC. Yeah, everything looks fine. So, yeah, just have a weird dilemma going on here. Do we pick this ones or do we pick this ones? Well, I mean, yeah, maths. So I think this is also goes to show that, yeah, just sometimes you don't necessarily always know what to do specifically. So you just go with your gut. I mean, you know. So the first one, we could not map out anything that is coming out twice, which is not very nice because, you know, that would have been nice to see. But what you can do is you can see if you can redo it with like another variation. Let's see if we had said something like AC over CB is equal to AM over DM. Nah, let's not overthink it. I'm legit overthinking now, which is terrible. So let's just take this one. Okay, hashtag 2 is just AM over CM. This is equal to MC over MD, which is fine. So here, if you want to simplify this, you could cross multiply. This is going to be ACCD is equal to CMAB. And then here, if you want to cross multiply, remember these are the same because MC and CM means the same thing. So these two is going to give you MC squared. And then here you're going to have AMMD. So at this is equation 2. At this point in time, I would now check the 2 and see if there's stuff that is equal. And then I would also be referring to the sketch to, you know, to like try and solicit something. So the one thing that we know is DC is equal to CB. So let's see if there's any CB here somewhere. CB anywhere? No? No CB? No CB? CB? Are you anywhere? No, no CB anyway. Snap. Well, that's not very nice. So let's see here. What are we needing to end up with? We need something that is DC. Well, there's DC here, fine. There's MC there, fine. There's AB here. There's AM. There's MD. What is MD? MD is that tiny line there. What is AC? AC is that long line there. So, yeah, this is kind of annoying. But, yeah, so luckily this is where is this question? It's towards the end. So if you do get stuck, I mean, you can just move on if you want. But we're like right at the end here. So might as well figure it out. Might as well maybe just pause so that I work it out. And then just, you know, yeah. Okay, so I have had some time to think. So in an exam, always be ready to pivot. So for our second equation, we used the bottom part. And the bottom part was nice because it gave us this here and it's squared. But the top part, you see this option and this option did not give us anything usable. So scrape it. We are going to now use this and this because you see there is CB and there is, you see CB is equal to DC. So where we have CB, wait, I thought I had it. Yeah, I'm going to use these two because there's CB here, there's DC there, you see. So these two will be able to work out one way or the other. So I'm going to use this here and this there. So let's see there. CB over MD is equal to AB over CD. Now the good news is, remember, CD is the same as AB. I mean, CD is the same as DC. No, man. DC is the same as CB. You see, CB and CD, they are the same. They gave us there. You see, CD and CB. So they're equal to each other. And because our expression needs to have CD or DC twice, we can always rewrite this as, DC at the end. So we can cross multiply here. We'll have CB dot CD there is equal to AB times MD. And then these are the same, you see. So we can write this as DC squared is equal to AB times MD. Let's call this #1, equation 1. Okay, so you see what we did there? We changed our mind because this was not working. You see, I had chosen these two. Why did I choose these two together? Yeah, kind of weird, really. I don't remember why I chose these two together. Oh, I chose it because there's CD in there somewhere, and then there's MC. So you see, it didn't work out, so you just change it, pick something else. So here we chose these two because there's CB here and CD, which are equal. So eventually that can give us DC squared. So what we have here is this. There's technically MC squared here, or CM squared, and then there's this squared here. So technically we need to end up with CM at the top and DC at the bottom. So you see, we can put CM over DC, CM squared over DC squared. This is going to be this value here, AM and MD, over this value here, which is AB and MD. And luckily this cancels out. And then you have your final answer. And yes, this question was proper trash. But hey, you gotta make it work. You see, if you do something and you see it's not working, don't just keep rolling with the punches. You must also throw another punch back. You must throw. You must duck and dive and do the things. So the best thing about this question is I think you're also seeing that don't just think, yeah, things are smooth. No. If you wanted, luckily this is right at the end, right? So if you wanted to maybe this, you could have done it without the previous one. Who knows? You could just go back there and then come back here. It's towards the end anyway, so you would not be worrying about your time or anything. So you have time to think nicely. The next one says, hence or otherwise prove that AM over AB is equal to sine squared x. So sometimes it's always the simple questions that are annoying. It's like, why do you want us to do that? Like, why? So here, let's see here, sine squared x. Where is sine in our question? So x is here, or rather, where is x? X is here. X is also this whole thing here. So where is AM? AM is here. Where is AB? AB is there. Oh, wow. Such a simple question. But it just looks like it just looks so annoying. It's like, why do you even want that? So anyways, let's see. How would I go about working out this question? Hence or otherwise. Prove. Oh, it's a proof question. They want us to prove it. They don't want us to show it. Huh. Okay, that's very nice. Well, what do we know? We know that you see, these two are linked. Because there's AM over AB, there's AM over AB. So let's see here. Where's 10 point? 10 point what? 10.2.1. So here we're 10.2.2, the very last question. They said here we should prove that AM over AB is equal to sine squared x. So the idea is we already know that this over this is the same as MC squared. Is the same as CM squared over DC squared. So here we know that sine squared x is equal to cm squared over dc squared. Okay, well, how are we going to prove this now? Where's our sketch? Where's our sketch? Help us sketch. Let's see here. Sine squared x is the same as this. Well, let's see what, let's scrutinize this first and then maybe reverse engineer what they have here. So here technically you have here sine x, right? The whole thing is squared, remember. And then here you technically have cm over dc. The whole thing is also squared because one has a square, one has a square. So technically if you square root this side, you also square root this side. So this, you're going to have sine x is equal to cm over dc. Let's see what that is. Let's see what that looks like. Is that, where's x? This is x, so the whole thing here is x. But then this is x, that tiny part there is equal to x because of our similarity shandies, you see. I mean, this is equal to that is equal to that. So it means that if this is x, this has to be x. Because all these triangles are similar to each other anyways, you see. So, yeah, let's see that. That is equal to that because of Pythagoras theorem. Therefore, Pythagoras theorem, trigonometry. Yeah, I think here we've cracked the question because look, this is x, right? Opposite over hypotenuse. So let's reverse engineer this until we end up with that. You see how you prove things? Sometimes you can reverse engineer it and finesse it. This, you can even scratch it out if you want, it doesn't matter. So what we're going to write out is we need to firstly show them that d2 is equal to x. You see, d2 is equal to x. We can even use, you see here, d2 is equal to b because angles of similar triangles is what you could use there. Or rather, corresponding angles of similar triangles. That's what I'm going to use. So here, let's put here d2 is equal to b, which is equal to x. The reason is corresponding angles of similar triangles, you see. So basically what I'm saying is these two triangles are similar to each other. Here, it's proven already. So if this is equal to that, which we know, and if this is 90 and this is 90, technically this is x because that's going to be x. So because we know that this is x, we know that therefore sine x is going to, you see, we're just reverse engineering this, you see. So we say it here, sine x is going to be equal to opposite, which is cm, opposite over hypotenuse, which is dm, right? No, cm, opposite of hypotenuse. Hypotenuse is dc, sorry. Yeah, opposite, which is cm, over hypotenuse, which is dc. dc. Now, we know that if you square one side, you can square the other. If you square this, you can basically square this. And then here, the top is squared, the bottom is squared. And then we know that this, because of our previous question, is equal to am over ab. Am over ab. Sine squared x. My guess is they made this 2 marks because, I mean, it was at the end. They could not make this 2 marks only. If they made it more, obviously, it was going to go over 150. But, hey, it's fine. So we have gotten our proof there. All we had to do was show that this is equal to x. Do trigonometry. You can even put the trig as a reason if you want. Trig, this is just basic trig, right? And then put that there. If you square one side, you square the other. And we are squaring because we want to end up with stuff like this, so that we can just eventually write it as am over ab. So yeah, this paper was like, it was confused, this paper. Sometimes it was easy, sometimes it was funny, sometimes it was madness. Like this last 2 questions, proper madness. Like, yo, wow, guys. Anyways, that's that for this paper. So as mentioned, the next few are definitely going to be 2020 prelim papers. So yeah, stay tuned for those. Don't forget to subscribe and all that shandies.